And hello everyone. Good morning, good afternoon, good evening. This is our second Data Science Global Summit event 22.2, which we're doing done by our team at Geekle. And so my name is Nick, I'm Director of Events, and I have with me here today Lilia, who's amazing event manager, community manager for this event. Hi, Lilia.
Hi everyone. Nice to see you again after 6 months. So We're preparing for you a lot of interesting information, use cases, and best practices from best speakers. So I hope everyone will enjoy that, and we also.
Yeah, me too. And so yeah, we already have people writing in the chat. So please write where you're watching this from. And like most of the people writing good morning, so I guess it's morning too for them. And yeah, so I'm gonna say that yeah, this Geekle is a team from Ukraine, and we are right now broadcasting using generators, accumulators, and other stuff like that. But we're still decided to that we need to have this event, and because we prepared some amazing content from amazing speakers for you all today, and not also today, but we have 3 days of content. We have so many hours per day. So yeah, a lot of information for you. So yeah, Lilia, what are the general topics for this event?
So yeah, I also want to mention that Data Science Conference is the longest conference that Geekle organized before, because it's 3 days, not two that we always made it before, and it means that it will be more useful content. So it's great. So main topics for this event, we choose four main vectors. I mean, it will be machine learning for biotech and pharma and healthcare, artificial intelligence and social good, machine learning, and other aspects, data visualization and big data analytics. So our speakers will tell you about every topic, and they will describe you many last updates in that sphere from this year and previous years also.
Yeah, and so we have like more than 2,000 registrations for this event, and so we expect people to be joining throughout the day. And of course, this is a free junior level day, but we'll still have two much more advanced days. And so yeah, we will have not only as always as on our all events, we have not only just talks and sessions, we also have Q&As. So prepare your question. That's why we have speakers live for you today, and you will be able to get answers for your questions. And for the most active attendees who will be active during Q&A session, we'll also have 5 free tickets for tomorrow and for Thursday. They will be distributed randomly. We'll choose the winners and send you tickets later this day. And so basically we have 3 blocks of talks per each day. After the end of the block, we'll have a Q&A session. And so today we have uh, like like 11 topics, and in general we have like 34 for the entire event. So many, like yeah, as Lila said, so many, so long. Well, we used to be doing 3-day events before, but now we're doing 2-day events, and data science is definitely so big and so many topics that this is also a 3-day event for us. And yeah, so as I said, tag to in the chat, and we have Q&A tabs. And if you're watching this on our platform, and if you're watching this on YouTube, there's a link to a platform in the description of the video. So I would recommend you watch from there. And the recording of this will be available later at the event. You'll be able to watch it with the same link, so don't worry about that. And so yeah, let me just see. Yeah, people are already writing where they're from. 6 a.m. in Chile. Wow. So yeah, Lilia, what do we have?
So yeah, it's very impressive that people at 6 a.m. join us. I'm very happy for that. I want to mention also that if you will have any question or suggestion for us or for our speakers, please let us know, chat with us. We'll be happy to communicate with you and let grow our community. So, I also want to mention that today we will have one workshop. It will be during our sessions. It's a great opportunity to know more knowledges from data science, and also we will have one workshop after that event, and we will make announcement between our blogs, and you will get more information about it. And also, if you will have any, I don't know, concerns, or for example, you would like cooperate with us during this event, also communicate and chat with us. And I think we are happy to start.
Yeah. Like Lilia said, feel free to reach out to us either on info@geekle.us or just find us on LinkedIn. Well, we are open to any ideas, and of course, we'll be sending feedback forms at the end of the event. So also, please fill those. Okay, without further ado, let's introduce our first speaker and first block for today. We'll start with some big data analytics topics, and we have our first speaker, who's Jesse Anderson. He'll be talking about foundation of data teams made simple. So let's welcome Jesse to our stage. Hello, how are you
Hi,
doing today?
Jesse.
Thank you for having me. I really appreciate it, especially in spite of everything.
Yeah.
Thank you. Thank you for joining us. I'm very happy to see you here.
Yeah, I guess the stage is yours, so you can start with your presentation. Here you go.
Excellent. Well, thank you, everyone. We're going to be talking about foundations of data teams in this session. And let me help you understand why we need foundations and why we need to disclose any problems that happens. Disclosure means tell somebody why you need this. Then we'll talk about the data teams themselves. And finally, we'll round it out by talking about the implications of this. So we're often implicit in what we want. We're often implicit in saying we want data science. We want big data. We focus on that exterior thing that's cosmetic. And if you look there on the right of the slide, you see this beautiful area in Italy, and you think, okay, I want to live there, and how do I do that? And maybe you've already selected a house. I've selected the house that is kind of a purplish color, reddish color, and I say, I want to live in that house. I bet that has an amazing view. So I'm kind of focusing on the exterior, the cosmetic parts of that house. But what I'm not doing is I'm not saying, I hope that house doesn't fall down that cliff and kill me, for example. I hope that house doesn't cave in on me and kill me when I'm asleep. We're implicit about safety. We're implicit about saying we want those things. We want those things to help us. We don't want to be unsafe in there. We just focus on, I want that view and I love the color of that house. In a very similar vein, our houses are the value that we create. So that's the value that data creates. That's the house. And who constructs that house? Well, in our case, it's the data teams. Those data teams construct that house. Now, how do they do that? We're going to talk about that in a second, but suffice it to say, our data teams have to construct these houses. And if we skip either of these steps, well, we're going to have a problem. So talking about that facade. So our focus is often on the facade, the thing that is in front of us. Usually that's an analytic, and artificial intelligence, it's some VP, some vice president, some CEO saying, oh, I read about AI and it's going to change my business. I just want it. So there's that focus on the facade. So if you've never seen a movie and you've ever wondered what's happening behind there, well, this is what it looks like behind an exterior, a facade. So there's nothing. You see Pete's joke shop here. And if we were to look at it with a camera from the outside, that would look like a regular house, a regular joke shop. But if you look behind it, there's nothing there. There's just this facade. Could you live there? No. Could you have a business there at Pete's joke shop? No. No, there's no possibility for us to actually create any value with Pete's Joke Shop. It's simply a facade. And that's often what's happening to us is we're so focused on models, we're so focused on AI that we forget the rest of it. We forget the data. We forget the infrastructure that we need in order to do this. We forget the people that we need to have this. So this is really key, where this is a big reason why teams fail. They focus on the facade. So you might also be wondering about whether data teams need foundations. Sometimes especially new companies will ask me, Jesse, we're going to create this data team. How long do we need it for? Is it this 3 months? Is it 6 months? And the answer is they need to be there for a long time. And this is part of why data teams need foundations. It's because we are going to create a foundation that these data teams will sit on for a long period of time. Once a data team is established in a company, it continues on for the life of that company. It is not a one-year thing. In a very similar vein, we see this building here. It's called a yurt, and that is a building that is specifically made to be nomadic. It's for a nomadic people. And so what they would do is they would put their house together and decide if they, at one point, they want to move. Well, they just pick it up and move. There's no foundation to this house. There's no concrete underneath it. There's no wood underneath it. It is made to be transportable. So in many ways, excuse me. In many ways, we have our executives thinking that we just need a yurt like this because the data team is just going to be there for a short period of time. That isn't the way it is. We actually need a solid foundation, and we'll talk about that solid foundation in a second. Other times people think that adding data science and AI is just this simple, easy renovation, that you just kind of look at the organization, you plop a data scientist in there, you hire that data scientist, and all of a sudden you have AI coming out your ears. And that really isn't the truth. As you can see here, we have this renovation. You can count the number of people that are part of that renovation. Maybe somebody said, oh, that renovation is going to be easy. It's just the outside of this, and we don't have to go deep. And that's really a big problem. That's really a common problem where the management thinks simple, easy renovation rather than, oh, adding this advanced data analytics, this AI, this machine learning, we actually need much deeper. We need to go much deeper than this. So now let's talk about disclosure. So in the US, where I'm originally from, there's a law that says if you sell a house, you have to disclose all the problems that you know about it. And you can actually see that form there on the right. That's a screenshot of it. And it's called the Seller's Real Property Disclosure Form. And you can see there on the bottom right some of the things that you have to say. Is there a problem with the electrical system? Is there a problem with the plumbing? Is there a problem with this and that? And so you actually have to say that as you sell a house. So when you don't say this, also called non-disclosure, there's a bunch of legal problems and there's monetary implications that you can see in there. In the form, it says if you don't fill this out properly, there's going to be major problems. You can get sued. You can have all these various problems. So now the question comes up when we have a problem is whose job is it to disclose to you that we need or we have a problem in your team? Is it a vendor's job? Is it management's job? Is it an individual contributor's job? Is it a book's job to tell you? Whose job is it to disclose that you have a problem? If somebody sees a problem in your team or in your organization or company, whose job is it to tell you there is a problem there? So let's kind of go through them. Vendors usually don't want to tell you this because they're trying to sell you something. If they tell you, oh, you have a problem there with your team, you're missing data engineering, then you say, oh, I need to go spend my money on data engineering, not your product. So vendors won't tell you. In fact, vendors will tell you the opposite, as we'll talk about in a second. Is it management? Management often doesn't either know this or understand this. They've been really pushed by the media that data science, AI, machine learning, you just hire a data scientist and out comes all this machine learning. So they often don't know. Is it an individual contributor's job? Well, it's quite difficult for individual contributors to do this because they have to push upwards and they have to say and convince their management, hey, we're doing something wrong. We actually need to do this. Or books. We also have books that talk about it, but most books are just focused on the technical. They're just focused on this technology. They don't say, here is the sort of person you need for this. So it's a key part of, there's this missing disclosure that's happening within the industry. So that gets us to some of the marketing push that we've actually seen from vendors. And some vendors are deliberately misleading in their disclosures. They say things are easy. You just use our product and we will make it so easy that you can just plop, you can just have that AI. You can just have that machine learning. Just use our product and it makes everything easy. And the reality is they're misleading. It isn't easy. That technology may make something easier, may make a certain part of it, a very specific part of it, but it doesn't make the whole thing easy. And that's really where we need that solid foundation, because the management, the company, they hear easy and they don't think, oh, we actually need to put some effort into this. So it's really, really key that we go through and understand nobody is actually trying to go through and say, here is the problem. Here is why we need to do this. Here is what we need to do. So now let's talk about what should be happening with our data teams. Here are the three data teams. We have data science, data engineering, and operations. A question sometimes people ask here is, okay, well, I see three teams, but which one is really the one that's important? Which one is the one I really need? And the reality is you need all three of these. Each one is equally important. Each one does an important job, does a specific part of this. And we'll talk about what each one does in a second, but it is very key to say, if you are missing one of these teams, there's going to be a problem. To say one team is all you need, that's a big problem. Most common here is missing, just having data science. So let's talk about what that looks like. So without data science, let's imagine we had a company and there was no data science. Well, here you can see in this picture, there is a foundation. Yes, there's a foundation for that building, but there's no value being created. Nobody's going to live there. It's completely abandoned. So in many ways, data science, the way I explain it to management, if they don't understand it, is they're really that cherry on top. That's the expression we use in the US of they're the pinnacle, they're the eventual result that we want, where as a result of doing this, getting all this data, making sure that that's all ready, we're able to create this artificial intelligence and AI, that machine learning, and that really is the pinnacle of what we can do with data. I go so far as to say, if we aren't doing AI and we're doing all this data, then we're really missing out. As you can see here, we might have all this data, we might have the best data in the world, the most interesting data, but if we aren't using the most advanced methods, then we're not really using it to its fullest. In a very similar way, if we don't have data engineers, what does that look like? Well, this is probably one of the more common things, is that a company will just have data scientists and they'll have no data engineers. This is exactly what it looks like when I go in to work with them. There is an issue where they've gotten to a certain point. They've arrived and they've said, okay, we're going to make this data and we're going to make this data infrastructure. But the data scientists don't really understand the engineering that they need to at the level that they need to. And so they built this house, but they didn't understand the sound engineering. And so it just crashes, it crumbles. And this is often what it looks like when I come into these companies to consult, that they've gotten it to a point, but it just crumbles every single time. They'll try to build it, crumbles every single time. You absolutely do need data engineers to have that sound data engineering. So here we have what happens if we don't have our operations people. Well, we can see this really clearly in the picture. That place it's not crumbling, and somebody could live there, but nobody wants to live there. And that's really what happens when we don't have our operations team. There's no operational excellence that says the business can rely on this to be to not be messy, to not be neglected. The operations team makes sure that we can live there. They keep it tidy, they keep it neat, they keep things running. And this is probably what happened at this place. Over time, nobody lived there. So now nobody wants to live there. And so it is key that we have our operations team making sure that the data, that the products, that the infrastructure is all running well so that the business can actually rely. And that's often what I hear from the business people when I come in and consult at these places. They say, we can't rely on the data products. We can't rely on the data quality. We can't rely on the infrastructure being up. Those are big problems. So now let's talk about our implications of this. What are the implications of our foundations? So here we have a picture, and look at that picture closely. You may not be in construction, but you can see there's a great deal of effort and there's a great deal of money being spent on that foundation. And the reason there's so much effort and money being spent on that foundation is because there's going to be a really tall building built on top of that. So here, if you look closely, you can see that there's a lot of rebar, there's a lot of construction people walking around. There is a ton of effort going into this. So here, when we go to establish a data engineering team, if we go to establish our data team, it is far, far better to build on top of a solid foundation beforehand, and then, only and then, do you make the tower, the rest of the building. You spend a lot of time on that foundation, you get the foundation exactly right, and then you build. So it's far easier, far cheaper to do that, even though they're spending probably tens of millions of dollars to get this foundation right. It is so much easier to do it right from the beginning. So what happens if we don't build a solid foundation? Here's an example that we have, an actual real life example, and it's called the Millennium Tower in San Francisco. And you can see the pictures there, and as it was being built. Well, if you don't do it right from the beginning, if you don't build that solid foundation, you're going to have to go back and fix it later. And it's going to be far, far costlier. Here's that real life example. Well, the tower itself cost $750 million to build. However, they didn't build the foundation right. The foundation is actually leaning. So this building is leaning so much that people are worried it's going to fall over. So it's got some really big problems to it with the foundation. So here we have our Millennium Tower. They're getting sued for $200 million. The actual fix is going to cost $100 million. So substantial amounts of money. And then I read recently that $100 million is actually not the correct anymore. It's probably going to be $200 million. So by not doing it right the first time, you can see that it's going to cost almost probably 60% of what it cost to build initially, because they didn't do the foundation right. Do the foundation right, and then you will be able to build on top of it effectively. So now let's apply this more correctly or more directly to our data teams. What does this look like when we have our data teams? So I've created a graph here, not really super scientific, but it's very much based on my experience working with data teams around the world. And so we have there on the left velocity. This is how much the team is able to produce, how the complexity that they're able to do, the speed with which they're able to do it. And there on the bottom, we have time. So over time, as the team gets more and more maturity, more and more ability to do things with it, more and more time has gone by. So this is what it looks like. We have two different lines. We have one, the red one lacking a foundation, and the blue one with a solid foundation. So let's go through the one where we're lacking a solid foundation, that red one. So what those teams look like is that there is this buildup. There's this buildup of they get to a point, and then they just come crashing down. And then they build back up again, and then they come crashing down. And this is exactly what it looks like. Those teams get to a certain point where they can't handle the complexity because they're missing somebody. They're missing data engineering. And so there's this constant roller coaster of productivity, of velocity there. And this is exactly what it looks like. You may be in a team right now where this is happening. It's the roller coaster. And in these roller coasters, those teams are at risk of either getting canceled, getting fired. There's big problems with that because those teams, you're spending a lot of money, but you don't have the right foundation in place. Now let's contrast that with a team that has a solid foundation, the blue line. So what will happen is those teams will gradually ascend and hit a plateau. And that plateau is okay. That's where they're kind of congealing, making sure that they understood what they are trying to do, learn new things, try to shore up and make sure that all the code works well, all the infrastructure works well. And then on the next, once they've gotten past that plateau, they will then ascend more and plateau and ascend more and plateau. And this just keeps on happening. And as if you were to compare the areas or the amount of work being done between these two, the solid foundation team gets far more work done because they're not on that roller coaster. They're not going up and down. They're plateauing, yes, but they're always making progress. And that's the key there. When a team has a solid foundation, they can build on that, get to the next level, build on the next level. If you're in a team that's doing this, that lacks a solid foundation, there's some big problems and you will need to fix that. So this is where we get into the question, an ounce of prevention is worth a ton of cure. So when we look at this foundation here, they're going through and they're jackhammering out the concrete, they're taking it out, they're going to redo it. So it's always possible to go back and fix things. I know I've done it with large organizations. So it is possible. It's costly, but it's possible. So one key thing, one big point I want to make to you all is that if you are in this situation and you're saying, oh, that sounds like my team, these problems do not right themselves. Put a different way is, it's not going to be a year later and you'll have worked this problem out because it just kind of happens organically. That doesn't happen. It only with concerted effort do you fix these foundational problems. It's going to be costly, but it's going to be worse a year from now, even worse 2 years from now. It just keeps on getting worse. And so this is where the ounce of prevention is worth a ton of cure. The expression is a pound of cure, but in my opinion, with data teams, it's a ton of cure. It's a significant amount of weight. So with that, you might be wondering, how exactly do you create these teams? What do you do? Well, I've written a book called Data Teams, and I go through the 3 teams, what those teams are, how they interact with the business. You can go to datateams.io to read the book and understand that more. So with that, a big thank you for attending the session. I really do appreciate you doing that. And if somebody puts a question in the chat, I could handle that.
Yeah, thank you, Jesse. Thank you for your presentation. It was very interesting. So feel free to ask questions for Jesse, and I hope that you will join for QA session in the end of this block, and we could make a conversation with other speakers and discuss everything together. As we have a few minutes till starting the next session, probably our next speaker could join us now. Ahmad, are you here? Okay.
Yeah.
Hello.
Hello. Good morning, everyone. I was attending the session with Jesse, and that was really informative. So yeah, if you want to start now, I'm ready.
Yeah, thank you. Thank you for your joining us today. So now I'm happy to present Ahmad ElShiekh. It's a data operations lead, and he will tell us about comparative guidebook on data and shaping industries. Ahmad, the stage is yours.
Thank you, Leah. So good morning, everyone, or good day, according to your time zone. Hope you are doing great. So like today, I want to talk more about data shaping industry. This will be like the name of the session for today. So just to walk you through quickly, who am I? So I have worked in the software field for a while, and now I did initiate or founded a firm for data analytics and consultancy that's called BoostNetic. And I'm working also in the content understanding operations team at Scale AI. Okay, so first of all, the abstract. So why we are like holding this session at the beginning. So because of data like started very vague at the beginning, and right now it's having a huge impact on almost all of the industries. So aside from IT and like the tech community, in the rest of the industries, data have been like super impactful and providing a lot of boost to different companies. So to walk you through like the comparison between data and oil, for example. So if you asked someone a couple of years ago, what do you think about like the most valuable asset on Earth? So most probably they will consider oil. Like the energy sector has been huge for almost the past 100 years, but right now, it's no longer the same case. It's the data, the information. Everything related to that has become the next big thing, or like the big thing of today's time. So quickly across our agenda for today, we will have first we'll talk about the data rising, where the data science like naming came from, and then we'll go through the analysis, modeling, and types, and the business intelligence afterwards, and industries use cases, and what's the digital transformation that we hear a lot and that like my company is actually doing, and how to get seated in the data field. So starting first with the data rising, the data science term wasn't actually new, because like a lot of people might consider that data is like a very new term or like a niche market, but the term data science was actually traced back to 1974 when Peter Noor proposed it as like an alternative name for computer science. And I can see this is like being super accurate. So the data science, or like the data in general, consists of 5 stages life cycle. The first one is the capture, where you will do data acquisition, whether you will be purchasing this from like someone. For example, we have data firms that do sell data, or if you are working in a specific industry and another company do have data, so you will be acquiring this. That's data acquisition. And you have the data entry to, of course, like add this into your database, and you have the signal reception and the data extractions, etc. And the next part of the cycle, or the next stage, will be the maintain, to do the data warehousing, where you're going to store this data. Basically, this is like the job title for the database administrator. And you have the data cleansing and the data staging and data processing and data architecture. Next stage will be the process. So you will need to process this data. So you have the data mining, the clustering, the classification, and the modeling and the summarization. And afterwards, you have the analyze, or you will need to analyze this data. So it will be the data reporting, the visualizations, and the business intelligence and the decision making. So more on this like later across our session. And lastly, you need to communicate. So once you have done every single stage of this life cycle, you will need to communicate this. So this is will be the last step in the life cycle of data. Okay. So to the next point will be the analysis, modeling, and types. So we have basically 4 analytical model that they are like the most common and most used right now. So the first one is the descriptive model. This is being like the simplest form of a data analysis or data analytical model. So in this, you will make sure that you understand what happened in the past by using the past data. So you have like basically a data, and you will start doing like a descriptive model on this. The second one will be the diagnostic. In the diagnostic, you will try to understand what's the reason of this, like why this happened at the beginning. Okay, so this is like basically understanding the analytics and doing everything to know what's the cause of the matter or any like action that happened. And the third type of analytical model will be the predictive model. So in a predictive model, you will try to understand what will likely happen in the future. So this is a little bit more complex. And again, in the predictive model or the predictive analytical model, uh, as the deeper you dive into time, the more vague it will be and the more complex. So for example, if you are doing a predictive analysis model for the Q1 of 2023 in like a company selling clothing or apparel. So if you are doing the analysis on Q1, it will be solid information, and most likely this predictive model will be like a trustworthy. But if you are trying to do the same for Q4 in 2023, it will start to be very vague, and the data itself, or like the insights you are getting from the data, will not be very trustworthy. And lastly, have the prescriptive model. So the prescriptive model is the most complex of them, and this is like using all of the machine learning and AI like artifacts we can see at the moment to understand different perspectives in this data. So for example, I want to understand if this happened, what could be the end results, and if this perspective happened, what would be the end results. So it's more of a simulation. So this is the most complex type of analytical model. And in this graph, this is like a very simple graph between the value and the complexity of the analytical model. So the descriptive, as we mentioned, is one of the simplest, and ending with the prescriptive being the highest in complexity and the highest in value, of course, because it's very insightful. So moving next to the business intelligence. So business intelligence is a term that often being misused with the data science or the data analytics. So business intelligence have been derived from the concept that most of the managers or the stakeholders with no information would do disastrous decision at the end. So in this case, the business intelligence like have initiated to provide the stakeholders and the managers with insightful like information or details that the decision makers could utilize to base their decision on. Okay, so we can see here like a very simple comparison between data science and business intelligence and what's common in between of them. So in data science, for example, the time focus of the majority of data science is the future. It's more explorative, and it's low on automation, and also the business drive is planning, and it's based on hypothesis testing. Okay. On the other hand, the business intelligence, it's more time focused on the historic part. So it's more of a descriptive analytical model, we could say, and it's in a high automation rate. Like a lot of these processes should be completely automated to just facilitate the process on the people. So no one would love to sit and do like a huge job of data entry and then taking the insight, etc. And the business driver here is the decision support and also a trend identification. We want to know what happened, what's likely to happen, etc. Okay, so moving next to the industry's use cases. So in the industry's use cases, sorry, I guess this is a slide shouldn't like be with that title, but no worries. So these are the softwares that you more likely to use with the business intelligence. So first of all, you have the spreadsheets. So spreadsheets are very common. For example, the Microsoft Excel, the Google Document, and also the Power BI tools that Microsoft do provide. And then you have the reporting softwares. So the reporting softwares is the way to organize and filter and report and display your data. And you have next the data visualization. This is the key differentiating part in the business intelligence, taking the fact or the concept that also stakeholders are not very numerically oriented. So if you are a data analyst in a bank, for some instance. So in this case, if you are proposing like a new feature in an application or something to your product manager, it's better to do this on a data visualization on how everything should like happen in a graphically appealing representation. So this is more likely to get accepted than providing just the numbers. Okay, so that's like the importance of the data visualization. And afterwards, or lastly, you have the data mining tools, and this is like how you could collect like data patterns using machine learning also, and statistics and artificial intelligence, etc. So moving next to the industries use cases. So what industries would utilize data nowadays? So again, we are just were talking at the beginning about data in general and the business intelligence and how, like, what's the concept of the two, and now in the use cases, like what's going on in the market right now. So what's going on in the market, that the first industry that adopted actually data science was banking and financial industry. So they use it in the risk assessment or the risk analysis, that they can take the data, for example, for like a company that are asking for a loan, for example, they could do a risk assessment using the data and using like a descriptive analytical model, for example, to understand what happened in the past with the loans of this company that's asking for a new one, and they can predict when they can pay off this loan at the end, or pay out this loan, for example, and what should the process be. So it's more of a key feature right now in the banking and financial industry to have data related positions. And yeah, a lot of data scientists actually exist in the financial industries nowadays. The next industry we will go through, which is the media and the advertising marketing. So definitely this has been one of the popular right now, because whenever you are using a free software and you are not actually paying for this service, so how the team would actually earn money or like succeed and complete their business model is through collecting your data and then using this in the advertising or even selling this out. So again, remember the data acquisition at the beginning. So yeah, we could be using like a free software. And again, I'm not saying that all the free softwares are doing this, but again, it's all about the business model and how the software company or like the product team is actually doing it. What is their business model? Maybe they are open source and they are not collecting any data. Maybe they are collecting data and they are telling the consumer when they are agreeing to their terms and conditions. Okay, so we have here an example, like for music platforms, especially like Spotify, would actually make a very useful use case of data in this case, that they will collect and analyze the data anonymously, and then they will use this data to give you a better music recommendation. So you maybe will not be feeling this, but it happens everywhere. So for example, if you are doing like a search in Google, and afterwards you see something related to your search keywords or your search results, it will be the back end work of Google doing analysis for your data and understanding everything. Okay, so the next part is the healthcare, and this is like the useful of them all. Like this is like really good industry to use data, because science and medicine, if they like if you merge them together, or I'm sorry, data science and medicine, if you merge them together, you could have a magnificent results at the end. So health sector is actually doing this to improve like the patient care data and understand what's like most probably to go on. And this is all of using a wearable. So if you have a patient with like an atrial fibrillation, he can like hold a wearable, and the wearable will be detecting the heart rates across the day, and then doing a algorithm with the data collected, and then provide the end results to a doctor or to the patient himself, or anyone that could take control of this to understand if the patient would need more attention, would need like a change in the medicine, for example. If there's an emergency, they need to take him to the ER room, etc. Okay, so this is all about like the healthcare. And next you have the government. So government is actually started right now across all of the world to adopt data science, because they understood the value of data, and they are using them in everything. So for example, a environmental protection research and energy exploration, especially in the energy sector. This was very new to have data science. I come from like an energy engineering background, but the energy sector was a little bit behind on adopting this, especially the oil and gas. Right now, they are taking this to the extreme, because they see like the current situation in the world with the fossil fuel and how we need to protect the earth from everything. So they started to adopt data science to minimize the impact of fossil fuel and search for another options or sources of energy that might be more safer to consume. And also, for example, we have here that the FDA would utilize the analysis pattern for the food illnesses and disease. And this has also have been utilized in the COVID-19 when the pandemic impacted like the whole world. Government actually started to use the phones that we hold each and every day to understand if someone has been diagnosed with COVID-19. They will make sure that if this phone contacted with someone who have never gotten like COVID-19 as 100% healthy, they would notify that person. So please go to the nearest hospital to do like a check and make sure that you are absolutely fine, because you may be caught the virus from this contact, because the two phones actually happen to be in contact, like they passed each other in the street, for example, or in a cafe or in a bank or anything. Okay, so that was a very useful use case of data in that particular sector. Next, in the manufacturing. So the manufacturing of everything, data science has been like growing more and more footprint in that industry. So the production processes to like how the manufacturers would collect data to like increase the efficiency and the performance of the production lines and the machines, and how to like increase the speed of production if they are selling goods. So that will depend on the throttles they apply on the production lines. And all of this come from data being collected and analyzed, and the insights that have been provided to the decision makers. Lastly, we like not lastly, but we have the tech startups like us, like BoostNetic. We are actually taking like tech startups are taking like a beautiful approach of the data, and they are offering a very focused data services for companies that they will not willing to integrate a team of data engineers and scientists and operations in their like business model, so they can outsource this. So we come to provide, like, for example, consultancy services on data and doing the analytical model ourselves, and all of this like to be outsourced completely out of the company, and we just provide the insights at the end to decision makers. So that's on the tech startups. And lastly is the retail. And of course, like in the retail, if you went to any one of the e-commerce, in any of the e-commerce platforms, and you try to purchase something, the next thing will be a recommendation to purchase the next thing that would you most probably would like. So for example, if you got like an iPhone, a e-commerce platform would recommend getting an AirPods along with that, or like getting an Apple Watch, etc. Okay. So now moving to like the pyramid of like the data structure. So at the top of the pyramid, or like the end results we're aiming for, is an AI with the deep machine learning. So why we are handling a lot of data, we got like whether we want to provide insights or we want to create a deep machine learning model that we will keep feeding data. So in the future, that machine learning model will be able to perform, or that artificial intelligence would be able to perform these processes on his own without like any human interaction. So at the top, we are aiming for the AI, and this is the main job description for like a machine learning engineer. And below that, we have the data scientist and the data analyst, that they will make sure that the segmentation, the analytics, the aggregations, and the training of the data is good to go, and also experimenting with different algorithms, etc. And below that, we have the data engineer. So the data engineer providing like a reliable data flow and the infrastructure and the pipelines, and making sure that the unstructured data storage is there and the structured is there as well. And the base of this hierarchy would be the data infrastructure engineer. If that like collapsed, everything above will collapse. And yeah, and again, you can see here very similar to the 5 stages life cycle: the collect, the move and store, the explore and transform, aggregate and label, learn and optimize. So this is the life cycle, the 5-stage life cycle for a AI model, more focused data approach. Okay. So next we have the digital transformation. So we hear digital transformation a lot. So after we covered everything right now about the the data structures and how the data science and the business intelligence would compare to each other and how they would impact different industries and what's happening right now, we come to the digital transformation. So the digital transformation, from the name, it's taking like this old and boring processes and modify it or create a brand new process for a business or for an industry to make sure that it will meet like the new challenges and the market requirements. So in the digital transformation, you can see here the industry 4.0 graph would actually explain everything about it. So you start with the technology, you have the data also, you have the process, you have the organization and the governance and the security. So if you meet all of these six main pillars of the digital transformation, you will have it like a perfect and smooth digital transformation from an old process to a completely digital process. And again, doesn't mean that if a company did a digital transformation, they will let go of the people. Actually, data and the digital transformation is the empowering the people. So instead of letting the people do all of the boring work and the like very standard job tasks, they will be more focused over something that's of a higher priority. So they will try to give more insights. They will try to overlook what's going on. They will basically do the governance portion over like an AI model that has been running for a while. So again, the six pillars: security, governance, organization, process, data, and technology. Meet all of them, you have a 100% complete data transformation. And again, so the system of intelligence in the data, in the digital transformation using like data. So basically you'll be able to empower your employees, engage your customers more and more, and optimize the operation and transform your product. So you will need to do any one of these. Digital transformation will definitely be the way to go. You need to cycle in digital transformation first. And lastly, I would love to talk about like the core values that would thrive you in the data field or will get you seated in the data field. So the first is an analytical eye. Just please remember that programming languages and like analytical models and everything else, it's just a tool. So if you do not know what's the aim of this tool or what's the purpose of your job, you will never be able to achieve anything. So just first of all, make sure you understand it and have an analytical eye of this, what you want to actually spot on, or like what's the trend you are looking for, what do you expect at the beginning, and then you would start using your tools to get to there. So if you give someone like a drill and you told him to make a hole, he could like make a building collapse if he's not aware, not oriented, and not aligned. So, but if you give him a drill and told him that you want to like hang a painting, he will go ahead, yeah, and make a very small hole and then add like a screw and then you can hang your painting. So this is the purpose of this. And next is the trend understanding. So you need to understand the trend and what's going on. So right now you did like a predictive analytical model and there is a trend that there's something will increase. You'll need to understand if your data is actually trustworthy or not, if it was like cleaned or not. So the source of data is very important. As we mentioned, like at the base, the basics of the data science is where you collect your data and gather your data. So if this is infected, all of the model will collapse and you will reach nothing. But just having a very clean and a very structured and spending a reasonable time on processing everything and cleaning this will get you a magnificent end results at the end. And any trend you would like produce from this model will be super reliable. And next, you need to have industry awareness. So right now, data is not anymore related to a specific like techie industry. You could be a data analyst or a data scientist working in any of the industries we talked about. And to do this, you'll need to be very aware about the industry. So for example, if you are working in like retail, you need to have a solid principles of how the retail works, what's the channels you are selling in, and etc. And then you start learning data and joining the data field, you will do great. Okay. The next two things are actually essentials in every single job, which is like to first of all, have like a clear mindset whenever you are working in a data related task, because if you mix something, you would like completely damage everything across this. So you will need to make sure that you are having a you'll need to make sure that you have like a very clear mindset on this. And next, the communication. So communication is super essential. If you spot it like a trend and you didn't communicate this, it would also get you like the end result of the complete structure of your business being shattered. You need to communicate every single thing with your team, and this would fall back into like the we could say the project management processes. So if you are working in a waterfall, working with the Scrum, these are more related to project management. So let's like not deep dive into them, but I mean your team is really essential to be communicated with all the updates. If there's like any blockers, if there's a fires, there's escalations, you need to communicate these things with your team on the spot to make sure that you avoid any misalignment or anyone doing something that he shouldn't do or doing something completely wrong. Okay. And lastly is the critical thinking and logic. And this is more related to the data position with decision making. So if you are like operations lead or anything, you will need to understand what's the whole process, if you should actually go ahead and provide this insight or not. This will all depend on your thinking and your logic. So is that like a good thing to do? Yes, go ahead, please, and give like the stakeholder your insights. If not, you would rather like redo something or change something in the process in order not to completely like miss everything up. So yeah, that was everything on my plate for today. And yeah, please, if you need to ask a question before the Q&A session, go ahead. If not, we can meet in the Q&A session.
Yeah, thank you very much for this amazing presentation. And we're a little bit earlier from the schedule, so maybe you can add something like give some recommendation on literature or resources. Where can people get more information about all this?
Yeah, sure. Recently we had the very famous website 365 Data Science. This is again like not sponsored or anything, but they had the complete courses to be publicly available for free. And right now they are doing like a really good discounts for people that are willing to start on data fresh. So you could go there and double check for the courses. They have different tracks. And again, for folks specifically in Egypt, where I come from, we have this initiative, that's the Forward initiative. You could go ahead and also sign in at like the Dasti website. You will get like 100% off, fully sponsored by the country, to be able to also join a track if you are willing to join data, whether you are aiming for like a machine learning title or just like sticking in the data itself or the big data. You would definitely join that. And like the internet itself, like right now, this is like very great thing for Generation Z and the millennials, that we no longer need to get like a college degree to do our job. It's more likely of what value are you going to add to the industry or to the place you are joining. And this value you're adding will completely change like the employer perspective on you. You maybe do not have a degree, but you are really good at doing this. So they definitely will hire you. And now we can see most of companies are changing the processes. You are no longer required to provide like a degree or something. It's more over the like personal assessment on what are you looking like a person. So are you like polite with your colleagues, you are respectful, you are good at the workplace. So that's it. And also a technical test to test like your technical knowledge and how you communicate everything, and that's it. So if you have these two things, you are good to go. You can go ahead and actually apply for one of the big names. And lastly is like before thinking like to do anything, just go ahead and double check for someone who did it before. and try to ask. So networking, just make sure you are having like a very solid network. And by networking, you can get free mentorship, which is like the privilege of knowing a lot of people or being in different social circles. So this will help you a lot. If you are hesitant about something, you can reach out to a professional, for example, and ask, hey, this is me. I want to just ask you a question if you have time. And you go ahead and ask, and they will definitely help you with this. So yeah, that was like over for like the everything.
Yeah, thank you. Like, I'm sure this works not only in your country, but in general, like data science and data analytics is still like it's like out there on the like on the front lines, and it's like, yeah, it's where not people not getting degrees, people are actually making and creating more and more stuff that other people will be learning in a few years from now. Okay, yeah, thank you very much for joining. We'll get back during Q&A session. I think we'll also start a little bit earlier, so please join a bit earlier. Okay, yeah, thank you for giving your presentation. Yeah, see you soon.
Thank you, Nick. Bye.
Okay, I think we're gonna have a short break before we start the next video because we're really running earlier, so we'll give you a chance to stretch your backs, grab yourself some drink, but please get back. And before we'll have this break, I want to give some information about the workshop that we mentioned during the intro. So first of all, tomorrow during our senior track, we will have a presentation by speaker Pete Fain. He'll be talking about data engineering for data scientists, so giving how to get into data engineering. And he will also be doing workshop on December 1st. That's about data engineering from notebook to production. So like this is going to be like a 3-hour workshop or even 4-hour workshop that will basically you will learn how to get into data engineering. So some brief information of that, and that this is going to be a high level introduction. It's like a fast paced survey course. You'll learn how to take a data project from prototype to production quality data platform. And so like this is kind of essential if you want to get into this area. So I'm going to pass the link to the workshop in the chat, and we're going to have a short break for 5 to 10 minutes, and then we'll start. We'll go on with our next speaker, Ricardo. All right, let's get back on track. So we had a short break, but yeah, let's get back to our sessions. So we have a next talk presented by Ricardo Galante, who's presenting for the second time at our data science event. And so he's a senior advanced analytics customer advisory at SAS Institute. So he'll be talking about patterns and use cases on demand forecast using machine learning. So yeah, the next two sessions will be about machine learning. This is going to be a pre-recorded, but we'll still expect Ricardo to join us for the Q&A session. Okay, let's start the video.
Hello, everybody. It's a pleasure to be here with you at this fantastic event, full of interesting and extremely useful presentations. My goal is to share with you a little of my experience related to this topic, machine learning applied in demand forecast. But first, let me introduce myself. My name is Ricardo Galante. I am Brazilian and I live in Portugal. I am a statistician and I work as a senior advanced analytics customer advisor at SAS Institute Portugal. In parallel, I am also a professor of data science at Lisbon University, where I teach master's and undergraduate courses. I also leave my email, LinkedIn, and Twitter contacts here. And if you want to get in touch with me, feel free. To be more didactic, I divided my presentation in 6 blocks: planning, demand forecast using machine learning, SAS via, demonstration, and some takeaways. Let's start our presentation talking a little about planning. In general terms, when we plan something, whether in our personal or professional life, The path is calm, linear, and predictable. However, reality is different. The path that seemed stable turns out to be quite different and full of different and even unexpected situations. And this is the difference between expectation and reality. In fact, we cannot change the reality that surrounds us, but we can be more assertive if we manage to envision what will come in the future. If we think on an industry like manufacturing, it's even more important to be able to anticipate results and predict scenarios. As you know, the manufacturing industry is where goods are produced in large quantities after processing raw material into more valuable products. In this context, we need to make as few mistakes as possible and be able to predict future situations. In this industry, the impact of poor planning can be very high, causing huge losses in both people and finances. If planning is poorly done and what happened is above expectations, we have problems such as excessive inventory, inventory hold cost, reduced margin in business, for instance. On the other hand, if the planning is poorly done and what happens is below expectations, we have problems such as higher product cost or lost companion product sales or even reduced customer satisfaction. To avoid these problems, it is essential for business success that demand forecast be done in a right way and in a consistent way. But what is demand forecast? Demand forecast is a set of techniques that use historical data as input to make informed estimates that are predictive in determining the direction of future trends. In this graph below, we have the representation of historical sales being displayed by the blue dots. The yellow line is the fitted model. The vertical white line is the separation between the past and the future. That is, on the right side of the white line, we have the glimpse of the estimation of the future based on the past data. And the shadow around the model line is the confidence interval. What we do is apply the concepts of demand forecast in the manufacturing industry exactly so that we can plan for the future in assertive and in a consistent way. Here, I have listed what, in my opinion, are the greatest benefits of demand forecasting in the manufacturing industry. With demand forecast, we can improve inventory management, improve labor scheduling, maintain stock levels, optimize production planning, and improve business strategy. In fact, there are several other benefits, but these here represent the added value of doing the demand forecast correctly. But how is done demand forecast? Demand forecast is done using predictive analysis of historical data to estimate and predict the future. It could be a future demand for a product, service, etc. As I mentioned here, there are different techniques to do forecast. Among them, I cited statistical methods, market research, econometric methods, for instance. However, on this presentation, I will share with you the use of demand forecast through a hybrid approach of machine learning and classical time series models. If you check the recent academic papers, you will see that hybrids of a machine learning approach and classical time series models are among the top contenders in accurately forecast the future. As I mentioned here, classical linear models are parsimonious and performing well, but they are unable to capture nonlinear relationship in the data. On the other hand, Machine learning models such as neural network are very good at modeling nonlinear effects. So why not use both on demand forecast process? Before we go any deeper, let's do a brief review of concepts. A neural network is composed of an input layer, one or more hidden layers, and an output layer. An example of neural network with one hidden layer is shown here. Each input node has a connection to every node in the first hidden layer. Likewise, every node in the hidden layer has a connection to the node in the output layer. Here, we expanded the node N4 only to illustrate how the output of a node is calculated. My intention is to show you the use of demand forecast using machine learning through SaaS-Via platform. As I mentioned here, on SaaS-Via platform, we have several possibilities to model time series using machine learning. For example, we could use panel series neural network, stacked model, multi-stage model. But before looking at each one of these approaches, let's first understand what is SaaS-Via platform that we are mentioning here. What is SaaS-Via? SaaS-Via is a complete analytics lifecycle platform. This means that to solve business problem, the SaaS-Via platform is capable of accessing any type of data regardless of its granularity and volume. In this data ops step, the platform prepares the data using various data preparation techniques. In the next step, the platform allows us to create analysis, descriptive, predictive, and prescriptive models using simple techniques until the extremely complex algorithms. And finally, the platform has the model ops module that allows models to be stored, analyzed, compared, and governed. The entire process has a single goal, which is to transform the data accessed in the initial stage into a strategic decisions. Let's now go back to those modeling strategies that we mentioned earlier and look at one of them in detail. The first approach in the modeling strategy is called panel series neural network. Using this figure as a reference, we have the following. The input data first go through a pre-processing step where data is partitioned, transformed, and standardized, and next, extremely important features are extracted. After pre-processing and feature extraction, the neural network learns how to fit the model to the data. Finally, the output data are reverse transformed, and this is standardized back to the original scale to produce the final forecast. Let's now look to the stacked model modeling strategy. Using the figure as a reference, we have the following. The stack model uses the panel series neural network to create an initial forecast of the target variable, and then models the residual by using a classical time series approach. So the forecast of the input data and the residuals are then added together to generate the final forecast. And finally, let's see the multi-stage model modeling strategy. Higher levels of the hierarchy are fitted to the time series model. The lowest levels of the hierarchy are modeled using regression or a neural network, while forecasts are reconciled in one process. A specified level of hierarchy could produce a final forecast. So this is the idea. Use this reconciled effect to produce the final forecast. On the next step, I will demonstrate how SaaS-Via can help us to create demand forecast. On this demonstration, I will use data from manufacturing. I use this data from vehicle parts factory, from a vehicle parts factory. In this case, I have 4 products, 4 warehouses, and I have a historical of 5 years with daily information. At first, I will use SASVIA to prepare data. I use SAS code here. Then I use the SAS Visual Forecast to create models, in this case, demand forecast. And then I use SAS Visual Analytics to create business dashboard. In fact, I use this to applicate the results coming from demand forecast in a more business way. So I will open right now my SASVIA. Let 1 second. Yeah, here I have SASVIA. Okay, this is the entry point of the platform. If you go here, we can see the different areas in SASVIA. So this is nice because this show us that SASVIA is not an algorithm or a dashboard or a technique. It's a complete platform. You have the manage data, prepare data, explore and visualize, build models, manage models, build decisions, and develop code. So this is the idea when you are using SASVIA. Okay, so I came here in the manage data, and in this part, I imported the data that I mentioned before. When I came here in develop code and flows, here we can see the code that I prepared to prepare the data. Okay, here I put some information like region, latitude, longitude. I use this part to exclude some outliers. Okay, and I use proc time series to change my data, because the original data we have daily information, and to be more consistent, I changed this to a weekly data. Okay, and I used to do this proc time series, and after this I exported the data using procast YouTube. Okay, with this ready, I came here and I will open the build models. Okay, so this is the area where we can create models. Let me open this view for you. 1 second. Okay, here we have different projects. I will create very simple one, only to show you the process. Okay, I will create one called SAS forecast. Okay, here I can change the kernel. We have data mining and machine learning, forecasting, and text analytics. I will use forecasting. I will use the template at auto forecast. Okay, and the data I will use that data that I mentioned before when I prepare it using code. In this case, is manufacturing demand. Okay, here you have. This is nice because here you have the information about the data. Okay, the name of the variables. I can see like a glimpse of the sample data if you want. When I click in OK and save, here you have another project, okay, in SASVIA. Here you can see SAS forecast. Forecasting is the kernel that I chose, okay, and now he's open the project. Okay, here you have in this case we are in the demand forecast area in SAS. Okay, here we have the time series, but we have the possibility to put attributes. We have possibility to see descriptive statistics. We can put, for instance, the model attributes, the exogenous variables, and so on. And here we have the predefined events like holidays and things like that. Here we have the data. Okay, the date is recognized automatically way that is a time, the row is time, okay? But I will use the information about demand as my dependent variable, okay? And I will use the warehouse and the category as hierarchical. I put the verb by variable. In here, you can change the reconciliation level. You can change. You can specify where what level will be the most important level in the in the reconciliation process. I will use the top one, okay? And also I can put, for instance, the price as an exogenous variable. I put independent. On this part, I prepared my information to create models, to create demand forecast models. Here in pipeline, remember when we choose auto forecasting, okay? And here I can click here and change different aspects. In this case, I am using the classical time series, okay? I can use the exponential smoothing modules, Remax, intermittent demand. I could use UCMs if I want, okay? But here, when you click on the left side, you have different approaches, okay? Not only the classical ones. You have gradient boosting. You have multi-stage models. Remember, when you talk about multi-stage models using a mix of neural network and classical time series, we have here panel series neural network is the combination of neural network and classical time series, okay? So it's very cool because here you can use, and the way to work with this is very easy. I can go here and drag and drop the algorithms and put these algorithms in my pipeline. We call this pipeline, okay? For instance, I will use this and I put the stacked one here. I will just open this. And here you can, for each one of these, because this is not only an algorithm, is a strategy of modeling. So when I click here, for instance, in multi-stage model, I can select this part and set up a lot of possibilities. The feature extraction that you can use the time series, you can use regression, neural network. Remember, when you talk about this, the different stages that you can cover with this part. The stage 2, the same way, okay? The time series part, the model selection, and let me go down here, okay? This is nice because you can select the holdout. You can do this for every node that you put here. The holdout is very important. It's a very important part in the demand forecast. And this is the way I can click run. Okay, of course I can set up all these nodes, but the idea is more or less the same. Okay, you have different approaches for different nodes. And when I click in run pipeline, in automatically way, Sasvaya will compare these different nodes. I did this before. Let me open this part only for you see. I have a project ready to show you, okay? This is the project using the data that I prepared before. Manufacturing analysis. Okay, I will click here. Sorry, guys. And here you have the variables, okay? Is it more or less the same, okay? And the pipelines here. I tested for. Did you see this green ball here is represented? I ran these before, okay? And I tested different approaches. The nice thing is that when I came here, you click in model comparison, I can see the results. In Sasvaya will show us what's the best one. He put here as the champion, and the reference or the way that he choose the best one is related with these metrics here. The default, it's used the weighted map. Okay, in this case, the stacked model achieved the best weighted map in the considering the other models. Okay, so this is very nice. And here I can see for each one of them the map distribution of stacked models, the map distribution of the multi-stage model. For each model that I tested, we can see here the map. Okay, in this case for the gradient boosting, and on this case we have the panel series neural network. But one thing that I really like is the possibility. Let me show you. I will open this stacked one, the best one, and I can click in forecast viewer. This is cool because with this part you can see details of your model. Okay. So here we have the in the left side you have the levels. Okay, we have, in this case I have two categories or hierarchies, warehouse and category of products. Okay, and here we have the like it's like the behavior of your series. But in the good thing here is that you can compare different combinations. Here you have the combination between warehouse and category products. For instance, if I click here in Lisbon category 1, we will see exactly this combination in the process. Okay, and I can click, for instance, let's see, Lisbon in category 3. Did you see here? Okay, and I click in, for instance, Porto category 1. This is very nice because you can see details about each one of your levels, and you can, for instance, identify behaviors or problems before put this in production. Okay, this is a very important thing. Okay, I really like this because this is a way to help us as data scientists to create improved models. Okay, so this is the idea. But one thing that I would like to show is the possibility to do override. In the override part, you see here, let me open for you see. Here you see the model is pretty good. You have the historical data here, represented by these blue dots, okay? And the yellow line represent the model. And here we have the future, okay? We have the future of our data. You can tell Sasvaya what would be the length of your horizon. Suppose that in this case I have 52 weeks. So I have 1 year of forecast here. I have some years in my historical data, and I predicted 1 year, 52 weeks. Where I could change this is very easy. You can go here and you can change the project settings. And here I put 52, but you can, if you can use 6 months or 2 years is up to you. Okay, so what I did here, one thing before I mentioned this, is the possibility to do override. Override is it's when you replace the forecast, because in this case the forecast is 73. But suppose that I have some knowledge or I have some feelings about the forecast, and I decided that this not okay. It would not be this number. I can go here and put a different number, or I can go here and use the override calculator to calculate in a more, not only in a punctual situation, but I can use like a slider to select different periods. This is very nice. What I did here, I created these models. Okay, I have this inside. This is another I think nice thing that we have is like a summary, okay, done in automatic way by SAS, where SAS tells us what are the details related with the model. Okay, we have my name, I have the when I did this, okay, what was the best one, the models that I tested, and things like that. This is cool. Okay. But what I did before or after this, I go here, I went here and export all data. With this data, I can create, because here we have a like, how can I say, a data science interface. Okay, this is cool, but it's not a business. We don't have a business approach here. But when I click in export data, I can move this information to another interface inside Sasvaya, but another interface, and create different visions. And I did this. I came here and I go to the share and collaborate. And here we have remember this part, this is the original interface. I create this one, okay, data science. I use the data science global summit website, or the picture that we have in the website. Okay, this is very nice. This is a good thing that I am showing this, because it's a way to customize. Okay, you can put different colors, pictures, and what you think is I think it's cool to customize and put the vision in the way that you like. Okay, here we have the table. Okay, this is the table that I prepared before, and I have two visions here. I call this overview. This overview is related with the data, or with the historical data. Okay, and here we have the categories, we have the regions, we have the historical information. Of course, all these things are related. Okay, if I click in one category, I'm sorry, if I click in one category or in one slice, we will have these things changing. Let's see what is happening here. Okay, we are loading this part. And when I click here in application, this is a nice thing, because in this dashboard, I'm looking only to the future. Okay, all these things, I'm using the prediction created using the stacked model. Okay, in demand in the visual forecast, and I'm looking to the future. And here we have the cities, the warehouse, but in fact are cities in Portugal: Coimbra, Faro, Lisboa, and Porto. Okay, and we have the categories and the predicted values for each one of this combination. And here we have the future. Okay, we have the predicted value and the confidence, or the bound of confidence. We have the upper and the lower part. Okay, this is very nice, because it's very business. It's very business. You can put this in an iPad, in a mobile, or of course in a website. This is very nice. So guys, this is the demonstration that I would like to show you. Okay, the idea is show you the power that we have with Sasvaya. I prepare data, I create models, and I can applicate this model, or put these models in a business vision. But I could do this in automatic way. So I could put these forecast models in automatic way, running in using some devices, for instance. Okay, it's very cool. Let me go back to the. So now I would like to finish my presentation. Okay, but I would like to leave with some points. Okay, to highlight some points. At first, Sasvaya is extremely powerful and can be used in any industry. So of course, the demonstration in the process was done in thinking in the manufacturing industry, but you saw the power. You can use this in different industry. In fact, you can use this in any industry that you want. Okay. Other thing that I would like to mention is SaaSVia is an open platform that allows us not only work with SaaS process, but also with process coming from Databricks, Python, H2O, or MATLAB, etc. And the last thing, SaaSVia is a platform that works natively with machine learning and artificial intelligence in all stages. I'm not saying, guys, only in the analytical part. I'm saying all stages, okay? In the data ops, of course, in the analytical process, and in the model ops part, okay? Guys, with this, I finalize my presentation, okay? I would like to thank you very much for your time. Okay, guys, thank you. See you.
All right, thank you to Ricardo for this amazing presentation. And yeah, like I said, we'll have him back with us live during our Q&A session after the next speech. And so yeah, once again, I want to remind you about the workshop that we'll have on December 1st, and about the promo code that we're also sharing in chat that people can share.
Yeah, I also want to add that feel free to ask questions to our speakers, and feel free to reach me out about extra discounts for tickets for next 2 days. And I hope that we will grow our community together. Thank you.
And to me as well. Yeah. Okay, so let me introduce our next speaker and last speaker for this first block. So we're gonna talk a bit more about machine learning, and this presentation is gonna have some like good amount of code in it. So the next presentation is by Seyyed Mohammadiyeh, who is also goes by the name of MaxBase. He's been presenting on our other events, and he does lots of things with React, Ruby, architecture, like lots of stuff. But this time he'll be talking about real life use case on NumPy, a tool that every data scientist needs to master. So that's a promising topic. Let's start the video.
Everyone, good morning. I'm Ali Mohammadiyeh. I'm software engineer and CTO of Postgresql and the open source maintainer at GitHub. It's my honor to officially welcome you to the Data Science Global Summit Day of Presentations. I was honored to be included in the list of speakers a couple of weeks ago, and so I'm glad to be back with you. I'm here to talk about real-life use cases in NumPy, a tool that every data scientist needs to master. And it's really my pleasure to be part of this event, and I hope I can share something useful for you to know more about the NumPy library. All of us know about NumPy. It is really a popular library in Python, and it grew the Python language as well. But it is really a large library and has many features and functionality. Here we are going to cover only a small part of the main thing in NumPy, which almost everyone must know. And I can start with the sentence that we don't know NumPy, but we know about there is something called NumPy, but we need to know it more deeply. Just a start. Who I am. My name is Ali and I'm software engineer and I'm programming for more than 10 years, and my education background is pure mathematics, and I'm a mathematics researcher at University of Kashan, Iran. And you can find me on the GitHub on base max username, and I'm an open source maintainer at GitHub, and you can just follow my work on open source in the GitHub. Note that I'm not a data scientist, I'm just a software engineer and programmer. I just want to share what is NumPy and how NumPy can help you to write less line of code, and really NumPy is really good if you can know more about these features. NumPy. NumPy is a library for the Python programming language that's adding support for large multidimensional array and matrix, along with a large collection of high-level mathematics functions to operating on data arrays. And you can read more about the NumPy on the numpy.org website. It is the official website of the NumPy. Introduction to NumPy. NumPy is a Python package used for numerical and scientific computing, and it provides much better runtime and space complexity It provides a wide variety of array operations. If you wish to perform general purpose operations, use Python list. But if you care about the performance and space complexity, use NumPy. So NumPy is here to help you to process faster with better performance, with better space complexity. Benefits of NumPy. By using NumPy, the developer can perform the following operation. The first one is mathematical and logical operations on array. So by using NumPy, you can easily process operations on array matrix, and it is much easy for you. And the second one is the Fourier transforms and routines for shape manipulations. And the last one is operation related to the linear algebra, and NumPy has many inbuilt functions for linear algebra and random number generations. Why NumPy? In Python, we have the normal list that serve the purpose of the array, but here we have something new that's called NumPy. Normal lists in Python are really slow, but NumPy is much better. The first one is NumPy provide the array object that is up to 50 more faster than traditional Python lists. So we can say NumPy is really faster than traditional normal Python list or tuple. The second is the array object in NumPy is called NdArray, and it provides a lot of supporting functions that make working with NdArray very easy. So there is many functions and the feature on NdArray, and you can just call them for using. And the last one is array are very frequently used in data science project, and in data science project we have a lot of data, so it is really big data and we need a speed and resource, and it is why the performance and the resource using really important, and it is why we are want to say NumPy is really big and important library in Python and data science field. Using NumPy. For using NumPy, at first you need to install Python. So if you already installed Python and pipe, so you can easily install NumPy by running the following command in your terminal or CMD. Pip install NumPy, and after that the NumPy package will be installed so fast. NumPy array. We can note that NumPy contains collections of the tools and technology that can use it solving on the computer mathematics model of problems in science and engineers. So NumPy is really useful for engineer and science and mathematics and data science, analytics, AI. And one of the tools is the high performance multidimensional array object that is a really powerful data structure for efficient computation of array and matrix. To work with that array, there is a amount of high level mathematics functions operations for using our matrix or array. Advantage of NumPy. In this slide, we can see a couple list of advantages of NumPy, and the core of the NumPy is its array. And one of the main advantages of using NumPy array is that it takes less memory space and provide better runtime space and performance compared to the similar data structure in the Python, traditional Python list or tuple. So by using NumPy, you can store more data with less memory, with better performance, so it is much better for you when you are working with a lot of data. And the next number is the NumPy supports some specific scientific functions such as linear algebra, and it can really help you for solving linear equations. And the third one is the NumPy support vectorized operations like elementized additions and multiplications, computing, and many more features that is available in NumPy. And the next is it is very good subs. And I just want to say there is many other tools in the computer for computing similar to MATLAB or Octave that can help you for faster developing and computing. But as we can know, Python is really easy language, and if you are a Python lover, so if you want to computing and working with a lot of big and large data, so Python is for you. And for Python, you have to use NumPy. NumPy is one of the large library in Python. And the last one is the NumPy is really good and very, very good library for data analytics. Disadvantage of NumPy. NumPy has some features which is not available in the normal list in the traditional Python. For example, we have nan, it stands for not a number. So nan in NumPy is a value that is not a number. So if you have some missed value in your list, you can get help from none. And none value is something is available in NumPy. So maybe it was a problem for you if you are going to convert your NumPy array to a traditional data structure. So you must to pay attention to it. And the last one is when you're working with the large data sets and you have to working with the data, inserting, deleting, and working, iterating, and looping your data, it will be costly for you to storing and moving the memory address, shifting the address, inserting the positions. And yeah, it is what is problem is also available in the NumPy when you are working with large data. Let's start using NumPy. For starting and using NumPy, you first of all, you must to import NumPy library. So for importing the NumPy, you can write, as you can see in the slide, import NumPy as NP. We are going to use a short name. For example, here NP, you can write any other word you prefer, but we want to say it's better to keep it shorter because we must repeat it every time for using the NumPy functions. So we will write np dot any function we want to use. So after importing the NumPy, you can use NumPy library. Array in Python. In the Python, you can easily define a variable, for example, mylist, and define a list of the number 10, 20, 30, 45, 60, 70, 80, 90, 100, and put that in the mylist variable. And for checking the data type of a variable or value in Python, you can easily use type function in Python. So when you check the type of the mylist variable, you can see the type of that variable is list, and it is a normal array in Python. Here we are going to convert a normal traditional Python list to NumPy list. So at the first, we have a normal traditional list, and that's stored in mylist variable. After that, by using np.array, and array function is a function in NumPy package, by using array functions, you can easily convert and cast your traditional list to a NumPy. So you can easily convert your traditional list to a NumPy and store that in R1, and you can print that. This is how NumPy are working. About the data. If you are going to access to the memory address of array object in NumPy, you can access to data property on your NumPy object. And if you are going to check the data type of your NumPy object, you can check it by using type functions, and it will be numpy.ndArray. If you are going to check the data type of each value in your list or matrix, you can get in help and use dtype property in your NumPy object. So dtype will be the data type of your value in your list or matrix. If you are going to convert or cast your integer array to float, you can easily use asType function on your object. So by using asType function, you can easily convert and cast your integer array or list to float list. So it will be cast all of your number or digits to float number. For generating a couple of the list, you can easily use arrange function in NumPy package, and by using arrange function, you can create a list of a number between a range from 0 to 10. Note that we not have 10 in the generated list, so the main range is 0 to 9. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. By using range function, you can easily define the space between each number. So if you are going to create a list from range 0 to 100 with the space 10, you can easily use range function, and the output will be 0, 10, 20, 30, 40, 50, 60, 70, 80, 90. Note that we not have 100 in the list. Also, you can generate a list from a lower bound to the lower bound by using a negative space, and range function work perfectly. If you have a list or a matrix, you can easily check how look your data structure is, and you can easily check what is the shape of your data structure. It is a one-dimensional, two-dimensional, n-dimensional, and so by checking the shape, the output of the shape is a tuple. You can see the tuple content 10. So it is a one-dimensional array, and you can just print that. For checking the number and the size of an array or matrix, you can easily use size property on your NumPy object. And if you are going to calculate the number of the element in your array, you can easily use len function similar to other traditional Python list. So len function also work for NumPy. If you are going to check what is the dimensional of your array or structure, you can easily access to n-dim on your NumPy object. So here it is 1, so it is one-dimensional array. If you want to check how much or how many bytes per item in your list need for storing, you can easily check item size property on your NumPy object. Here we have a list of an integer, and integer is a 32 bits, 32 bits, and 32 bits is equal to 4 bytes. So here our list needs 4 bytes for each item and number. Our list has 10 number, so each number needs 4 bytes, and 10 number will need 40 bytes. There is a function in the NumPy for generating an array with default 0. If you are going to create an array with size n, you can easily use 0 functions for generating an array in size of n with 0 default value. Note that 0 is not an integer, and that is a float. You can easily cast it to int if you prefer to working with integer decimal. Also, if you want to generate a list of ones, you can easily use ones functions in the NumPy package. So it will be generated a list in size of n with default 1. If you want to repeat a number, for example, here we want to repeat 10 number 5 times, you can easily use repeat function in the NumPy package. And after running this function, it will be generate a list of 10, 10, 10, 10, 10 for you. And repeat function also work if you are going to repeat a list. So you can easily repeat a list and generate another new list. For example, here we create a list of 10, 20, 30, and we store that in the a variable, and after that we are going to repeat a 3 times. So the output will be 10, 10, 10, 20, 22, 30, 32. Also, if you are going to create 5 number of 10 in the list, you can easily use full function. They are mostly the same. It's perfect on your need, and you can easily use full function for generating a array contain 5 of 10, and the output will be 10, 10, 10, 10, 10. And we can know after generating a list from range 1 to 20, so our list will be content 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So more, we can easily filter the odd numbers by index. So if you are going to only limits and filter the list of the number that is odd number, you can easily use Python indexing feature. Similarly, if you want to only filter even numbers, you can follow the same for filtering the even numbers. There is another function in the NumPy that is really awesome. And when you are going to create a couple of the random number, sorry, not random, not really random. You want to create a couple of the number between a range. For example, here we are going to create 4 number between range of 10 and 20. The line space is here to help you. It can create a couple of the number between your range. Here we are going to create 11 number between range 10 to 20. So the output will be 10, 11, 12, 30, so more. The next function is np_random. By using random function, it will be generate n number between 0 to 1. So it will be generate a random float number for you, and the output array will be float. You can cast it to integer and say or throw it if you want. If you want to create a couple of the random number between a range, for example, here we are going to create 5 random number between 0 to 500. You can easily use np_random rand int. Another example. Note that you can set your seed in the Python, and when you set your seed, a constant, it will be generate same and duplicate random value for you. For example, here we set the seed to 1, 2, 3, and we are going to generate 10 number between range of 0 to 100. If we repeat it again and again, we will see the result and generated random number are really same. And this is really bad for a large program if you are going to generate unique random. So it's why recommended to use current time in second or nanosecond for seed. By the way, seed is good for you if you want to generate same number. Maybe you need this feature. By the way, generally Python is safe and it can help save random number for you if you prefer to use its default. There is another function called random uniform. By using uniform, you can easily generate a couple of random number between a range between 5 and 10. We are going to create 10 random number. If you are going to cast and floor your float number to integer, you can easily use floor functions. And also there's another functions called Seyyed, and it will be run to up and floor will be run to down. So also, if you are going to cast a float array to integer, you can easily use as type functions and casting to int. Or maybe you want to keep your array in float mode, but only you want to truncate decimal part. For this, you can use trunc functions in NumPy package. Otherwise, you can easily convert your float array to integer by using as type function. If you are going to generate a couple of the list number in the mean 0 and variance 1, you can easily use random rand_n functions for generating a couple of the number, and the variance is 1 and the mean is 0. So if you have a list and you are going to print and iterate your list and looping that, you can use n_denumerate function in NumPy package. So by using n_denumerate function, you can easily access to the index and value of your list. If you want to calculate sum of all elements in an array, you can use sum function on your object. If you are going to checking the list of the steps sum is increasing, you can use sum function on your in the NumPy package. So it will be generate a list of steps sum is increasing. And the last item of sum is the total sum of all items. If you want to find the minimum number in an array, you can easily use min function on your object. If you want to calculate maximum, it is similar. If you want to find the index of minimum number in a list, you can use argmin function on your object. And similarly, if you want to find index of maximum number in an array, you can use argmax. For calculating the mean of all number in a list, you can use min function. Similarly, for median, you can use these functions, and for variance, you can use var function on your object. So there is many more functions and operations in the NumPy which will be make it easy to use for you for developing your data science project. For standard deviations, you can use np std. Std is a function in the NumPy package. And there's many more features. Let's start two-dimensional array. If you are going to convert a list, traditional list to NumPy, you can easily convert that similarly, no matter that is one-dimensional or two-dimensional. NumPy support all. So easily you can convert and cast your traditional list to a NumPy list. And similarly, you can calculate most feature and functions on two-dimensional array as well, similar to sum on a two-dimensional array, or maximum, minimum, or maybe you want to find the minimum number column-wise. For this, you can use amin functions and mention exists is 0. 0 means it's column-based. Or maybe you want to calculate the minimum value in row base. For that, you can use amin functions and define the axis to 1. So 1 means row base and 0 means column base. For calculating the mean of all number in two-dimensional array, you can use similarly min functions or median or any more. And for accessing a number in a list, you can easily access to it similar to the traditional normal Python list. So NumPy is really easy to use. Maybe you want to access all elements of an array except first one. For that, you can write accessing the array index 1 column nothing. So you can easily skip first one and getting the rest. Or maybe you want to just getting the 2, 3, 4. And you just want to skip 1 and skip after 4. For this, you can easily write a number after column. For accessing the last element of a list, you can easily write negative index when you are going to access elements in an array. So you can easily access last item of array by writing -1, and that works. You can easily write both of your index in negative. For example, -0, -1. And that's really work, and you are going to only get 9 and 0. There's a function called where in the NumPy, and by using where, you can easily filter and replace your list. Here we created a list in a range of 1 to 20. So we have 1, 2, 3, 4, 5 until 19. And we are going to change and replace all of the digits that are even to 0. So it will be replace all of the even number to a 0 number. Or maybe you want to replace 10 to 99. For this, you can easily use where function as well. Similarly, by using put function, you can put a list inside another list. And so by using put function, you can easily merging two array and in a specific index. So it will be similar to replacing a list on another list at a specific position. There is something called none, not a number in NumPy, and you can define your missed value in your list, and that's really supported in NumPy. You can easily mention which value is missed in your list. If you are going to checking which value in your list missed or is equal to none, you can use isNone function in the NumPy package. So it will be generate a list of true and false, true or false, I mean Boolean value, Boolean array, to show you which items contain a none, I mean not a number. And you can combine where and isNone functions for just finding where is the index of missing value, and you can easily find the index of missed value in NumPy, and it's really works. Similarly, if you are going to replace all of the missed value to 99, you can use the feature of indexing in Python, and that's really working. Also, if you want to check the array has any null value, I mean NaN value, you can use any function on a isNone function. So any function can check something on a list of Boolean. You can use non value in a two-dimensional array, I mean matrix as well. And the isNone function will be generated two-dimensional output for two-dimensional input. Note that you created list from 0 to 5, so you have an array one-dimensional, and you want to reshape it to a 3 and 2. It will be generated a two-dimensional array for you, and you will have 3 rows, and each row will be contain 2 columns. Reshape is really useful function, and you can easily converting and casting your array to another new size. You can also get help from Reinvent function. Note that when you mention the one of the size in the reshape is negative and has minus, for example, -1, it will be just changed to something which is working for your array. For example, here we have a list in range of, we have a 10 number, 0. We are going to reshape to 2 minus 1, and it will create a two-dimensional array, contain 2 rows, and each row contain many columns. So -1 just skip. If you are going to push or merge array vertically, you can use vstack, and that's push your array vertically. Similarly, you can do same horizontally. So you can horizontally merge two arrays. Here we are merging A and B horizontally. So you can easily merge your arrays horizontally or vertically. There's a function in the NumPy called intersect 1D. That means one-dimensional. It will find common items between two arrays. So you can easily find your common items into different arrays. Or maybe you want to remove common elements. For this purpose, you can use set diff 1D. 1D means one dimension. Or if you want to find where both of your I are equal, you can get help from where function, and it will be return the element that A is equal to B. Here 2 in the IA and RIB are equal, and the next one is 8, so index 4. Index starts from 0, so 0, 1, 2, 3, 4. Yeah. Similarly, you can just print and getting a list of them where the R condition is satisfied, and you can easily merge the where function on the indexing feature of Python. Or maybe you want to filter and getting a list of the number between 20 and 35 by using where functions. You can easily filter it. You can see range function will be generated list from 0 to 60, and after that we are going to filter between 20 and 35. Or maybe you want to only filter digits or number between 20 or 35, or if that is divisible by 10. So there is an or between our where condition. Or maybe you are going to using logical AND. So there's a function called logical AND. By using that, you can just checking two conditions and only running the where function where both of the conditions are satisfied. You can use isNaN. isNaN is a function which will help you to check where is your target array or number is repeated or displayed in your list. So isNaN isIn function is a useful function if you're going to searching and looking for a number in your array. And yeah, you can see many more examples. I have more hundreds of slides, and there are many more functions and examples to show. So excuse me, I have to go faster and just mention the name of the main functions. Also, you can easily reverse your array by getting help from indexing feature. You can easily write colon -1 and reverse your array. Also, there is a function in the NumPy called flip, and by using flip, you can easily reverse your array. Or maybe you are working with a two-dimensional array that is a matrix, and you want to reverse that. For row-based reverse, you can write colon -1, and if you are going to reverse column-based, that's different. By the way, you can easily reverse one-dimensional or two-dimensional array, row-based or column-based easily in Python. Or maybe you want to reverse your two-dimensional matrix in both row and column position. That is possible in Python as well, in just a single line. Or maybe you have a list and a couple of the number, and you are going to sort that. For sorting in ascending order, you can easily run sort function in the NumPy package, and sort function in the NumPy package will be sort your list in ascending order. And if you're going to sort your matrix, sort function working as well. And you can mention you are going to sort your matrix blank rows or column. For rows, you can mention axis is 1, and for column, you can mention axis is equal to 0. Or maybe you want to just sorting in descending order. For that, you can run the sort function, and the sort function will sort your list in ascending order. And after that, you can just reverse the sorted list, and the final output will be a sort in descending order. Or maybe you can use flip functions. So you can use sort function to sorting your array ascending order, and after that you can call flip to reverse your array, so the output will be sort in descending order. And if you have a couple of the number in your list, and by using NP random shuffle, you can easily just putting the number in the random position, just moving the position and index of the number, not about generating a random number. That is just changing the position of location of your list number. Also, if you are going to return n largest number in an array, you can easily use arg sort and limit that to get the largest number. So it is really much better for you to mention how many number you are going to get after sorting. Also, you can get help from arg partitions, and by using arg partitions, you can also you are able to return n largest number in an array. If you have a list and you are going to repeat whole of the array two times, you can easily use tile function. Tile function in NumPy can repeat an array 2 or 3 or n time for you. And the output will be 10, 20, 30, 10, 20, 30. Note that the output is not 10, 10, 20, 20, 30, 30. Output is 10, 20, 30, 10, 20, 30. Also, if you are going to using repeat function, it will be work differently. It will be create 10, 10, 10, 20, 22, 30, 30, 30. You can just look at to check what is different. Also, there is a function called allClose, and it can check your array or list are equal or no. So which will be Boolean, true or false. And by using unique function, you can easily just getting a unique number in your list, and unique functions can return one value or two. The first one will be list of your unique value number, and the second one will be the number of repeat for each digit number. There's another function called bean count, and that can create a new list which will contain 30 items, because largest number in our list is 30. So we have 3 repeat for 10 and 6 repeat for 10 and 3 repeat for 20 and 4 repeat for 30, and there is a lot of 0 in the generated list. You can see at the position of 10 there is a 6, at the position of 20s there is a 3, and the position of 30s there is a 4. That means 30 number repeated 4 times. Also, there is a function called rmax, and by using that you can just find the most frequency value. And sometimes you need to create a read-only matrix or list. You want to keep a list only readable, so you just can disable flag writable to false to make that only readable without any change. You can easily load a matrix or load list from a file by using load txt functions. Also, there is more functions similar gen from txt that can generate a list from a txt file, and you can easily accessing specific rows or columns by getting them from Python indexing feature. Thank you for your attention. I just used a couple of the reference, a book and some website. Also, I published my slides and presentation file publicly on my GitHub on a repository called Data Science Global Summit -NumPy. Thank you for your attention, and I hope I can share something useful. It was my pleasure to be part of this event. Thank you for your time and attention. If you have any questions, you can just mail me. Note that I'm not a data scientist. I'm just a data lover, and my education background is pure mathematics. and I'm in mathematical research and university. But I'm software engineer. I'm just happy by writing and designing the software. Thank you so much.
Okay, thank you, Max, for this amazing presentation. And yeah, we'll start our Q&A session next. So yeah, Lilia, what do you have to say?
Yeah, thank you a lot, everyone. All our speakers from that block are present. So let me add everyone to the screen. So hi, hello, everyone. Nice to see you.
Hi, hello guys. How are you? Nice to meet you.
Nice to see you again.
Okay, Nick, let's start
Hi,
from.
everyone.
Hi, hello.
Yeah, hi. Like, yeah, I hope Ali also has a good connection. Like, I know he has some troubles, but yeah, he still managed to join us. Thank you. Okay, so let's start with our first question that we had from way back, way earlier in the blog. So the question is, how to reconcile making good foundation with the business need to iterate quickly?
So I'm guessing that was from my talk, and that is good foundations help you iterate quickly. So if you are missing the people for your foundation, you'll always hit that downward spiral that I talked about, that roller coaster. So I would go so far as to say part of the problem of not being able to iterate quickly is missing those people. If anybody else has something they want to say on that, I would love to hear your thoughts.
Thank you for your answer. We have one more question to you. In data team, how is data science different from operations?
That's an important distinction of how data science is different from other operations. So let's talk about what operations is first. Operations is giving that operational excellence. They're making sure that the infrastructure runs correctly, that the processes run correctly, that the data has good quality. That's really key. So that's different from data science, who is creating the models. So your data science team is actually writing code. They're actually creating models, they're doing training, and that is important because if we don't have that, if we're missing operations, no one is there making sure that everything runs correctly. And then on the data science side, the operations people can't create models. Likewise, the data scientists are poor at doing operations. So you do need both, as well as you need data engineering, which you don't mention in the question, but very key. Those two are sizable differences there.
Okay, thank you. So guys, feel free to ask more questions to Jesse. I will continue with other questions. Ricardo, next question for you. How can you increase the accuracy to demand forecast of a demand forecast?
Oh yeah, I think this is a question that worth $1 billion to improve. I think the best way is I think a key point is the data preparation part. This is a key point, and the use of different approaches. And I proposing on this my presentation to use neural network like a hybrid approach. Neural network, and it's not only neural network, but a neural network with time series, a classical time series. Is like a hybrid process. And I think, in my experience, my day-by-day experience with this kind of approach, a better data preparation in an hybrid process involving neural network and classical time series, we are achieving best or better results in terms of accuracy. Okay, this is a fact. I'm not talking only about theoretical points, but using this kind of thing, take in consideration data preparation and an hybrid approach. I think is a good one, a good choice.
Thank you. Yeah, okay, can you please continue?
So yeah, we had some questions. So I think this was asked during also Ricardo's presentation. So about Model Studio software, is it free? If not, if there is an education license for this software? Yeah, I've guessed like lots of students could be interested in it.
This is a question for me.
If I'm not messing with it, if I'm not, yeah, it was for you.
Oh, okay, no problem, no problem. We have Sasvaya. We have Sasvaya. Okay, Sasvaya is not for free, but we have Sasvaya for learners. Okay, and this is for free. This is the same software that I show in my presentation, but the only difference is that you have a smaller capability in terms of amount of data. Okay, but you have the same functionalities in terms of machine learning, artificial intelligence, optimization, and so on. And this is totally for free. The only prerequisite is that you need to have an academic email, but just it. It's not necessary to pay anything. If someone need more information or need more information about this, please send me a message by LinkedIn or by email, and I will be happy in support you on this stage. Okay.
Awesome, thank you. And also, like, now we're talking about like studying and learning. So people are asking, first of all, for your slide. So if you can give links, I can like send them to chat. So please share them.
Oh yeah.
People asking to you, Ahmad. Definitely, I remember people asking about your slides. And so, like, if you can share slides now and links in chat, people would really, really appreciate that. And the same goes for some materials and like studying books, links, and you were either showing on your slides or not. So yeah, you can also post in the chat either directly on our platform or right here in private chat. We'll copy it to for our audience to chat. So like send whatever, we'll collect it and send it to our audience right away. Okay, so the next question that we have is for Ali, which is why is NumPy is an important library for working with data?
Hi everyone, can you hear me now?
Yeah.
Yes.
I guess there is a delay, but it should be fine.
Okay. NumPy is an important library in the Python because it can help you to working with larger data faster, and it can help you to easily apply more operations on your data easier. So you can working with data easier, and it can help you. And it's growing a lot of in the recent years, and it is really a popular framework.
Okay, thank you. So there was another question for Jesse, which is, can we say that operations is the one that verify or validate the data engineering process?
They can be. So operationally, as we talk or think through the data as it goes through the pipelines, there needs to be monitoring of that data in real time. So there is this ongoing data quality check that your operations team should put in place. Now, that doesn't mean that it's only operations job. There should be programmatic data quality checks as well. So let's just say, if we're expecting an integer, a 32-bit integer, and we're passing that as around as strings, that's a problem. Yeah. There's a lack of validation of that field. And so now that becomes, instead of the, let's say, data scientist, this is often, frankly, a data scientist doing this wrong. That data scientist doing something wrong that then becomes an engineering problem, but at its face, it becomes an operational problem because now things don't get converted correctly. So in many ways, data quality, validation of data is everybody's job, but oftentimes at the very end of that, we see that becoming an operational problem. So what I'd really strongly tell you is verification, the data scientist should be doing the verification. For some reason, I got muted.
Yeah. Can you please repeat what you just said? Like the last sentence.
Sure. So everybody's job. It's everybody's job. But what it could look like at the very end is an operational issue.
Okay, thank you. Thank you for the answer. So there is a question for Ahmad. So why is Halu so popular in big data analytics?
Okay. So yeah, I'm sorry. I was just like looking at the links. Okay. Right, so yeah, for the question. So for like the Hadro, so like to be honest, I have never been like dealing with the big data analytics or that segment. I'm more specialized into the business intelligence. But like for a software to be like so popular in any field of the data fields, for example, like on the SaaS, it needs to be like having a lot of use cases and also the popularity across the enterprise. So if a company is doing a really great job at like selling to companies and providing the key features that these companies and enterprises need, they will definitely be very popular. But from my end of things, I'm more into the visualization. So, for example, Tableau would be like very popular in my use case, and the reason why it's more integrated into like my company and etc. So, for a specific software, it needs to be to the key elements that the software provides to that field.
If I could help out answering that question more. So Hadoop is so popular because it's open source. So it's Apache Hadoop, it's an open source license. And so early on, probably 15 years ago, it was really popular. 10 years ago, it was really popular. And it was popular because it made the actual analytics be able to go over terabytes of data relatively easily. We had Hive and those sorts of technologies that would sit on top of that. One thing I will say that is really key here is that Hadoop as the HDFS, as the file system, is still around. But if you're doing any sort of greenfield or brand new technology usage, you definitely wouldn't be using Apache Hadoop MapReduce for that. You would want to use Spark, Apache Spark, or something like that, and newer technology. But it is still popular, but more for legacy applications.
Oh, great. Thank you for so interesting answer. Probably someone want to add something for that? Okay, we could continue with the next question. What is the size of the data accepted by CS?
Okay. Okay. No, it's not. We using SASVIA, we don't have a limitation of data. Okay, it's not. We don't have a limitation of time of size of data. Not even in terms of granularity. It's possible to work with any kind of amount of data because this process is done. I'm sorry, something happened. I hear something. So, but it's not. We don't have a limitation in terms of size or in terms of variables or observations and so on. It's not a problem. I'm sorry. Maybe they are asking related with SASVIA for learners. SASVIA for learners is the same software, but with a kind of limitation. You have 5 gigas, 5 gigas. But this is academic software. Okay, but if you are using SASVIA in a corporative way, we don't have limitation.
Okay, great. Next questions for Jesse. Can we say that operation is one of the verify of validate of the data engineering process?
I think we just covered that one. Yeah,
we just covered that one.
Yeah, sorry. Yeah, I didn't delete it. But yeah, we have a question for Ali. So this is from our YouTube chat. So thank you so much for NumPy cheat sheet. Will be great reference for working on Python. Could you please share the sheet for easy reference? Yeah, people are asking for you to share.
Yeah, just let me. I will show in the chat message.
Okay, yeah, I'll do that later at the end of the Q&A. And we have one more question for you, which is, will NumPy benefit from the speed improvements of Python 3.11?
It is a really nice and interesting question. For sure, the answer, we can test it and report the benchmark result. I expect NumPy to be faster than traditional and normal list because in science, there are many algorithms. For example, we can read about a sparse matrix. We read about a sparse matrix. it is a matrix, something will be contain only a special value. For example, if you have a lot of zero number in your list, in a sparse matrix, it will be ignore all of the zero, a number which is frequently repeated. So I am not sure about the structure of the NumPy low-level library, but I am sure if Python improved its compiler or interpreter, NumPy will be grow and will be faster than before. Note that Python is the main environment, but NumPy mostly processes in low level, not at Python level, but improving the Pythons can improve the NumPy.
Awesome. Thank you. So we have more questions for Ricardo,
Good.
which is which data file format does SAS VS support?
Again, we don't have a limitation in terms of data, in terms of access. You can use CSV, XF, or you can use Oracle. You can connect in databases. We don't have a limitation in terms of data, because when a company buy Sasvaya, we have a connector for every kind of type of data. So it's not a limitation. Okay, we don't have. In fact, when you think about data in terms of size or in terms of connection, is not a problem. In fact, we can work in stream data. We work a lot in data from streaming, like window turbines, for instance. We work a lot with some energy companies, and the data came in the streaming in real time. So it's a huge amount of data, and in a very quick way. Okay, so it's not a limit. We don't have a limitation in terms of format.
I guess continuing on that question, so can it be run locally or is it on the cloud?
Could be on premise, could be on cloud, could be a hybrid situation. Depends on the company, okay? But could be on premise or cloud. It's not possible in a desktop, okay? In a desktop, if you are using Sasvaya for learners, okay, it's possible to do in your desktop, but you access a cloud environment, okay? But in a company, you can choose on-prem or cloud or even a hybrid situation.
Okay, thank you. So we have another question about NumPy. So what are the main areas of functionality used for data analysis applications? Hey, Ali, are you here?
Oh, it's format. Okay. Can you hear me now?
Yeah.
Okay. I am not sure about the purpose of these questions. If you're looking for using traditional lists in Pythons, I just answered that because NumPy is a low-level library which can provide many more feature and functionality and operations for your data, and that can supporting and storing data in low level, so that can handle the data in low level for storing and working, and that can help you to store a big data in less memory and with better performance.
Thank you. And
Maybe
so
you're looking for an alternative for NumPy. I am not sure.
Oh, okay. I guess that covers that. And yeah, so this is like a reminder. This is a free live stream that we have lots of people who are just getting into the data science industry. They're thinking if you're going for data analytics or for data engineer, like lots of new stuff they're learning. So the question is, what is the most important thing to know about being a data scientist? That's the question we've got in our chat. This is a question for everyone. I guess we have different perspectives. So who wants to go first?
Okay, so I can go if you want. So for like B2 dealing with data, the first thing like I would see like about freshmen in data science, that they will be overwhelmed. A lot of tools, a lot of programming languages, a lot of things that you could do with the data, and especially like in different industries. So there's like not an ultimate data scientist, but there's like a data scientist for each and every position working in a company. So how it feels that you will try to figure it out. This is like what I feel like when I'm working at scale, for example, that you need to figure out like a solution, even if you're not like a solution architect or anything, but you will try to figure out from the insights that you are getting from your analytical model what is the next best action or the MBA that you should be doing in the future, or what you would go ahead and restructure, change the process, do everything. So the most important thing to know about being a data scientist, that you should be curious each and every day, and you should figure it out whenever you are doing any task. Just go ask and double check in Google, of course. Like Googling is the key.
I would add, if you permit me, that I think is an important thing that we need to have is a storyteller capacity, because it's very important not only create models or create analysis, but translate these to the business guys, because these guys will buy our things. So it's necessary to have this kind of skill, okay? The storytelling, explain what we did in a more business way. I think it's very important. I think in my opinion, this is of course we need to know programming language like Python, R, SAS, H2O, and so on. Data set, the databases. We need to understand statistics, mathematics, but I think one crucial point is the storytelling part.
100%.
One other important thing to know there is that data scientists are usually coming from a mathematical background and learning the software engineering. And that's really key. You can see that from the questions. So to all those people who are trying to become a data scientist, just realize that you're just scratching the surface of what computer science, what programming is, software engineering is, and to know that limitation. So as you're trying to create a system, know that you are going to spend far more time than you think on the data, on the programming side. To that end, if you are actually trying to do this at a company, where you're joining a company, joining as a data scientist, and you look around and you're the only person doing this, there's no data engineering, there's no operations, that means that you're more than likely being set up for failure. You are now going to have to be the data engineer, you are going to have to be the operations person, and more often than not, that is setting you up for failure, because the data scientist skills are not at a level to be a data engineer, frankly. And the data scientist skills are not there to be an operations person. So you'll either need to start telling your management we'll need other people, because you will find yourself spending 80-90% of your time doing data engineering and not data science. And that's when people burn out. So be careful there.
Okay, thank you. Ali, could you continue, please?
Yeah, can I answer?
Mm-hmm.
Can you hear me now?
Yes, please.
Yes.
Okay.
Yes.
Thanks. And about this question for learner, I think this is a complex question, but we can go ahead simply. I think that we will need a bit mathematics and Python or R programming, statistics, industry, real life problem details, and learning more about database or data structures. Step by step, we need to practice more and learning more. And finally, not we or you have to solve a real problem by your knowledge. So we must looking for that and trying to solve that. It is all.
Okay, great. Thank you a lot. That for this, we will finish our first block of our first day of conference. Probably someone wanna give some final recommendation to all our attendees today. So please, Ricardo, could you please start?
Yeah, I think we need to be curious, okay? To need to read a lot, to hear from everyone, to be humble, okay? And I think never stop learning. I think it's necessary to learn every day, okay? be humble and work hard. I think this is my message. Okay.
Yes, I think it's also a best recommendation for everyone.
Yeah.
Jesse, would you like to share something from your experience, what people should to do?
Sure. That's to be wary of oversized expectations, whether your personal ones or within your company, where you have this personal expectation of, oh, I can become a data scientist this weekend. That's just not going to happen. Likewise, if your CEO is thinking that you're going to come to this conference and become just ripping through some AI, not very possible either. So have realistic expectations. Otherwise, both you and others will be set up for failure.
Yeah, definitely.
Thank you. And Ahmad, probably you add something for us.
So like Ricardo and Jesse have like said great things about like the curiosity and just like setting your expectation. So just to add on this, just be passionate and know the goal. So look straight forward to your goal that you are working for. And to end this up with like a quote from Einstein: once you stop learning, you start dying. So never
Yeah,
stop learning.
it's true. It's true.
Thank you. And Ali, what is your opinion about that?
I agree with Ricardo. He spoke very well, and we have 2 ears and 2 eyes and 1 mouth. Let's listen more, learn more, talk less, and do more.
Yeah, yeah. I like it. I like it. These.
Thank you. Thank you a lot. Nick, you want to continue?
I guess we went through all the questions that people had for us. So yeah, thank you for everyone for participating in the Q&A session, and of course for sharing all of your amazing knowledge with us. We hope to see you on our future events. And for now, we're gonna segue into a break. And so yeah, thank you very much, and see you later.
Thank you.
Thank you.
Thank you.
Great
Bye
to be
bye. Bye
here.
bye, guys.
Thank you.
It was a pleasure. Bye bye.
Bye bye.
Okay, yeah, so I guess we have a pretty long break ahead of us. So I'm going to talk a little bit about our plans for next year, because surprisingly enough, this is going to be our last event of the year that we've done at Geekle. Like, wow, we did so many. We did our first data science event earlier this year. We did like 2 Reacts, 1 Node.js, JavaScript, and many more events. But yeah, we have so we'll start the year with our Node.js and Java events in January, and we also have Ruby. So 3 events in January, and I also will share some links in the chat after I finish talking. But yeah, we'll have 3 events in January. We have Java, Ruby, and Node.js. We'll also have Angular event in February, and of course, yeah, we're talking about data science here, but I'm sure there are some people who have something to do with front end and back end here watching us. And so we have Angular, and we even have product, our very first product management event at the beginning of March, and also will be done by Lilia. So if you have someone in your company who's a product manager, or interesting to learn more, because so there are lots of people who are developers and they change their occupation to product managers. There's usually lots of people there changing from being developers to product managers. And yeah, so I'm gonna share all the links in the chat.
Yes. I want to also add that, as Nick mentioned, it will be Ruby in the end of January. So I will expect everyone. Probably someone will change mind till January and would like to try something with Ruby on Rails. So I will be happy to see you there, because I also will care about this event and about product management also. So if you would like to try you in product on project management and try something new in your company, feel free to join us and discover new knowledges for you. And as Nick mentioned, we close our season with Data Science Global Summit. It's the biggest, it's the longest event actually in Geekle, 3 days conference. So feel free to join us 2 next days. It will be more use cases, more information there. Speakers will have high level of insight information, and they will share it with you. And feel free to ask questions and write me or Nick to join us.
And of course, the workshop on December 1st, it's still open. So register. Even of course after the event ends until the end of November, you can register for that. So if you need time to confirm that with your company, you have time till the end of November. And so yeah, let's go to a short break. Not short, like it's gonna be like 25-minute break, I guess.
Yeah, it's just coffee break, and I also want to add.
I think you can have a decent meal during this time, not just a coffee. So
Yeah.
that's what you have chance to do. So get back in 25 minutes, and we'll continue with the next block of speeches. We'll be talking about data science. We'll be talking about NLP, and we'll even talking about some big data and machine learning.
And one more reminder actually. So feel free to share your feedback with us. We expect your minds, your opinions, your emotions about this event. So feel free to share it with us. Thank you.
Thank you. See you in 25 minutes.
See you.
Okay, we're back. And before we start with our first speaker, let me remind everyone that we actually have a Black Friday. It's pretty easy to forget there's a Black Friday out there when you're literally in a cabin, but yeah, we're not talking about that. We have an annual pass for our future events available right now with the Black Friday discount. So we have plans for more than 30 events. We have published calendar for first half of the year already, and we'll update it later for the entire year. So right now we have an annual pass available. It will be either for individual one or for your company. We even have an unlimited that will, like, if you are representative vice, like if you are a team lead or a CDO, I don't know, you can buy this unlimited package, and you can send any number of attendees for any number of events that we have planned for next year. So, and I know there are lots of people who are interested in strictly in JavaScript. Of course, this is not an event to be talking about that, but still, we have a JavaScript annual pass, and this is going to be more than 6 events, at least planned for the year: JavaScript, Angular, Node.js, Vue, and React. So we have to have those. And this is our main page, which is geekle.us. It's pretty easy to find, so go at geekle.us to find those, and you have time until the end of the week to basically confirm this with the management and like to show it to your colleagues. Okay, so I guess we can get back from break finally and start with our next block. So let me bring Lilia to introduce our first speaker of this block.
Yes, hi everyone, one more time. Our next speaker, let me welcome Jônatas. Hello, Jônatas, how are you?
Hi, feeling good, and you?
Thank you. Nice to hear you today. Nice to see you also. So let me introduce Jônatas. Jônatas Paganini is onboarding lead in Timescale, and today he will be talk about data science with Postgresql and TimescaleDB Toolkit. So Jônatas, the stage is yours.
Okay, thank you. So let me share my screen here. And so this is probably a tunnel now, and you will not see myself too much. Even I will just scroll here. And this is the black screen that I love. That's the terminal. And I have 2 tabs here. One that's this black one, and this one that's white. That is where my presentation is. So I am a terminal lover, and I struggle to just use visuals in my presentations. And as I do a lot of live coding things, so I prefer to have everything in the same application. So I will be here for most part of the time. And yeah, my name is Jônatas. You can find me as JônatasDB at the internet. I use Postgres since 2004. I am a backend developer. I am always using Ruby, Shell, Postgres, and Vim to my work. And my title in the website is as an onboarding lead. And recently, I am back as a developer advocate at Timescale. So if you want to find me on Twitter, I am JônatasDB. On GitHub, I am Jônatas. I have several open source repositories and examples and things like that. So for today, I will be showing some weather data set, and that will be our playground. And from this weather data set, we are going to start with some Postgres statistics, and then we can just evolve to use some timescale functions. And then I'm going to just share a bit of what TimescaleDB extension is and how it works, and how the functions that we have and how we enhance Postgres for time series data. And later we are going to just go through some of the toolkit functions and explore more data science ideas and things like that. So the data set that we are going to use is from OpenWeather. If you are not familiar with this website, it's very good if you don't have a data set as a playground. It's free, and you can also connect to the API free, so you can just have some data to play. In my case, I fetch data from the weather from the last 40 years, and this data I also keep like a API connected to my data set, so I'm let's say refreshing my data set very often, and then I have up-to-date data with a very good granularity for exploring this kind of weather metrics, right? So let's start with the PSQL. So I will be jumping into these two screens, and PSQL, if you are not familiar with this, PSQL is basically PostgreSQL command line interface. So as you know, PG admin is a very common thing. It says here you can use help if you want to know things, and then you can, for example, if you wanted to learn about select, you can just use like \h and then or interrogation question mark, and then you can learn about some specific commands. And I'm going to start with \DT, so it means describe tables. And in this database, I just have one table that is this weather metric. So if I try here \D weather metrics, I can describe what's inside this table. So I'm going to reduce the font a bit just to fit in the screen. And you can see here what we have in this table. We have like a time column that's the most important for time series data. So when we collect some specific temperature, so it's the temperature of today, from yesterday, from previous year, or whatever. So this is the main column for time series data. And the second column that we are going to use a lot is city name. So we have a few cities here, and we are going to also use the temperature in Celsius here. So that's how we are going to do. So let's just start with some 5WH. I really love this: who, what, when, where, why. So the TimescaleDB extension. So we are going to talk about this for a bit here. So my next command here is \D+. So what we can do if we just try D here, you can see that I have in the end here I have this before insert weather metrics, and it says that it will just use this TimescaleDB internal. But more important here, we have this number of child tables. So it means that this table, weather metrics, is not like a very common table. We call it hyper table because it's full of child tables, and the child tables is partitioned by data, so by time. So when you try \D+ here, you can see that it contains these timescale internal tables. I will just copy the first one here in the list just to show you. So if I try here \D on this table, you can see that we have exactly the same structure of the table, but the difference here in the end is that it has a constraint that just allows data which the time column is from this date, 78 December 10th, 28th, until January 4 of the next year. So it's like a week of data, right? So, and every partition here have a week of data. So instead of like, I have a very long and huge table with all the data from all the time series years, I can just split into small tables. And why it's important? It's important because when you are fetching and querying data, you can parallelize the partitions. So you can just query data from a large period, and then it will split the data, and then you can just query the data in parallel. So if I'm going to check some query, it will be much easier and fast. So and it just optimizes the throughput of the data. So it allows you to insert more data in parallel, and it allows you to also select, update, delete the data. And another good thing of these chunks of data is that you can also compress them. So for example, you are just using the most recent data, and the old data is just there for auditing, for logging, for just analysis, and you can compress this data and save storage space in your hard disk, right? So I'm going to enable timing here because you can just keep watching this. So for example, if I enable timing here, I can just select something. For example, I just select one. So, and it's like half millisecond to select one. If I try again, you can see. And if I just do this, this is like a empty query. So you can see here 3 times. So in average, like an empty query is like 1/10 of a millisecond, right? So, and with this, you can see how is the delay of your server. So it's less than a millisecond. So, and this is important to get to know metrics about your server. And then when we query things here, we are going to also see how much time it spends to execute this. So the next thing here, we are going to use this select count from weather metrics. So when we do count here, for example, we spend like 1 second or a bit less, like half second. It was not in memory yet, so now you see like half second, 456 milliseconds to count 4 million rows of data. So, and it's very fast. So if you are not familiar with numbers, it's quite fast. But we also have another function for hypertables that's able to do something very similar, and it will be much faster. So 90 milliseconds. So an approximate row count, it will use the metadata from the server, but it still bring a very approximate number, right? And this is very interesting to see how these hyper functions can help you. The hypertable concept and the functions that comes with that, we call them hyper functions. And then if I try here some explain, so explain is a command that if you are familiar with Postgres, several times you need to go and understand deeply how the query is working behind the scenes, why it's delaying, and so on. So for example, if I try to explain here the count, you can see here that I have several parallel index here. So everything here is like parallelized because we can count the subtables in parallel, and then we can just merge and join them, and it will be much faster than if I just try to go line by line in a sequential way. So it would be much harder to count, right? So let's start with the queries, and now we can check the first query here. This query is quite simple. Like I'm just selecting the time and the temperature from the weather metrics table where the city name is New York. And then I'm going to also just do a filter by the June 1 and 2, like the 1st and 2nd of June, and limit the data for 20 records just to see some data that we are going to explore here. And as you can see here, like we start with the minute 15, and then we have 27, and then we have 45, and then 55, and then we have like a kind of like every 15 minutes, and it's not very let's say closer to 15 minutes. Sometimes it's 13, sometimes it's 17, but this is like open data from different servers around the world, and that's the data that we can have. And you can see here, for example, 29, 53, 10 minutes late, it's 21. And then we don't see too much difference between 1 and 2 because the difference is very slow, is very low, and then we can be just grouping this data to be more easy. So, for example, if I would like to check the last 24 hours of data, I can use this time bucket function and just group it by 1 hour, for example. So time bucket is widely adopted by the TimescaleDB extension users because this is let's say grouping by 1 hour. It's very similar to use to truncate a date at some point. So we are basically truncating the date here, but time bucket also works with time zones, and it's prepared for the TimescaleDB extension, so it's optimized for the hypertables. So now we are going to test this. So we are just like looking from day 1 to day 2 and grouping by 1 day, and this is also New York from June temperature, right? And then we can see here like 30, and then we have 27, and we can see 24, 21, 20, 18. So the temperature is going down here and just go into 1 p.m. here, and then 11 p.m. and then it starts growing again and getting back to some higher temperature again. So a warm weather again, right? So, and then we got here like 24 rows for 1 day of data in 5 milliseconds. So it's very, very fast and easy to get this data. And this AVG is the function that we used here. I will use \e here, so we can just jump into this terminal and then, for example, I can add here like mean temperature, and I can also add the max temperature, and this is our like Postgres functions. So now we can see like in the 1 hour it was 29 and jumped to 31, but the average was 30, and so on. So this is like very basic statistics that we can do with Postgres, and this is how, let's say, and this is how like coming with Postgres. And we have also this this function that is named first and last. So if you are familiar with the candlestick pattern, so for example, mean, I can call it low, max, I can call it high temperature, and then like first temperature based on the time column is the open, right? So I can, the candlestick pattern is widely adopted in the financial markets, and they use it to see like how the time open, or how the prices of the market open in a day, how they close the day, what were the highest of the day or the week or the year, and what was the lowest, and how it closed. So I can also call last here, and then I will call it close. So open, high, low, close. This is a pattern, and we also call it OHLC. A lot of people just use this acronym for referring this, and this is a very, very common used thing. So for example, let's edit it, because like 1 hour we cannot see too much difference, but let's get like 7 days, and then instead of doing it for 1 hour, we can get it for 1 day, and then we can see like a week of data. So the lowest temperature of every day, the highest temperature of every day, how the day started, how the day closed. I cannot say they started or closed because this is UTC time, and New York is not UTC, it's UTC -2 or something. So we would need to also translate. But for the sake of just like exploring this data, this is a good thing, and we can follow in this way, right? And this is the basics of like using a kind of like candlestick pattern. And like we can also add more things, like, for example, standard deviation. So, for example, this is also quite useful. So I could also add here standard deviation of the temperature, and I can easily see here how much this is varying, and this is how functions, mathematical functions that comes with Postgres, and and then and then we also have this array aggregation. So sometimes we need to understand some specific, like why this is the highest, or like what data we have on this day. So for example, if I call here like array egg temperature, it will create a different column here, and now you can see like all the temperatures of a week. Let me just use the 1 day again, just to and instead of looking a day, let's use 1 hour, and then we can see less data here. So we can see generally we have like 4 samples, or sometimes we have 3, sometimes we have 5, but this is the basic of like every single day. So you can see all the data use it to build this. So array aggregates is good to just inspect the values, and this is also useful sometimes when you are querying some very complex things and you need to go deeper. So ArrayAg can help you. This is also like only Postgres until now. The only thing we are using is time buckets, and we are using hypertables. But you could achieve the same without the hypertable. It would just be not very performant as with the hypertables. And now I'm going to talk about the toolkit. So Timescale is a company behind the TimescaleDB extension. I work there, and I'm very happy to see how much data science and how much guys that are very proficient on math are working and helping to build the toolkit. So the toolkit is an extension that is all data science things for Postgres. So it's not coupled to TimescaleDB itself. It's just a set of mathematical functions, and you can use it with any Postgres database, and it works and performs very well with the Postgres extension because it knows how to deal with the partitioning, and most part of the functions, they also support a rolling window. So in Postgres we have like a window mechanism that says, for example, I would like to get, let me just confirm, yeah, I am alive. I would like to check how is the last 30 days, and then like when you go 1 day ahead, you just would like to get the last 30 days again. So you just shift to 1 day window, and then this shift to 1 day window, sometimes it needs to requires you to recompute everything. And the toolkit, it just pops the first day and push the next day in your calculus, and it's much faster and much more efficient. So I will start now with percentile. So percentile is a very nice thing that allows you to understand the normal distribution of the things, and how the distribution works. So for percentile, we have this percentile egg function, and we have several functions that are suffixed with _egg. So this egg comes from aggregation, and this is like a kind of not exactly a value. So I'm going to show you here, and this is when you see here, you see, well, what I'm going to do with this. And this is a very weird metadata from the percentile, and basically this metadata is a pre-computed percentile aggregation. And from this perspective, you can just like prepare your data, pre-compute it, and then you can extract several statistics from the same function. So instead of just like compute the 99 percentile or the first quartile or the median, you can just compute it once and then extract several values from this slice. So this is like a middle term object that is in the middle of your calculus, and then you can pipeline this to another functions that will allow you to play with that much better than just like extract one thing and then compute it again, extract another thing. So sometimes you are just trying to understand the distribution of the values and you want to check several percentiles. So you process it once, extract all the values together. So let's go and process the first thing. So the first function here that we're going to use is the median. So the 0.5 percentile is in a normal distribution, it would be the median. If you imagine that bell curve that you have, this is basically the percentile egg thing. Okay. And is it okay with my screen? Looks like.
Oh, well, you're not sharing your screen anymore.
Oh, okay. I'm sorry. Okay, so now you can see my screen again?
Yes.
Okay, thank you. So in the previous query, I was just showing the percentile thing here, and this is the metadata behind the percentile. And when I got into this metadata, I can just use functions to make the percentile work. So I will just go to the first one that is approximate percentile, and this is going to show the median temperature. So as you can see here, we get like the median temperature from all the days, and we have here observing one 1 month of data, and then we are talking here about several months, and every month you have the median temperature. And then if you think about the median temperature, it's not saying too much, but we can also add more data. So for example, before I move into this, I just need to share this very cool thing that is we allow this kind of pipeline operator. So if you are familiar with functional programming, you know that we have the pipe concept. So you can keep piping things. So and what we have here is a very similar thing that is just like we swap the function position here to be using this kind of a row, and then we just call. So this is exactly the same as the previous one, but this is allowing us to pipe several functions, and most part of the functions also allow to be piped into other functions, and there are a set of functions in this regard. This is still an experimental feature. I'm just showing you just to allow you to maybe explore it later. It's not definitely going to the official API, but this is something that we are looking for feedback. So if you have any idea there, just feel free to share, and any feedback you have, it will be very interesting. So let's process several percentile now, and in this example, we are going to check the first quartile, the median, and the third quartile, and that would be, and that's like exactly. So for example, if you get here November previous year, we have like a minimum temperature of 3 in the first quartile. It means like the first 25% of the lowest temperature, like we are ordering the temperature. So in average it was 6, but the maximum was 11, and then we have this. Let me just force the screen and just make it fit. Right, so now we have it fitting the screen, and you can see here a few months, and you can also understand here how is, like, for example, the median temperature, the Q3 temperature. So, and then, for example, if we go here and edit this, let's say, for example, we call here the 99 percentile. So the 99 percentile would be the highest temperature, right? So and then let me just reduce a bit. Yeah. So for example, you can see here, even November, and like the month that we have like -5, we still get like 12 degrees. So this is very good to just understand the distribution and what are the edges and the extremes. And yeah, so this is also possible. And Postgres has some percentile function and allow you to get the percentile disks, but this is much more cost much more to the process, and it's much more expensive to be processing. So that's something that like we are very excited to share, that this is very performant, and this is also used to cover more of like window function and things that will allow us to play with this very, very fast. So for example, here I have one example using CTE. So CTE is a custom table expression. So we just say with some naming as, and then we have a query. And then instead of like querying from the table again, we can query from this name. So we can say like with 1 month. So this is 1 month processing of percentile egg. And so this percentile egg, as I didn't name it something else, it's just named the percentile egg as the function name. And here, when we select it, we can select from the percentile egg, and then we can keep nesting and building very complex queries. So this is the same as the previous, just using custom table expression. I'm not going to run it because this is the same. And let's move on. So the next function is stats eggs, that comes from statistical aggregates, and this allow us to have like several statistics from 1 dimension or 2 dimensions of data. So let's start with 1 dimension, and later we are going to also correlate data with 2 dimensions. And with 1 dimension, you can see here that we can just we will have a very similar thing from the percentile eggs. So this is a bunch of pairs of metadata that we cannot understand too much, but this is good because we can also extract things. Like I can extract the average. I'm not going to run it just for the sake of the time, but this would like do the average as we did previously. And then the thing is that you can reuse it. And then the most important part is the roll up function. So all the aggregations that we have, they allow us to roll up things. So roll up means that you can start, for example, let's say you have already processed some time bucket of 1 hour, and then you have statistics based on 1 hour. So for example, I would like to know the maximum or the count of last hour, or the minimum, or things like that. And then you just decide to go to 1 day. So 1 day, and you can just reuse the 1 hour thing. So for example, here we have the with hourly, and then we do the one day based on the hour time bucket. So the hour time bucket was named here, and then you can resize it to a bigger resolution, and then you can take the average here. And the average will not be the average of the average. but it will consume much less process because it will merge the metadata from different aggregation methods. So this is a very advanced technique that will allow the user to be playing with like data in several resolutions, and instead of just like reprocessing everything, you can reuse pre-calculated chunks of data, and that's a very, very cool thing. And it's also very, very fast. So you can see here, it just processes everything in 13 milliseconds. So yeah, this is quite good. And then you can see, for example, here we are processing like with 1 hour, and then we are processing 1 day, and then, for example, in this case, it's like a month of data processing in this time. And then, for example, if we go here and get this example, we go to 1 hour, to a day, to a month, and then we can get, for example, an entire year here, for example, and everything was 13 milliseconds. So this is still very, very fast and quite useful to be reusing this. Here is another example, just like another kind of methods that you can extract, like variance or standard deviation. And numVals is also quite good. For example, I will just add this, the numVals here. So for example, I have the average, and then I can have numVals from the monthly aggregate. And then you can see how much records are inside all these aggregations. So you can see some months of data. So it's a few thousand records per to calculate every number, right? And now I'm going to go and just cover the CAGs. That's the most cool thing that we call CAGs, but the name is continuous aggregates. So continuous aggregates is the name we call for materialized views for the hypertable. So you can just create a query that uses this time bucket function, and then you can materialize it. It means that you are not going to reprocess it anymore. It's just going to be processed once, going to a materialized view, and then you can reuse. And you can also use these pre-computing objects, like statsags can be like a column of your materialized view, and then later you can extract any statistics from it. So it's very, very interesting and good for this. And I already have the materialized view here, so I'm not going to cover this, but this is exactly the same, just another materialized table, and then you can just use this row up under the materialized view, and then you can reuse your previous calculated data, so you are not going to reprocess the rows from scratch again, right? And we are now going to announce soon the ability to work on the one continuous aggregates in the top of other continuous aggregates. For now, you can just use regular views, and that will save much more and more things, because you will not need to reprocess. But if you need, you can just use a regular view for now, and it's the same. Here I have another example with candlesticks, and this is how a table is created. So a hypertable, you create a regular table, and then later you just convert it to hypertable, and then you call it like ticks, for example, is the name of the table. Time is the column, that is the time series column that will split the data. And then you have several configurations. So here I just put the chunk time interval, that is like 1 day. So if the table is receiving like millions of data per day, I can just like split one table per day, or one per week, or one per month, depending on your case. And here I'm just going to show this is open, high, low, close example, similar to the previous one, but using the Toolkit method, that is also good for this. And let me just jump into the last example. I'm just wrapping up now. And this is a correlation. So I was thinking, how can I know the weather temperature correlates between each other. So I was thinking about this, and I got two random cities here. So I am just getting like 1 month average of temperature of New York, and then from 2010 to 2021. And then I have like the same for Nairobi. So Nairobi is in Africa, and New York are very far from each other. And then I was just building this. And here in the last part, you can see I got like a time bucket of one year, and then I have covariance and also the correlation. And here you can see stats eggs just with two params. So I have like the New York average temperature versus Nairobi average temperature, right? So this is a very nice thing that you can do, and it allows you to correlate the data. And then you can see here the correlation of each month. As you can imagine, New York is colder than Nairobi, and then you can see here that the correlation is negative. So, and 82% correlation is not that bad, not very good too, but this is some correlation. So they have some kind of like similarities in somehow, right? So when correlation means like when someone is going up, the other is going up. When something is going down, the other is going down. So this is able to extract this kind of correlation. Covariance is quite similar, and now I my next challenge was like, can I build this like for every city to every city? So that's the latest challenge here. So the correlation matrix. This is a very widely adopted algorithm into Python. We have like on pandas, you can just call like the data frame dot core, and it will just create this correlation of any data. And here we are going to use the table func. So if you check the extensions here, you can see, oops, sorry. You can see here that I have a few extensions, and table func is also here. Table func is an extension that comes with Postgres, and it allows us to do a cross tab thing. So the cross tab thing is just allowing us to use the names of the pairs as the city names. So for example, this is what we are going to do. Oops, I just get one extra line here. So for example, I'm going to correlate Austin with Austin, Lisbon, Nairobi, New York. This is all the cities I have. And then I'm going to correlate Lisbon to Austin, Lisbon to Lisbon, Lisbon to Nairobi, New York, and so on. So this is the matrix of correlation. And like here, it's not a matrix because we are just looking the data as a pairs of names, and we are looking for all the combination of names between the cities, right? And this is our first step, but we can use this cross tab function to make it. And what we have here is the pairs of the cities that we explored before, and then we have this summary. So the summary is like the average temperature per hour from a weather matrix from 2010 to 2021, and then we can finally go and just join the correlation between average of two cities. And here in the end, I have this kind of like a query where I just put here the name of every city with a double precision, because this will allow us to cross-tab this thing. And this is what we are going to run now. So if I just run this thing, you can see that it's not the fastest thing in the world, but in 8 seconds or 9, it will be able to just like correlate all the data. So 10 years of data from 10 different cities. And this is, I will just reduce the font size to be able to check this diagonal. So you can see here 1, 1, 1. So 1 is a perfect correlation. So New York is here, New York is here, Austin is here, and Austin is here. So the city correlating to itself is 100% correlation. So, and if you try more data, it will be less. And then like here you can see, for example, 93%. So who is correlating 93%? It's Toronto. So Toronto is very closer to New York, so they have a similar weather and they will be correlated. And we can see low correlation in other cases and so on. So this is the power of the of just like exploring queries. If you see here, it looks like a monster query, but this is not anything hard. It's more about like reading part by part and just like creating the right pieces to be exploring it. If you are interested in learning more about Timescale, I would strongly recommend you to just join the Timescale community. We have a Slack, we have a forum, and we also have the GitHub. I am always helping on Slack, and if you have any questions, please feel free to reach out. And we also have these docs at Timescale that's very, very good. You can go to the API reference here, for example, and then you can find several things about how everything works here. So, for example, I was showing before the rollup, and you can learn about how the rollup works. And then you can see examples here and things that can help you to build your data science under Postgres database. So yeah, that's all I have for today. As I mentioned before, my name is Jônatas. Feel free to reach out to me on LinkedIn, Twitter, and yeah, you can find me as Jônatas DP. So thank you very much.
Yes, great. Thank you, Jônatas. Your presentation was very interesting. Thank you a lot. I hope that we will meet for a few time on Q&A session. And I'm welcome next speaker. Supriya, are you here?
Hi, Lilia.
Hello, Supriya. Nice to see you. How are you today?
I'm doing great, and I hope you are also having a nice day, hectic day.
Yes, thank you. I'm very happy to meet each speaker here, and I could see you and talk with you. So let me introduce Supriya Raman. It's data science in JP Morgan, and today she will be talk about the action plan on how to implement text analytics in banking. So Supriya, the stage is yours.
Thank you so much, Lilia. I hope my screen is visible.
Not yet. Oh yeah, now it's visible.
Okay. Thank you. Today the topic is about the text analytics in banking, and I will be specifically talking about how we are using natural language processing in order to solve different use cases across banking. I'm Supriya Raman. I work as a VP Data Science in JP Morgan Chase under KYC and client onboarding team. I've spent 16 years in banking, and today's session will be mainly to discuss about some of the use cases I have worked on in banking using text analytics. This is the agenda for today, where we will be talking mainly about why do we need text analytics first of all, what are the common areas of application in banking, and we will talk at a very high level about how the different data science framework look like when we discuss that. And of course, when we talk about the data science framework or any machine learning algo which we apply, most of the time which we spend on the models are about the text pre-processing. So some bit of how we do the text pre-processing is what I want to cover. Then at a broader level, I want to cover two of the use cases on which I have worked on. And at last, I would like to talk about some of the considerations which we have to be very particular about when we are talking about the text analytics. So to start with, I'll like to start about how the communication with the machine has changed over a period of time. The first picture here, it shows about the punch card reader and the punch card machine. So earlier we used to have cards on which we used to punch the information and we used to share it with each other, right? It was a very hectic task, taking time to punch it and then read it. It was bulky cards which we were carrying. The second era came where we had the black screens, which are mainly the AS400 and the mainframe screen. Although it might sound legacy systems now, but they are very relevant specifically in the finance domain, and most of our core systems still sits on mainframe systems. The third picture here, it shows about the chatbots, and almost all the domain and all the platforms now require chatbots, where before we actually interact with the operator, we can have some kind of interaction, valuable interactions, which can be facilitated using bots. And the last picture is about the talking machines, which almost all the households have, although they are talking in speech. But then again, we have speech to text or text to speech kind of conversations, which we do in order to, facilitate again the text analytics. So with these communications changing, the way the communication has been changing, and of course thanks to social media also, where we are collecting a lot of data, mostly unformatted, and also the digitalization which has happened, and again thanks to COVID, almost many things got digitalized. The data now is not only huge, but it is also growing exponentially. When it is growing exponentially and we want to derive some insights out of data, we need very skilled tool sets, and that's what we were talking today, that how to do analytics on such data which are very huge, but we want to derive insights out of it.
Oh,
So
I'm
to
sorry,
understand the
Supriya. I'm
text,
sorry, Supriya. Give me moments. So, for better visual experience, can you please share your PDF file differently so people can have better look at your slides? So, can you click present down there and click slides, and then choose this PDF file to upload? So, I'm so sorry for interrupting you, but this will bring much better experience. Ooh, yes, just like that. Thank you.
is it okay now,
It's perfect.
Nick?
Yeah, it's perfect. Go on, please.
Okay. Thank you, Nick. So yes, the when we are talking about, the text, basically we have mainly three steps in which we deal with the text. And the first phase of about understanding the text is about the lexical processing, where we try to understand a text as is. We just ignore the context of it or the grammar part of it, but we just want to understand the meaning of each of the token, which can be a word or sentence. And the best example about the lexical processing here is spam ham classification, where you have emails and you won't just want to classify it into spam and ham. Once you start understanding the word as is in the lexical processing, the next phase and the second phase is about the syntactic processing, where we are more bothered about understanding the language or the context of a particular sentence. And that's why parsing or understanding the part of speech become very relevant. When we say part of speech, whether a particular word is a noun or a verb or whatever, and not only that, we are more bothered about understanding whether the particular word is a subject or a predicate or an object, and so on. For example, you take two sentences, say Ram thanked Shyam and Shyam thanked Ram. Going through the lexical processing, actually both the sentences mean the same, but if you go by the syntactic processing, actually two sentences mean very different, right? So that's what syntactic processing is. The last phase is about the semantic processing. When we say semantic processing, it is mainly understanding the text beyond what is provided in the document. So for example, as a human, when we hear a word cat, immediately we can relate to an animal which has two eyes, one tail, and so on. But when we are processing a document where a word cat comes, can our model do the same thing? Like, can our model can also understand that when we say cat, it is such kind of animal which we are talking about? So for that, in order to provide the syntactic processing, we need extra information to be supplemented along with the document which we are processing. And that's why we have general knowledge or the domain knowledge is very common in the domain, where we have very specific taxonomy, like example healthcare, where we have the words which are very specific to that particular domain, and we need to supplement the document along with the domain specific knowledge. Discourse context is where the same word can have different meaning at different contexts of the sentence. The simple example is, take the word bank. The word bank can also be a river bank, but at the same time it can also be meaning a financial institution. So when you are processing a document in the semantic processing, you're not only talking about a document but supplementing it with other knowledges. This is a very common example of semantic processing where we are talking about the semantic processing, and if you don't supplement it with extra information, then you can derive different meanings out of it. uh, I want to quickly touch on deep learning. Most of the tasks which we were doing by the native way of semantic processing, of course, the there are a lot of libraries which are available in order to do the semantic processing in a native way, but they are getting replaced by deep learning architecture. When I say deep learning architecture, it means neural network and reinforcement learning hand in hand. But at the same time, not only these, with the recent advancements which we have more of a encoder decoder kind of model or transformer based model, which started with the Google launching the bird, and then we have so many other models which are now more relevant. These are pre-trained models which are trained on a huge corpus, and they give a very high accuracy when they are being worked onto the text. So when we talk about the semantic processing, the text analytics go hand in hand with the deep learning architecture, and we are using NLP along with deep learning. Text encoding. Now, whenever we talk about text, we have to understand that text is not something which a computer can understand. We cannot handle text, although they are processing text, and therefore we need mechanism by which the text can be converted into numbers, because that's how they has to be encoded. Because a computer only understands zeros and ones. So these are very basic, and of course the libraries does it internally. But it is important to talk about the encoding standards. The most basic encoding standard which we had was ASCII, and ASCII was the first encoding standard which was launched. But however, it can handle only some English characters. Only it was limited only to the English characters because of the limitations of the number of bytes which has been allocated to it. And later we had Unicode standards. So we have UTF-8 and UTF-16, which are more relevant when it comes to encoding, and that's what we are using today in most of the libraries. These are some of the examples about how the encoding happens. And now, talking about corpus, I talked about corpus. Now, whenever we're talking about the natural language processing or the text analytics, it requires a huge amount of data on which the training can happen. And specifically, when we talk about deep learning, it is about training it on a larger set of data. So those corpus has been provided by different means, and the most common which we have is a pen tree bank corpus, which provide 1 million words, which has been passed by WSJ, which is many other corpus which has been provided by, and different libraries or different packages which we are using for natural language processing has been trained on different type of corpus. As we talked about a domain. So if we are domain specific knowledge, then we have corpus which are very specific to those domain. I'd like to talk some of the common areas of application in the banking. So to start with, the first one is about the social media analytics. When we talk about the social media analytics, it is specifically about understanding how the social media is reacting to our product, or how the customer is reacting to some of the services which we provide. And it is very important to get that vibes. Now, of course, we are talking about banking, but going off beat and talking about Bollywood, Rohit Shetty is one of my favorite director in Bollywood, and every time when he releases his movies, he says that he want to be in the theater himself in order to catch the first hand expressions of the customers who are seeing his movie. But not everyone can be him, and thanks to social media, we have the platforms where we can gather these emotions or the sentiments which the customer have when they interact with our services and our products. The next use case is about the loan or the insurance origination. So whenever we submit any loan application in a bank, right, or in any financial institute, most of the information which we cover are gathered through different type of data, different type of text boxes or check boxes already which is present in the application. But at the end of the application, you are provided with a free flowing text box where we are asked to fill up why do you need this loan, and that free format text is generally captured in order to again capture why the real sentiment about the customer, why they really need this loan. So those kind of processing require again the natural language processing experts to work on those sentiments. The third one is about the text summarization, and of course, text summarization can be done by different algos of the extractive summarization or the abstractive summarization. But in nutshell, we have a lot and lot of documents which we are available in the banking, and if you really want to derive the summary out of it, we need natural language processing again. Chatbot is something very common, and of course chatbot, one quick example of chatbot which we actually implemented was during the COVID period, with a lot of calls which were the operators were getting. It was very difficult for the operators to handle all the call during the COVID period, so we installed a small chatbot which can do a first hand interaction with the customer. And with the interaction which it was able to do, it just used to classify it under the 8 products which we had. So with the interaction which it has, it just try to figure out whether it is for the loans or the deposits, or which particular product the complaint has been raised for, and it used to direct it directly to that operator, and which used to save a lot of time for the operators. The next one is about the sentiment analysis, and the most common use of sentiment analysis is, of course, when you are trying to, sense the behavior of the stock markets. That can be one very common use case which we have in banking. Customer segmentation, customer segmentation, when you are trying to understand your customer, whether it is through CRM, or whether you are doing any preferred customer management, or whether you're talking about CIS, which is customer information storage. Any kind of storage which you are doing for the customer, it always start with the customer segmentation, because you cannot apply the same rule to all your customer base. So it is very important that you know the segment under which the customer lies, and the customer segmentation is, of course, a critical phase of all those customer information systems to maintain. Recommendation system, again, a recommendation system works very well when we have app personalization. When you're providing an app to the customer, the app should be personalized according to the customer uses. The product which a customer specifically is using, or which they would like to use, the app should be personalized to that, and we should make the recommendation. And those are some of the use cases on which we are working on. Fraud prevention is a very common use case which is relevant in the banking. But then specifically when you are doing the fraud prevention, the most critical part of it is what kind of data you are using. So if you are just basing it on the transaction data, again, the transaction data can be a daily transactions, or it can also be the transaction history of a particular customer. You can also use KYC data. If a customer is a preferred customer, you will have more information. So there are a lot of information which a bank hold for a customer, and the model enrichment depend on how much relevant data can be collected and pulled into the model in order to supplement it, in order to do the fraud prevention. The last one here is about the data enrichment, and data enrichment is again a very common use case which we have in banking, specifically knowing that we collect the data from multiple sources. So some of our data which is there in banking are on core platform, which can be legacy platforms like mainframe or AS400, while we also have data through data warehouses like Teradata, and different type of databases. You can have SSIS, or you can have Oracle DB, and even you have data on clouds, which can be again on premises cloud or a public cloud. And when you're collecting data from different sources and collating it together, and again we are talking about huge amount of data, so we need techniques which can quickly enrich the data from one source to another, and they can harmonize the data together. So that is one of the common use case we have. With that, I will quickly switch to some of the common framework which we have. So on an average, whenever we talk about data science in banking, this is the common life cycle of a data science model, where we always start with the business understanding, of course, understanding the domain knowledge. because the more expertise you have in domain and the better you can understand the domain, it is more quicker to understand the business requirement, to see see the problem statement from the lens of a business, and then freeze it. So understanding the business requirement, soon after when we freeze the business requirement, we go on data acquisition or data collection, which is a data engineering phase. So collecting data from different sources, pipelining it, and putting it on a common platform where we can do the analytics further is the second phase. The third phase is about the data pre-processing or the processing, where we make the data available and standardized in the format in which the analytics can be done further onto it. So that is data pre-processing or processing phase. In data exploration, we do a lot of data visualization where we analyze the data either one attribute at a time, that is univariate analysis, or might be multiple attributes at a time. For example, again, if you are checking about the salary and the age of a person, salary and the age has a high correlation between the two variables. And if you do bivariate analysis, you can have very different kind of findings rather than doing each attribute study at isolations. So those kind of exploration is the fourth stage. And the fifth stage is, of course, the modeling. Now, when we talk about the modeling, of course, we have supervised modeling or the unsupervised modeling. Many a time we talk about the deep learning, and we also have most of our projects, of course, is based on NLP. So that is the phase where we actually do the modeling onto the data. And the sixth phase talk about the data evaluation, model evaluation, and the deployment. Many a times it can also be that the model, you need not deploy it because all the business wanted is some insights. So there are use cases on which we have worked on which does not require a proper deployment, but it is a specific, it is a very specific requirement where you want the model into the production and then you have to deploy it. That is the sixth and the last phase. And this is a very particular framework which we have where, instead of talking about all the life cycle, different phases, I've just summarized into the five major phases. And then I have given the percentile. So of course we start with the business requirement, which require 5% of the total allocation of the work estimation. Data understanding again take quite a huge time, and that's why it's 10% classified. Data preparation and analysis, I have marked it as 50%, because every time when you have data, making the data available in the format on which the modeling can be done takes the maximum amount of time for any kind of model. And that's why this is the phase, the third phase, which is data preparation and analysis, is the biggest phase for any of the data science framework which we have developed in banking. The fourth stage is about the machine learning or the NLP algos which we apply. This can even be a very optional phase where, if you just have to do analytics onto it and might be visualization, you might not require the fourth phase at all. And the last phase is, of course, the delivery and the results, where you provide the data back to the business. It might require particular visualization in a particular format, which can require dashboards like Tableau or ClickSense or ClickView, Power BI, or it can just be reports which has to be generated in some format which the business is looking for. It also required a model to be deployed, and then maintained. Of course, when you deploy the model, then of course the maintenance part is where we are talking in the last phase of delivering the results. Talking about the text pre-processing. So, as I said in the previous slide, most of the time of any of the data science projects we spend on text pre-processing, which is making the text exactly in the format in which it is required, or standardizing it through different sources. If you're collecting data from different sources, so you standardize it so that a common processing can be done to it. And the most common method by which we can do the text pre-processing, of course, the regular expressions, as long as we can identify some pattern. And the most common example, as I mentioned here in the slides, are tweet hashtags or phone number. As long as we can define a pattern out of data, we can quickly process it using regular expression. And it's the most easiest and the fastest pre-processing steps which we have in NLP. This is about the zip law, which talks about, you know, if you talk about any document which is quite of a good, length, not very small or not too huge, and if you talk about the frequency of each token in that document, and then with the highest frequency, the token which is the highest frequency should be given a rank of 1, the second token should be given a rank of 2, and so on. So if you take the frequency of the word, multiply with the rank of the word, you get some kind of constant, and if you try to graph it in a xy axis with the frequency of the word versus the rank of the word, you will get a graph with a blue line here which has been shown. And of course, using this statistical parameter which we have, if we can figure out what is the upper cutoff and the lower cutoff of the frequency which we are expecting to process, so anything which is above the upper cutoff of the frequency, it is marked in the green color, and these are the stop words which we don't want to process into our document. So of course, most of the document which we have high volume of stop words and which are marked in the green color, and they need to be eliminated. Again, there are words which are, which has a higher frequency than the lower cutoff, and these are the rare words which are marked in the documents. For example, if you are reading a document on Sachin Tendulkar and you come across a word Nigeria twice or thrice, might be it is not relevant, and says it is some very low frequency word which is present in a document and you would like to eliminate it. So eliminating the eliminating the green color text and the yellow color text which we have, everything which is marked with the shaded region here are the significant words, and those are what we want to process in our documents. Tokenization, as I talked about, tokenization is as simple as it is shown in the picture here. If you have a sentence, you tokenize it into word, but word tokenization is not only what we need. We need to tokenize it into sentences. We also do Twitter tokenization, where we have a specific tokenization where the tokens are specific to the Twitter, where we can identify the emojis or the hashtags. Also, we have regular expression tokenizer, where you don't want to process everything which is written in a huge text. If you can define a regular expression and you can just tokenize it using that regular expression, you can quickly extract all the tokens which are relevant to you. um, the bag of word, of course, we have very good libraries which are nowadays available in order to create the bag of word. Starting with the deep learning architecture, we do have deep learning, but we also have word to vec or globe or other thing. But explaining the bag of word in a very nutshell, this is what it means: that if you have different documents, here I have 3 documents, and assuming each document is containing one sentence at a time, if you arrange this document in form of a row and you remove all the stop words and you only take those words which are relevant to you and map it on your columns, and you just mark the presence of each token by 1 and the absence of each token by 0. So this will create the basic bag of word. Of course, this is a very simple way of creating the bag of word, and it is highly fluctuated by the frequency of the token which is there present in the document. So this is just for the understanding of how the bag of word has been created by many of the models which we have. And TF-IDF is another way of creating the bag of word. So as I said, in bag of word, frequency of the token matters a lot, because if you have a very high frequency of a token, right, and it is relevant, it is the frequency of that token is very high in all the document, that means it is not relevant to that, not relevant for us, and that can be eliminated. So TF-IDF is one of the model which help you create the bag of word by eliminating all the terms which has a very high frequency across all the documents. It actually penalizes it. So that is TF-IDF bag of word. Again, when we are pre-processing, we actually want to make the bag of word very compact and we want to reduce the number of tokens which we are using. So if you have different format of the same word, as in the slide we have warm, warmer, warming, and warmed. These are different format of the same words, and they actually mean the same. So we need not process them all differently, but we want to reduce them to the base word. So there are two algos for which we will be discussing on. One is stemming, which actually follows the rules, which works on the suffix of the word. So as the picture shows, it has rules which has been defined, which actually truncate the suffix, and it creates the base word out of it. And we have different type of algos for the stemming. So we have Potter stemmer or the snowball stemmer, which are there in the basic NLTK libraries. Also we have lemmatization. Lemmatization again is very similar to stemming. It tried to reduce the word to its base format, but in this case it is not trying to use any algos on the suffix or something, but it works on a dictionary lookup. And that's why lemmatization performance is much better than the stemming, because it actually do the dictionary lookup for the each word variant, and it try to derive the base word. But the context of both of these algos is the same, that we want to derive the base word out of it, and we want to make up the bag of word more compact for us to process it further for the models. Phonetic hashing is the another one, where you have words which sound similar. If the words are sounding similar and we have such words in our bag of word, they can be again made more compact by reducing it to a single word. So example is Bangalore or Bengaluru. These are two different words, but they actually mean the same, right? So if you have similar kind of word which actually sounds alike, they can be reduced to the single token using very simple soundex algo. And I do have a very simple algo which is here, but then there are many other algos which are relevant in the market, and they are very easy to implement using NLP algos. Edit distance or the spelling check is another one. So writing on a social media, it is very common that we do wrong spellings, and we do generally don't check the spelling when we are writing on a social media. And when you are processing such kind of text, it is very important that we do the spell corrections much before we process the, if you have huge number of misspelled words, then a model might not may be very relevant, because it is processing corrupt data, right? So correcting those spellings is what the next algo is about edit distance or the spell checks. And we again have very simple algos which help us to do the spell checks and calculate the edit distance between the misspelled word and the correct word. So with that, we come to the use cases. Now, we already talked about several of the pre-processing phases which we have to process. I'll be talking about two major use cases which I have worked on, and the first one being about the customer complaint classification. So this is one of the use cases which is very simple to implement, and we worked across this again when we had the COVID period. And we had a lot of complaints, as I said, coming from the customers. And because the complaints were very huge, many a time these complaints can also be breach. And breach has a very stipulated, if you have a breach complaint coming, then there are very stipulated time which has been allocated to you in order to resolve it. So it was very important that the operator can quickly understand which are the breach and which are not the breach, and the breach complaints should be addressed at a higher priority. So we put a very simple algos. The data understanding was, we had the complaint database which was hosted on the Teradata, which was our data warehouse. And then we have the company breach data, which was also present for all the Australia banking. So we were extracting the breach data from the Australian banking hub. For this was for one of the Australia bank I have worked on. Again, as I said, because these are customer complaints, these are user written complaints, so they were not formatted properly, and we need a lot of pre-processing. So we did very basic pre-processing, like removing the stop word, creating a TF-IDF bag of word, using regular expression in order to standardize it, using stemming and lemmatization in order to reduce the bag of word, and also using soundex algo in order to filter out the similar sounding algorithm. Another major challenge with the data was the ratio of the breach record to a non-breach record was very small. So there were only 0.2 breach record across 98.8% of non-breach record, and that means there were a high imbalance in data, and therefore we took the oversampling methods, like stratified sampling is something which we use, and also we did SMOT, which is a oversampling technique in order to do a proper sampling for the data. As the statement itself talk about, it is a binary classification, so we started with the logistic regression model onto this solution, and later we switched to the random forest, where because random forest help us with a lot of hyperparameters which can be tuned by the user. And later, because we has a huge amount of the complaints which has been available, so we also have implemented it using BERT, which has provided a better accuracy for this model. We have used PySpark in order to do all the processing, because the data is very huge and it's a big data. We have implemented it using AWS Cloud, and the model has been deployed on AWS Cloud. So this is one of the model which we have. Another use case which we have is about the data comparison tool. Now, data comparison tool is a very basic requirement across many of the platforms which we have. We have data across different databases, different platforms, and every time when you integrate the data, or when you move the data from one source to another, you need to compare whether the data from this source is exactly the same which is reflecting on the other source. And because the data is huge, of course the traditional tools cannot help you do that. So we needed a tool, and that's what the tool does. The tool collect the data from multiple sources. The sources can be SharePoint, it can be databases, it can be as simple as an API, or it can be simple JSON or XML files, or it can even be flat files, or it can be your CSV or XLS files. The source can be anything, but we have developed a simple tool. The front end of the tool has been developed using Streamlit. It's a simple Python tool which has been developed and installed again on AWS SageMaker. And all the tool does is take data from any different sources and just compare it and generate the report. The reports are, of course, generated using Tableau dashboard, where it just highlights what are the matches and what are not the matches. Also, many a time the match and mismatch, if you have words like USN, United States, it might not have an exact match. So we also have lookups created in order to bridge those differences, and that has been supplemented as an input to the tool. So this is another use case which we have developed. The last part of the session today is about why text analytics is hard. And when I say hard, it simply means that when we are implementing text analytics, we have to be little more precautious about these topics which I will be talking about. The first is about the ambiguity. As I said, that a particular word can have different part of speech, and even in the same part of speech, it can have different meaning. Like for example, we talked about the word bank, and there can be many other examples. Say the word PM and the Prime Minister, right? So the word PM and the Prime Minister mean the same. We can understand it, but can I reduce that ambiguity for that model? And if I want to reduce that, I have to supplement my model with extra information. Again, we talked about tokenization, that is point number 2, and we said that we generally tokenize our text before we do any kind of pre-processing. But there are languages like German and Chinese, and there are some of the examples which has been given which are very difficult to tokenize just by using the simple tokenization libraries which has been available. And then we have to use better tokenization techniques in order to work on those languages which are not English. The third one is about the unknown representation. Unknown representations are as the the one example which I gave is about the word cat. So when you say cat as a human, you have a lot of uh, predefined information which you have in at back of your mind. And similar kind of domain knowledge or similar kind of information should also be supplemented in order to the model in order to understand the representations which are not well explained in a particular document. The fourth point here is about the expression. Now, English, talking only about English as a language, there are different ways by which you can express the same sentences, but and the tokens might be very entirely different, but they can mean exactly the same. So, how can you make your model understand that two different sentences with exactly different set of tokens actually mean the same, and then it again require extra consideration. The last 2 points here is about the unmodeled variable, where you have two pictures here, the rat and the elephant. As soon as we hear about rat and elephant, we can quickly think of rat is a small animal where elephant is a huge animal. But can we make our model also understand the same? And of course it requires extra information to be supplemented. Um, the last point is about the sparsity, where we talked about that most of the texts which we process have stop words or the unwanted word which are present in the language but which adds no meaning to the sentences, and that has to be eliminated before we actually start processing. And that's what removing sparsity or maintaining the relevant bag of word actually means. With that, I come to the end of the presentation, and I thank Lilia and the team of the Global Summit to giving me this opportunity. I hope the last 40 minutes had been meaningful and we had some bit of learning around text analytics.
Yes, thank you, Supriya, a lot. So feel free ask questions, Supriya, and I hope that we'll meet for 40 minutes for Q&A session. And I'm happy to introduce next speaker. Aisha, are you here?
Hello, can you hear
Hello.
me?
Yes, nice to see you. How are you today?
I'm good. How are you?
Thank you. I'm great. So this blog it's about girls' power in data science, I think. Nice to see you again, and let me introduce you. So today we have Aishwarya Nair. It's data science in Trivago, and she will talk about does social media create societal bias. So let's start. The stage is yours.
Sure. Let me start by sharing my screen, and I'm hoping it's visible in the right way.
Yeah.
Okay. So thank you for the introduction. And I work as a data scientist at Trivago. I work in the ranking and recommendations team, and I specialize with looking at recommendation models. And I'm passionate about how different kind of recommendation models work, what do they do behind the scenes, and how we have different kind of recommendations on different platforms. So this is basically an account of how I went about trying to understand how things work behind the screens for social media. And I have documented some things which I found very interesting, and maybe some things which are not very openly available or known to everyone, and I just wanted to share my knowledge about it. And I want to start with basically having an icebreaker and asking how many hours approximately do you spend scrolling on social media? You can, I think there is a chat section, and you can add your comments over there and I can see it. And to give you about approximation, I would say an Instagram influencer spends around 9 to 10 hours per day, but we are talking about an influencer, like they are doing their day-to-day job. So go ahead, and I'm very, very curious to see how many hours do you spend on social media.
So yeah, feel free to write in our chat and help Aisha to open this interesting term. Let's do
Yeah,
it together.
sure. Even you can respond and write some things, Lilia and the team. So I'm like always curious to know more, because as a data scientist, it is I like to see the distribution of data and how different people have different behavior, and I get to see what's like the average, who are using more than the average, and how does this distribution look like.
So
So yeah.
yeah, now I
Mhm.
saw some answers in our chat. So people write that 2 hours, 2 hours. So from 1 to 2 hours per day, people spend in social media. So it's, we can say it now.
Okay, that's also good to know, because I also looked at the average myself, and these are some statistics that can easily be available to you. So this is the thing that I looked from Instagram, and for me the average was around 52 minutes to 1 hour, and the most time that I spend is on weekends, like especially on Saturday, and the other days are variable, especially less on Sundays, probably because I'm going out and having a life and not spending time on social media. So I see that people spend around 2 to 3 hours, which is also kind of the average. And what this brings me to next is, uh, when I ask about social media feeds, what do you think it is? Are they only restricted to social media, or do you see different kind of recommendations in different um, websites? For example, feeds are a very particular term used by Instagram and Facebook to describe different posts or videos or things that you see on your wall when you start scrolling. And they are definitely recommendations, but recommendations are not just restricted to social media. They can also be on Twitter, where you have different tweets. They are also YouTube or Spotify recommendations for videos or songs that you would like. Even Google, all the links that you see on a Google search page, uh, they are also some kind of recommendations. There is an algorithm behind it to rank it, and all of this constitute or come under the basic science of recommendation systems. So they are definitely not restricted to social media, but is there any motivation, or is there any advantage of having such kind of recommendation or feeds for such companies? Like, yes, definitely there are motivations to keep it, because it attracts the user to like spend, I don't know, 2 to 3 hours or 1 to 2 hour approximately a day, for a person to keep scrolling through the screen and keep them engaged on the product. But in the end, these companies want to make money, and how do they make revenue out of these recommendations or feeds? So let's look at the basic question of what's the motivation. And for this, we would look at how different companies generate revenue. And first off, we would look at shopping websites. So, thinking of shopping websites, Amazon, and every other website where you buy clothes, fashion, accessories, everything. All of them also have some kind of recommendation. Maybe, for an example, you go to buy, I don't know, books on Amazon, and when you put books, some book that you want to read, maybe machine learning book that you want to read, and you're interested in data science and you're getting started, and you put a book which is uh, something on machine learning into your basket. The next moment you see that you're recommended other books which are based on data science or in the same field or books that other users who have purchased after purchasing your book. And what happens is then you also think, okay, maybe this book could also be helpful for me, and you end up adding that. And then when you add books, you are recommended other stationery, other materials, and in the end, when you start the checkout process, you have ended up buying a lot more stuff than what you originally intended to buy. So for these kind of shopping websites, the revenue model is kind of direct to customer, where all the products that you buy inadvertently give an advantage to these shopping websites because you bought directly from them. So the more you buy, the more they earn revenue from the recommendations. So these recommendations directly impact their revenue. Talking about different kind of recommendation systems, how can content streaming platforms be behind? Like, I know that when you are not scrolling through different social media, you're spending a lot of time watching Netflix, Amazon Prime Video, or even listening to music on Spotify and different other channels. So the revenue model for such platforms is a bit different from these shopping websites, where they want you to buy their subscription model. And the entire purpose of these websites is for you to get their premium version and buy a package. Until you don't buy this premium version, they show you ads. So ads and having revenue from ads is a way sorry, these content streaming platforms generate revenue. And when ads are spoken about, how can social media websites be any different? When is the last time you ever paid for a social media website? Like, have you ever paid money to create a Facebook account, or paid to watch a photo or video posted by a friend on Instagram, or anything else, right? So my parents always keep asking me, like, why is this so free? Like, I can use everything, nothing is paid, I can spend hours together using this product. Like, how are Facebook, Instagram, Meta, and all these other social media websites making money? Because they seem to be doing really well, right? And the answer is definitely ads. And that's also because a lot of companies look at these social media websites as their marketing platform. What they do is they run a lot of marketing campaigns on these social media websites, because they have lots of data for tailored content. They have lots of data regarding all the users that they have, and they can create custom ads for each and every user. Since they have data regarding you, your demographic, your preferences, um, they have the ability to create customized ads for you, so that the companies who advertise on social media can generate revenue. And a large chunk of this revenue also goes to the social media websites. And thus, they thrive on the ad revenue business. And this is a very famous saying from the Social Dilemma documentary, is that if you're not paying for the product, that definitely means that you are the product, and your data is being used to incentivize and generate revenue for different stakeholders or partners or companies involved in the ad. So this is about the motivation behind such companies to have feeds, to keep you engaged, to extract revenue, and to monetize um, different kinds of recommendations. But going one step behind, what is the algorithm that feeds into such recommendations or such news feed that you see? Like, why is it so relevant and so difficult to make a recommendation feed customized for you? Uh, there are many different reasons, and one of them I would say is that it heavily relies on user behavior. So you might have seen that not all social media websites um, rise into popularity. There were many different social media that just started and vanished. Like, I think a few years back there was something called as Google Plus, which Google started as their own social media site, and it quickly faded away. Nobody was on there. uh, People from an older generation might also know Orkut, and I also belong in that generation. Orkut was my first social media website that I joined. So now there is like nothing Orkut called as Orkut or anything very close to that. Even the new Gen Z generation don't know about what's Orkut. So it depends heavily on how you keep the social media website alive and how you monetize from it. And all this data is very, very necessary in order to create algorithms to customize your feed and keep the users happy and have daily active users on such platforms. Every click that you do on a website like this generates some kind of engagement score. And what do I mean by engagement score is that if you're creating an algorithm for recommending something, how would you know that a content is relevant for a person A or B? You would first expose, for example, a photo of a friend and see if this person either likes, comments, shares, or does any kind of interaction with this content. If it's a video, maybe pausing, rewinding, stopping, any kind of stuff like that. If it's like an Instagram story, are you swiping on it? Are you skipping it? Uh, any kind of interaction like this is considered like an engagement to the content, and this inadvertently goes behind the scenes to a recommendation system for the social media. The greater you engage with such content, the higher the rank of this content. And this is how a lot of the content that you see on top of your news feed or on top of your recommendations are content which became viral because everybody's clicking on it, everybody's sharing it, and everybody's interacting with it. So the more such interactions happen, the greater the content score for this content increases, and the more is the likelihood or possibility of you seeing that popular content. And this generally makes people addicted to scrolling more and more of the feed and seeing organic content. So the more time you spend on this medium, the more is the possibility of you seeing an ad, because in the end, the media website needs to monetize people, needs to monetize from people who spend more time. If you're someone like my parents, for example, who just check social media for messages from friends and family, possibly you might not see an ad. uh, if it's somebody like an influencer or someone like me as well, who spends around an hour scrolling through the feed, looking at and engaging at different content, there is a higher likelihood that I see an ad. There is a higher likelihood that different kinds of ad are shown to me the more I stay on this platform. And think about this ad as a revenue generation algorithm. How does this website, how does the social media website, for example, Let's take Instagram, for example. How does Instagram know when to show you an ad and when to show you an actual content? If you know, for example, you open Instagram today, scroll through the first 10 posts that you see, and then from the 11th post you start seeing ads. If you see this pattern happening every day, you might just know that you might just know when to stop. You might stop scrolling after the 10th post because you know there is just ads below it. If, on the other hand, the social media websites fills the first 10, and maybe not even 10, like 5 spaces with ads, same way as Google does, like the first 3 to 5 links, I guess, are sponsored clicks, sponsored links. How does that look then for you? Because you know that the first half of the screen is ads, you would just like directly scroll to the bottom and start seeing. So then the website loses revenue because now you're not viewing the ads. If what happens if you mix both of them, like one ad, one content, and keep doing this? This would possibly be a better way to keep the person engaged, because you want to see the next content after the ad, so you're also seeing the ad and you're going to the next content. So a lot of these recommendation systems and algorithms, there is like ton of data scientists and a huge data teams who sit and customize the ad algorithms, the popularity scores, and all this stuff, and try to get the maximum customized for maximum revenue and user metrics in order to make revenue. And if you talk about revenue, you can see for yourself the numbers for the last financial year, where Facebook, Instagram, and Twitter are raking in billions of dollars just by keeping people engaged on on their newsfeed and by clicking ads. So a lot of, and you might be thinking like, who clicks on ads, right? Like nobody clicks on them, but apparently people do, and that's how these guys are making money. uh, yes, Twitter introduced right now some kind of subscription models to generate much more revenue, but a major chunk, like major 90% chunk of their revenues comes from ads. And how does all this, like, there is obviously algorithms that feed into this, there are different kinds of ads that are shown. How does all this affect our society in general, right? Because I know all of us spend time on social media. A lot of us work on social media. There are different kinds of roles that are created because of social media. Nobody even knew of the word influencer or influencer as a job role, I don't know, even 3 years ago. So, how does this impact the society? You might have heard of the word FOMO, or fear of missing out on the latest trends. This is this is an effect caused, which is also called like the bandwagon effect, caused because you see the same content repeatedly being done by everything. Remember how a few minutes ago I told you about how the popularity score defines how popular content comes up on your screen? The same way, if there is a viral trend that's going, for example, an ice bucket challenge, or uh, during the pandemic, everybody was getting a pet. So now you also want to get a pet. So this, seeing that everybody has something or everybody is doing the same thing, creates a fear of missing out and leads to a bandwagon effect where you inadvertently do something which you don't want to do. And this is, according to me, bad, because this is some kind of influence that social media has on you, and this is inadvertently driven by these kind of popularity algorithms. And there is a term for this thing, it's called a popularity bias. which is very common in the recommendation systems, which is basically the social consequence of a majority rule. What you see on your social media is driven by the majority vote. So if you belong to the majority, that is very good, because that means the content is very relevant for you, and your feed is very customized and you are seeing things that you actually want to see. For example, right now the FIFA World Cup has started, and everybody around you is sharing posts, liking stuff about FIFA, and this content is appearing again and again at the top of your list for you because all your friends are doing it. But what if you're not a sports fan? What if you're not into football? What if your country's not playing for football and you're just not into it? What if you're interested in some other sport that you want to follow, and you're not seeing it? For example, I am very interested in Formula One. I don't see many people liking or following it. And I actually want to see that content, but that's not appearing because now I fall in the minority and the majority around me have decided the content for me. So this is something called as the popularity bias, which decides my fate on what I see. And if I fall in the minority group, then I'm at a loss because now the content that I see is not tailored for me and I don't like it. And this would then reduce the amount of time that I spend on social media. uh, you might think that that's okay, right? Because if you are the minority, you're a very small group, it's okay. For example, there can be also a recommendation bias that is created. Like, if all the purchases of cars or clicking on ads of cars are by men, then there is a very high likely possibility that cars or any kind of recommendation about cars are shown only for men. And since the majority of kitchen products are bought by women, even if you're a chef at a hotel where you're actually looking for something related to that kitchen product, you will never be shown that ad. Um, these are very small examples, but it could also affect things in a very biased way. There was a few years ago a very a game, a kind of like a pop quiz on Facebook, which was taken down because it had caused some kind of discrimination based on gender. It was a very I guess a nice pop quiz, I would say, where you were asked different questions about your interests, about your hobbies, and in the end they would predict what would you grow up to be. So young boys and girls of all ages did this quiz just to know where they would be. And the professions that girls got recommended were that of like a nurse, a teacher, which are predominantly female dominated, and the boys would generally get like doctors, engineers, or jobs which were predominantly male dominated. So this is something that causes a bridge or a huge gap in the society, where you're doing something for the STEM field, for the growth of women in tech. This is, say, telling to all those young girls that maybe tech or science is not for you. So there is a huge community which is also trying to improve and better this process. Apart from all this popularity bias and the personalization aspect, what does this also cross? So popularity bias can also lead to lowering the overall quality of the content. And what do I mean by quality? Um, Suppose you are shown a video of a person who sings really well, or someone who is an excellent dancer. What is the maximum thing that you could do? You might like the content, or you might write a comment if he or she is your friend. But that's it, right? What if in the opposite end, there is someone who is singing very badly or in a very funny way, or dances in a very funny way? There is a higher chance that you would share this video on your social media with a friend, share a laugh, or do something, or interact. So this leads to a viral content, and that's why a lot of people thrive on negative publicity, because it has a higher chance to hit, it has a higher chance to go viral. And this is also a problem because this affects the overall quality of social media website, and it in turn affects its revenue, because maybe during the pandemic I didn't want to go to social media because all it had was sad news. Or maybe there was this era where everybody was creating TikTok videos, and I was so fed up of it, and I just wanted to quit social media. So this could lead to a bad effect for even the social media companies, where in turn they lose revenue because of the users not being there. And all this leads me to say that popularity bias, as you now know, is one of the most common and also difficult problems to solve in recommender systems, because how the recommender algorithms works in general is that they rank based on a popularity score or the majority rule. So, how is it possible to eliminate or just do away with this popularity bias? Because, as I have been explaining for the past 20 minutes, it seems to be very, very drastic, right? And it's causing so much problems in the society. I would say that we should refrain from the word eliminate and ask ourselves how to control it, because that's much more possible to do it. And how to control for this popularity bias, and some ways to be conscious about it. There is no one right way to control for popularity bias, because like I've said, all the social media websites also rely on these popularity bias to generate revenue. So it is not in their interest to reduce for it, but there are certain things that they can also do. One is to keep checks on the popular content from over dominating. There is something very commonly known as the explore exploit algorithm in the recommendation world, where you explore for new and fresh content which people haven't seen, rather than exploiting content which is popular, which everybody has seen, which everybody's liked, and which would definitely give you revenue. There is a fine balance to balance both, and keep a check that these kind of popular content doesn't over dominate the website. So yeah, what are the thresholds? What are the different what is that sweet balance that you can achieve, where there is a fine balance between popular and fresh? So that's something that social media websites can do. Another thing is to scrutinize training data for features that can create bias. This, I would say, is not very trivial, because it depends case to case, and a lot of times it is very, very difficult. A very simple example, a very oversimplified example, is something that I can give you is the pop quiz that I said, where gender could have been a training data feature that went into this data. So what you feed into these systems becomes super important, because the machines might not be able to realize what's right and what's wrong, but we can definitely recognize that adding gender might cause some kind of gender based bias. So, looking at the training data, understanding how it works, what is the prediction, are there any kinds of bias, can definitely help control for popularity bias. And are there all the steps customized only for the social media websites who create this algorithm? I would say no, because as users, we are also using the social media, and we are also, in a way, playing a huge part in creating the content score, the popularity score, and deciding what content to dominate on everybody's screens. So, as users, if you regulate your interactions on the social media, you realize what you're clicking on, what you're not clicking on, how you're interacting. This can play a huge role in deciding what to and what not to present for other users. There are also, like I mentioned, huge teams in these social media companies which work behind the scenes to check over content which are offensive or even fake news. There are like huge teams which deal with fake news, and they deploy huge personnel trying to reduce the effect of fake news and see what is right and what's wrong. And if you see something which is fake or which is offensive or which shouldn't be there, there is always some kind of report button, or usually there are some places where you can report these kind of content. And it is definitely recommended that you do this, because in the end, machine learning models, they can mimic human behavior, but they cannot determine what is right or wrong. And we as humans have the responsibility to train these models intelligently and not artificially. So, with that, I would conclude my talk, and I would say thank you so much for being a wonderful audience, and I'll see you at the Q&A section. And I hope you guys enjoyed the session and have some questions for me.
Yes, thank you. Thank you, Aisha. Thank you a lot. Please feel free to ask questions to Aisha. And now we have the next speaker. So let me introduce Carlos. Hello.
Hello, my friends. Thank you, Lydia. Thank you, all the Data Science Summit 22. I hope I will share a good experience in my job related to the public health and open data.
Yes, thank you a lot. I want to say that it's the first time that on our conference, data science conference, as we have speaker from Peru. So it's nice to see you here today. So let me introduce you to our audience. It's Carlos Cardenas, tech director in EAE. And today he will be speaking about data and public health at fast experience. So Carlos, the stage is yours.
Okay, let me share my presentation. One moment. Okay, nice. Well, I hope I will be clear in this presentation. Let me know if my time. That is very hard to try to explain, because Peru is maybe in the top of deaths related to the COVID situation. There are different statistics related that, and a lot of work to did inside to the country to try to support different public jobs related to how to reduce the infection, how to reduce the deaths. My job was to try to understand in first the problem, how to use the data, like to drive and to support some maybe decisions in the head, in the government, in the president of different governments inside to the country. Let me introduce a little bit about the agenda, about the scope, and a little bit show how the Peru in the data picture, how we use that open data or related to that, how to try to improve our internal process to dispose different charts, different statistics, different methods using open data. Reuni is a data portal from the Peruvian government related to the health data, and other works related to that, but not related to the COVID, but support other decisions in the government. And a little bit about the conclusions, maybe this conference or this speak is more related to the people work in the governments, or maybe use open data, or maybe it's a good opportunity to understand how the people will work in a very strange and hard situation, and how to the opportunity to reduce and increase the performance, and reduce in this case the infection, increase the performance, and how to displace any tool to support decision using data. About the scope, how do you do a project in a adverse situation? The adverse situation was hard, political difficult situations. We lost 3 presidents in only 1 month. For example, in November 2020 was very crazy during the pandemic time. About the deaths, maybe I will show some data about that. All the families in Peru have a relationship with 1 or 2 deaths. Is a real number. But how the people support government decisions with that using data-driven is not only one concept, is how to support decisions with data management, how to increase our performance using the data. The data is a result of a manual process, or maybe automatic process during the day or during the week. It's necessary try to increase the quality of data in some manual process. For example, assigned to the hospital, exists a nurse, or maybe exists other person different to the medical staff, to put this data inside to one's system. This system maybe is in web, maybe this system using only servers in internal application, but this data need to write inside to the central servers and increase the performance for other internal process to show trusted data. Reduce the deaths, reduce infections is a KPI in our management, but it's very hard to try to understand how to use the data to try to resolve these typical tasks inside one government decisions. Then go ahead. Peru in data picture, how to try to understand my country right now related to the COVID situation, for example, using some accepted KPIs. For example, Peru situation is related to the infected person in total in all these, in the last 2 years related to the COVID, in more than 4 millions. And the number of deaths is near to the more than 200 million deaths. It's very high. Only our country have a little compared with Brazil. Brazil have near to 1 million of people dying. And United States have a lot, but in our country, in related that all the population is related to that 32 millions, then the rate is very high. Maybe if you try to review our working data, our working data is our resource to try to compare different data related to health, related to population, something like that, poverty also. the relationship is not good for Peru because this post we don't have maybe in the past good health politics to support and reduce the risks in this situation. Well, okay. Maybe during all this speak, I will dispose some data related in our sector, but in Spanish because it's the source. But I will try to resume the last picture, which that is the situational room. This situational room is a picture generated every day by the Peruvian government. In this picture, return different data referred to the how is the pandemic situation day by day. They close it because some KPIs are generated at night. For example, arrive the last data in the 11:59 before to the middle night, and some jobs inside to the servers working in that, and the result is one automated process to dispose this data. This data is very important in our jobs to try to support, for example, decision how to increase maybe the number of medical staff in one region or something like that. But it's very important to understand, for example, the hospitalized person as right now a few than other days. I remember in the peak of the COVID appeared early to 20,000 persons hospitalized. Well, after to review this data, I want to show how to work with that. For example, if you try to review our working data display different KPIs related to different statistics. One is related to the daily new confirmed COVID case. In this case, you want to watch, for example, the typical situations during the last 2 years. For example, is how to find the first way, the second way, and right now we're in the way number 4. But you try to verify, for example, when beginning this year appeared one way very high with a lot of infected person. Maybe the possibility to reduce the death and maybe reduce the time of infection, because there are one interval in between 7 to 2 weeks that one person is infected with the COVID. And the person don't increase the risks related to need maybe other kind of resources to try to attend. For example, no need to hospitalize situation, maybe no need to support medical services, only with try to dispose one rest, or maybe staying home is the good solution to try to resolve the infection. But right now, that was possible only with the vaccines. And in this case, the boosters doses received with a population object was very high, and that have the possibility to increase our performance to fight with the virus in Peru in different regions. This result refer to our working data is created from the government, like to a good policy to try to be transparent and be truths with the people and show the data to try to compare with the government KPIs, and with other data science if want to compare this data to try to understand if that maybe our government dispose the correct information and validate this information with that the data. They have the possibility to download some data sets and review the data. That's was very fine to identify, for example, some issues related problems inside to the data. For example, identify maybe today receive one number of affected person, but for tomorrow this number for this day increase or maybe reduce. That's a good opportunity to receive some feedback and increase our performance inside to the job. Inside to the datasabiertos.gov.pe, inside to this web page, you have the possibility to increase the possibility to verify all data sets. There are data sets related to the machines. There are data sets related to the patients. Maybe there are data sets related to the hospitalized persons. And also, there are data sets related to the deaths to try to identify numbers almost time. All data sets are anonymized. And with this opportunity, we have other community of persons outside to the government, in the power of the citizens, to try to support how to share this information with different other data source. For example, in this case, our working data. Our working data consumes these data sets and increase the charts and the visualizations charted inside to this page, and others people use this dataset for create our different charts different to the government, but with the same data and alerts. For example, in Twitter, for example, Juan Carvajal is a person who works every day with the public data and generate every day different charters inside to the COVID situation. For example, in different regions, depend of the years, or depend of the interval of years, or depend of the timing about the maybe compare regions or compare different months to try to verify is the COVID increase the infected or maybe reduce infections. For example, this is a good opportunity to complement the government data, increase the information for the citizens, for the people to try to understand is necessary preserve their life using different masks, for example. And inside to the government, after to review the data source, after to review if it's necessary, improve different charts, improve different reports, and use visualization of data. The government use datos abiertos inside to Reunion. Reunion is other portal. I show in this kind of work. This work is related to the vaccines process in different doses. For example, this graphics is related to February, but right now there are other more new, and the URL is the same. With this information, the government dispose, for example, the different vaccines campaigns, different. For example, related to the different regions, or need to increase, for example, the doses, or need to increase the name is the quota related to the booster number 1, the booster number 2, something like that.
Other are more related to visualization data, refer to the number of deaths, number of infected persons, was created that to try to have a good tool to use observability. And with this tool, combine the different KPIs, we had opportunity also to create other risk map to try to identify where is the region or the district that needs more support with the government. Maybe need to dispose more medical staff or need more resources, something like that. For example, in this case, was the first risk application to try to support by region, but with some feedback from our community, and you see in this case different KPIs and different segregated resources to show by region and different KPIs. We dispose other solution. For example, this solution was related to the queues inside to the hospital to for example, queue related to test to verify you have COVID or not, or maybe a queue related to receive a boosters related to the vaccines in COVID. And also was a good solution for the people, for example, to try to prevent spend your time in the queue and maybe have the possibility to visit other medical hospital. And this KPI was a good opportunity also to create like to dashboards to try to summarize different KPIs. For example, the infected person refer to the CDC. CDC is other part of the government of Peru to try to review different problems in the health about the hospitalized persons, that persons related to the CDC, related to SynapseML is other application tool to try to support different and deaths with different origins. For example, death by COVID, death related to problems with the head, accidents, something like that. And with this KPI, we have the opportunity to take more decisions about, for example, the emergency in different regions, because the number of people dead with COVID in Lima is different in Loreto. Loreto is other part in our country with less population, but have also the particular problems related, for example, the medical staff, the number of medical staff inside to one hospital is very few in compared to Lima. It's a reason because this kind of KPI have the possibility to increase good decisions in different places in Peru. With that, also dispose other different complements visualization maps. In this case, for example, this graphic is related to the deaths in different regions in Peru, regions related to, for example, here in Piura, La Libertad, and Ayacucho, are different places to Lima, but have the similar situation in some time related to the infected person and the dead persons. It's more related because the COVID affected almost time inside to the big cities. The big cities have more risk to dispose different persons in one market, for example, or inside near to the public services. That was high risk to get a COVID infection. Is the reason because in some parts in Peru, for example, here in Ayacucho or here in Cusco, appear more high peaks in one time, but in other time related to other places in Peru don't have this scenario. The scenario is very different. For example, in Puno is other region in Peru, but had less people, no more than 1 million or 2 million persons. That reduce the possibility to have a COVID infection. And that's a good opportunity to focus the resource to try to support the region which have more infections in that time. With these KPIs, in summarize, we have the opportunity to support also the medical services. The hospital have different medical services, person to support the COVID, person to support maybe not only COVID, cancer, and other different problems. The nurse also are the human services to try to support different issues during the pandemic situation. But what was the problem, for example, when appeared the Omicron wave? The Omicron wave is infect almost early to 50 to 60% of the medical service in different hospitals. That was very dangerous to try to support the public services. And with this KPI, we have the opportunity to dispose support, for example, for other regions, for example, from Puno, from Tacna, we have less infected person, and dispose to this medical travel to other regions to support and supplant the doctor will have the COVID during 1 week, 2 weeks, or sometimes 1 month. And with that, we can the possibility to reduce also the deaths during this period, because it was hard to try to understand our country have very high problems related to how the rates about the deaths in the world. It's hard to talk about that, but with all these KPI, we dispose this risk map. This risk map have 2 versions. One version related to the CDC, other version is related to the strategic team. This strategic team increase the number of KPI to try to resolve, for example, the risk map, and increase our work only for regions or specific district to need to support and need more resources during the pandemic time. This solution was very important for the government's decision, because this post not in real time, every day, a good visualization map, a good statistics, a good focus in try to support different decisions. For example, Lima always was the region more affected by COVID. Then Lima is very big, have early to the 30% of the population related to all the population in Peru. But some parts in Lima have a lot of infected than other districts. That is reason because with this analyze method was very possible to try to define and try to follow the problem, and maybe have the possibility also to set your parameters, try to follow what happened in one hospital. Maybe this hospital had more deaths during one night. Maybe this hospital had more deaths during the week. Then was a good opportunity to dispose resources, human resources, other resources to try to dispose and reduce the number of deaths. This KPI was very hard to talk inside to the meetings because every day receive different reports. For example, the number of deaths in some region are less or more, but during the moment to need to fight with this virus was very necessary to understand, reduce the infections and reduce combine other kind of KPIs, the human resources, the number of boosters received with the population in the region, about the culture, about food sometimes, about the employee person. All these KPIs was used to create these reefs, maps, and dispose this information public for all the people. Right now, you have the possibility to join in this URL and verify this map. Yes, of course, this work was very hard to try to deliver in our period because we always working on time, or maybe the work was needed for yesterday. Reunis right now is a good website to try to find different statistic information related to the Peruvian health and Peruvian government. And almost time, maybe every day, or some graphics every week, or other graphics every month are disposed for the public. For example, there are different information from other different problems referred to the health. For example, in other words related to that, appear information sobre teenage pregnancy, related to the government. There are some KPI to try to reduce the teenage pregnancy during the next years. For example, there are here in Lima appeared more than 264 teenage less than 18 years old have a child. This pregnancy sometimes is related to ambulation, something like that. This very hard to try to understand. Maybe that capital with more opportunities and more information in all the country have this very high KPI. That's the reason because some governments in parts have the decision to reduce these KPIs in the future. And of course, there are other kind of work. For example, mental health is necessary to increase the number of the support of the people, because right now in the last 2 years appeared like to a hard KPI to try to understand the people blocked in their house when lost their job and lost the opportunities to have the social mobility. How to try to fight with that, and the person also receive a lot of stress, anxiety, and another kind of problems in their home, and increase this situation. It's a reason because the government disposed to create and monitor how to verify that. Of course, in the last 2 years, the attention was reduced because the first priority was to reduce the COVID. But it's a good opportunity to have a good visualization, a good focus in this problem. And of course, inside to other ideas to try to dispose a better services for the people, was created other application related to how to integrate, for example, the hospital in the neighborhood, how to dispose these medical services to try to attend as soon as possible one accident, the infection of COVID, or whatever other issue appear referred to the health. This solution now is working on to try to dispose more services of how to increase our statistics related to different problems, health problems some of time, but related to neighbors. Of course, there are the vacancy cards is like to other countries try to follow if the person received the correct number of boosters, but right now it's not used it more because the numbers of deaths and the number of infection are reducing a lot. But right now there are a new wage, but this new wage is not that dangerous than the second, for example. Well, there are here a little bit about the conclusion. I will show for the maintenance support decisions only numbers, but right now you appreciate in this speak the visualization was very important to try to dispose numbers and how to compare region, for examples, and with this visualization support decisions was very important. All the tools created here was created in Tableau using also sometimes R or maybe R language or maybe also Python. Well, more time for maybe for need to try to reduce the time to delivery was made in Tableau. Other is create rapid and progressive delivering tools. It's a reason because after to accept the possibility to use some licenses related to the Tableau, the team was focused in create the Tableau dashboards in all these visualization tools. Maintain the open data culture. The open data culture was a good key to try to support and try to implement different visualization tools because, for example, in our team, think create other KPI, this KPI using, for example, some graphics related to the timeline, but in outside to our government decisions appear some data engineer very happy to get this open data, and he create other kind of different graphics, for example, graphics related to the pi or maybe graphics related to regressions to try to understand what happened in the future with the COVID infection. That's very interesting. We get these ideas from this community. In the moment when I decide, I work like to a director here, I have a good relationship with the community because they support a lot with ideas, sometimes also with, for example, it's little scripts, how to have a good tool to visualization to dispose more data for the people and the government decisions. Connect that with the community is what's very important. Connect with this community related to the data visualization and data science, and improve the data quality. Remember some parts related to this how to get the number of booster or how to the vaccines get from one person. Almost time was manually, but it was very important to dispose some protocol to try to get this data every day. Was very important. Have a good communication plan with the different region to and alert is necessary to register in the system every day this information, reduce the number of papers with this information. Or maybe sometimes some region lost some papers. Is the reason because maybe in some regions that data not have a good quality. But with this communication plan, we have the opportunity to increase this quality in more than average. That was a good reason to work. Okay, before to finish, I maybe have some questions. I have some acknowledgement because this work was made from one team, one big team, more than 40 persons working sometimes weekends, on holidays, sometimes the people working sick because maybe the feeling how to fight with the COVID always was in this moment fight with data. The data driving inside to the public health services is very important. All these person, Enzo Reyes, Andrea, Jonathan Levy dispose a lot of time to try to increase the performance and increase the how to dispose these KPIs. How was the result? These people always support our team. These people always have pending to dispose different times, have a good disposition to increase our performance for the government and for the people in Peru. Also, the data community. The data community is a good, have a good people, very smart, have the good disposition also to dispose different solutions and different commitment communication with our parents to try to dispose different areas to how to increase our performance with data or how to increase the quality. Without these different two teams, maybe was not possible to resolve all these requirements in less time because this work was made in only 2 months. Only 2 months. Try to understand the database, try to understand the requirement, the visualization requirement was very hard and sometimes was very important to have a good communication inside and outside to the government. Thank you. That's all in my presentation.
Thank you, Carlos. Thank you a lot. It was very interesting. And please don't leave us. We will continue with QA session. And when we will wait for other speakers, I will have one question for you. Carlos, during COVID, what tools were used to collect the data regarding confirmed cases and this?
Oh, okay.
And this is continuous, this question.
Okay.
It's first part and second part.
Okay, in 2 parts. Okay. In one moment, for example, there are different issues, let's say, to the collection data. The collection process is beginning when, for example, one medical team get, for example, one certificate when the person is dead, other person maybe verify the reasons. Sometimes in Peru there are some protocols. The protocols include you need to describe the reasons in depth for 5 definitions. Was very hard to try to dispose. For example, one person was dead by COVID. Other special team create one special algorithm to try to identify how many persons dead with COVID or not. Right now, we have one specific protocol to dispose this correct information. Manual to one another related to using one application. The application, the name is Synapse. Synapse collect all this information during 1 week or immediately during the day. But sometimes it's very hard to try to dispose the correct data because sometimes some doctors dispose, okay, when these people die because have maybe one headache, or die because maybe have AHV, or and include COVID. But sometimes that's increase the discussion. Maybe the typical of the numbers maybe is high than our suppose inside to our data. But it's a good reason to understand the COVID increase the risk and maybe increase the death in when the people have cancer or when the people have AHV. Is the reason because inside to the governments define one algorithm, and this algorithm have the possibility also you can review inside to the Castañeto GitHub and exists this algorithm. This algorithm read the rows inside to the records in Synapse, identify, okay, this person dead with COVID, and move to other table, increase this table of number of deaths. It's the reason because we have Peru have one protocol to identify the death related to COVID.
Okay, thank you. Thank you for your answer. I will continue this question, and the next question will be to Aisha. What are some good stating method to apply in order to see in the mood is based or not, regardless in industry?
Okay.
Sorry, it's question to Aisha.
Aisha.
Are you hearing me?
Yeah. Am I audible? I'm not on mute, right? Okay, cool. So the question was, okay, I think when you think about some kind of data science problem, it is not different from industry, because data science and doing solving a problem is very, very connected to domain. And if you want to say regardless of industry, I can definitely tell you some textbook methods of reducing bias and maintaining this bias variance trade-off. But if you're asking how do you see if your model is over predicting some value, or trying to see if some kind of prediction is happening too much, how to streamline it, you need to use your common sense. You need to apply your data science knowledge about the industry, about the domain that you are in, and understand the data behind it. So for a very small example, I can tell you that if you are saying, if you want to take the example of social media, if you see that most of the predictions that this model is giving is showing more content which is popular, or is predicting items which are mostly um, uh, mostly classified in one category or the other, then you will see this imbalance of predictions in your model. And this is a very good starting point to see that maybe something's going wrong in your training, and you would want to change some weights, reduce something to create this balance so that the prediction is not so biased towards one set. So that's something I can give very generically answer.
Okay, thank you. And next question to Jônatas. Jônatas, some of the function of timescale use metadata. How accurate are the values obtained with this approach?
Well, I showed the approximate row count, and it uses the metadata from the PG catalog. So it will also needs that you run queries in this database, or you run like a vacuum analyze that will just keep this, let's say, tuple count up to date. So if you are running queries often, it will be very up to date. But if you don't run any query there, probably you need some extra effort, like in running one or two queries, it will already make it up to date. So yeah.
Okay, thank you. Let's continue with questions. Aisha, in your LinkedIn, it says that you worked on a ranking algorithm. How does social media impact ranking? Is there any correlation between ranking and popularity bias?
So maybe I would I would read this question and how it makes sense to me, and please to correct me if I'm wrong. Yes, I work in Trivago, wherein I work in a team where we build the ranking model, and the ranking model that we build is to rank all the accommodations or hotels on our website. And that's a major part of the job that I do, and that's how I am very familiar with ranking algorithms and recommendation systems and how they work. As for the social media, all of what I presented today is my understanding of how things could work. I have no experience working in a social media company or having exposure to anything behind the scenes. This is my general knowledge and understanding of how recommendation systems work and why things work in a certain way. So please do take it with a pinch of salt. And when I explained about popularity bias, I say that popularity bias is the main thing that is used for ranking, because it's one of the main concept of how recommender systems work. So there is definitely a huge correlation, because ranking is dependent on popularity bias, and popularity bias is not like a very bad thing. You might actually strive or want popularity bias in sometimes your algorithms.
Okay, thank you for your answer. And next, my question will be for Carlos. So, what are some of the public health issues you are most passionate about?
Well, maybe the pressure for try to dispose results immediately is the reason, because was very important to try to understand as soon as possible how to get the correct information, how to increase the quality, how to dispose this information, how it's possible to try to teach this information to the people in different visualizations graphics. Of course, inside to the government, there are different resources, but maybe it's not possible think outside to the box. The reason because it's very important have a good communication with the community. The community is people outside to the government, and these people using the open data increase the performance, increase the possibility to dispose different opportunity to make good decisions inside to the health solutions.
Okay, thank you. And next question to Jônatas. Which tool is best for PostgreSQL?
Well, depending on your flavor and style, like I really like to use SQL as a command line tool to interact with Postgres, but Postgres is full of extensions, and I would say that PostGIS is very interesting and widely adopted by the community to work with geographic data. That's very interesting. We also have tools for different, let's say, domains. So the question is quite wide and hard to answer, as like tooling is everywhere. So I would say that and it's very good if you understand how what are the capabilities of the database, and then if you understand this, probably you find the right tools and the right extensions that can allow you to go and move fast in the domain that you want. So
Okay. And I think it's also a question for you, which is better for data science, MySQL or PostgreSQL?
well, I'm not a MySQL fan. I never used it in production, so my comment would be biased. So I don't have any specific knowledge about it. What I know is that Postgres is very well known and like more than 30 years in the community. It's a lot of work from different people and different domains. You see even like Oracle DB and is Oracle also has an Oracle cloud, and now even Oracle offers Postgres cloud in their cloud. So that's quite funny, and this is the benefits of the open source. And a lot of companies embrace, for example, I am Brazilian, so here in Brazil, for example, we have like the government banks, and they run on their Postgres. So I see this is a very reliable database. So it depends on what's the type of your analysis. You need to choose like the strengths of the database that matches what you are going to do. So yeah.
Okay, thank you. And it's the last question for Aisha. What good features that don't create bias can we include in our training data?
So, like I mentioned previously, bias is not a bad thing. Sometimes you would actually want bias in certain situations to optimize for it. So, the correct answer is it depends from case to case, but I can give you an example of what you can try to do. So, the example where I gave, where there was a pop quiz app where a gender was a feature. Instead of having this feature, you can see the predictions out of this model and see the distribution of the gender feature. If you see that certain predictions are only catered towards men and women, maybe removing this feature helps in creating a very impartial prediction. And when you are creating a model for predicting a job or certain kind of profession, you should also think as a normal human person that having some kind of gender variable, including it in your training set, would invariably create some kind of bias, which is not very good in terms of like predicting for this output. So understanding what should be there and what should not be there, having input like your interest, your education background, something what is relevant for understanding what profession you should be, is much more important than adding things like race, sex, caste, or other features which might not be very relevant.
Okay, thank you. Thank you a lot. So this is end of the blog. Thank you all our speakers. Thank you our audience for questions. And I want to mention that we will meet with Jônatas on Ruby on Rails event in January. So let's meet us there. And thank you, Carlos. Thank you, Aisha. Hope that we will meet for next data science event soon. And now we will have short break between next block. It will be a last block of our junior day. So if you will have any questions or comments, please let me know. And I also want to mention that don't forget about our workshops that will be in 1st December. And it's a great opportunity to take more from data science industry and communicate with speaker more closely. So Nick, are you here? Would you able to add something?
Hey, yeah, I'm here. So yeah, first of all, yeah, I will also say thank you all three so much for joining today. So see you on our future events. Good luck with your projects. Bye. And yeah, so as Lilia just mentioned, we will have workshop around about workshops. So please register. You have time till the end of November. And I will also, well, yeah, I will also send the link in the chat once again. And just a quick reminder, you can still buy tickets for tomorrow with a 50% promo code they have on screen right now. And of course, Lilia just mentioned the Ruby on Rails event we will have in January. So if you go to events.geekle.us/Ruby, there's an early bird price, and you can still join the Ruby on Rails event. And two other events that I mentioned, Node.js. Also, we have very, very simple links. Event.geekle.us/Node.js2, which is going to be a second event since last year. And another event, which is Angular Global Summit 23, we'll have in February. So we have a promo code DataFlash that you should use if you'd like to join those events. And now I think we're going on a short break. Like, let me check. Yeah, we have less than 10 minutes. Or no, we have like around 15 before the next session. So see you in.
Yeah, I also want to mention that the next session, it will be also workshop for beginners. So don't miss that opportunity because it will be free workshop included in that day. So I hope to see you soon.
Oh yeah, we'll have an hour-long session, so be prepared. So take your time to get yourself something to drink or to eat before this hour-long session. Yeah. Okay, so let me introduce our moderator for the last block that we have ahead of us. So welcome to the stage, Smita. So how are you doing today? Hey, unmute yourself first, please. That's the common stuff. Oh, we cannot hear you yet. Sorry. You're still muted.
Can you
Nah.
hear me now?
No.
Okay. So, hello everybody. My name is Asmita and I'll be broadcasting from Los Angeles. It's a beautiful morning here and I've just started my day with Data Science Global Summit. I hope you guys are having an amazing summit so far as well. Glad to be here.
So please introduce the first speaker.
Sure. So now that we get started, I'll present you our first speaker, John Herke. And hi, John. How are you doing?
Good.
How's your day going?
Great. Thanks for having me. I'm also from the US, Minnesota.
Oh, nice. It's just the morning here, right? Okay. So while John presents his presentation, shares his presentation, I'll just give a bit of an introduction. So John has come today with a workshop on the topic of best practices and use cases on graph databases and machine learning. John has about 6+ years in building healthcare solutions as an EIR and graph engineer, and is currently working as a manager of the developer relations at Tiger Graph. So, John, would you like to share your presentation?
Yeah, of course.
Yeah, that'll be great. So I do believe this is a workshop, so it will be a 1 hour of learning new things. So I'm pretty excited for that.
Great. Can I take over?
Yes, you can.
All right. Well, it's great to be here. Thank you for the invite, and I'll get started. You can see my screen. I believe so. So again, my name is John Herke, Director of Developer Relations. I have an extensive background in database management, graph databases, data analytics, machine learning. I have a couple different patents in this space as well. I come from the healthcare background, building the world's largest healthcare graph. We'll go into what our graph database is today and how it can enhance your machine learning capabilities. And with that, we'll get started. So we're going to do a workshop. So if you see this screen here, this just means that this is a place that we're going to stop and do an interactive bit. So the workshop that we're going to be doing today is using Jupyter Notebook that's hosted inside of Tiger Graph Cloud. So it has a bunch of capabilities that are pre-built into this Jupyter Notebook deployment that interface with graph capabilities. So whenever you see a screen like this, we're going to actually toggle over to another screen so we can get started. So I encourage everybody to follow along. So you'll actually have an account at the end of this and you'll have ran through how to apply graph data science and machine learning. No worry, you don't have to code anything. All we're going to do is hit the play button. Everything will be no code. And we'll have maybe follow-up sessions as well if people are interested in learning more about graph data science. So the first thing we're going to do is go to Tiger Graph Cloud or tgcloud.io. So if you want to open a browser next to the screen right now, go to tgcloud.io. And what we're going to do is toggle over there and just check it out. So go to File, or go to your TG Cloud, so tgcloud.io. So Tiger Graph Cloud portal is where you're going to have all the different tools to interface with Tiger Graph. So everything's sort of prepackaged. It's a database as a service. It comes with a bunch of visualization tools. And if we have time, we'll go into some of those tools later on. So what you're going to want to do is sign up if you don't have an account. So click the sign up button and go through the sign up process. You'll get an email verifying that that's your email address, and then you'll be able to log in. So while I do these slide presentations, I encourage you to go to tgcloud.io, sign up, so then you can follow along throughout the presentation. We'll sort of hop back and forth. So just go up to sign up or log in, and then we'll get started. So what we're going to cover today, I know this is going to be really fast. There's going to be a lot of information. We'll have Q&A at the very end. I encourage everybody to ask questions at the end. I won't probably be able to answer questions during the presentation. And so we're going to go a little bit into what is a graph database. So intro to graph databases, and more specifically property graphs. We're going to talk a little bit about why structure matters in your data, and go through a couple different graph use cases, and finally get to that interactive portion where we're going to interface with Tiger Graph Cloud and run through a feature engineering lab. So what are graph databases? Everyone's probably really familiar with relational databases. So on the very far left side, I'm hoping as data scientists that you have seen something similar to this, which you have tables, and tables have rows, and tables have foreign keys. The highly they have connections and relations to one another. However, they are very rigid, but there are very good use cases for relational databases. It's high performance for transactions if you're going through and you don't have a bajillion joins you have to do. It's a really good database for you to have and store your data in. But then when you're doing deep analytics where you have to do a lot of joins, it can be pretty poor performance. The other ones that we're going to look at are key value database, which is a little bit allows you to have more of a fluid schema. It is high performance for transactions, but also again, for deep analytics, it's a little bit tough. And this is where graph databases come into play. I'm not sure how many people are familiar with graph databases or property graphs, but we'll go into a little bit today so you can understand a little bit how property graphs are structured and how people are using property graphs. So what's really nice about property graphs is it's really flexible as far as your schema. If let's say you're doing a use case with, let's say you're doing a use case with patient data, that's where I came from, and you have nurses notes that comes in, right? So you want to add nurses notes to your database, and then you want to have conceptual, maybe you're running machine learning and you want to do entity extraction and then link all the nurses notes to entities and then link the patients to the notes and the doctors that wrote the notes and the nurses that wrote the notes. You can do that without having to rewrite your whole database schema. It's really good for high performance complex transactions as well, and high performance deep analytics. So you get sort of the best of both worlds where you have transactions, and then you can also do deep analytics. So a little bit about property graphs. You could almost think of this as like multiple tables. On the right-hand side, you can see payments. They have properties underneath them. So imagine a table of 2 columns, right? On the payments, you have ID and maybe amount. Then you have a edge. So the important things to know about graph databases and property graphs are that you have a vertex, which represents sort of an element. Most likely they're nouns, and edges are usually things like verbs. So things that relate to one another are usually on the edges. So you can also pick, because it's a property graph, you can write the properties on the edge as well. So the edges themselves are first-class citizens within the property graph. And so you can see order on the other side, which has ID and quantity. And then there's also a directionality within the edge. So that's sort of the basic principle is constructing this. And we'll go a little bit like deconstructing how to build a property graph here later. So this is thinking in graph. One thing you might not know, but I'm sure a lot of people have LinkedIn. Back in the day, you could actually see the graph behind the scenes. I don't know if anyone used LinkedIn a long time ago, but this was something you could do. You could see all of the related elements within your LinkedIn. So you could see that left side cluster is orange, which represents a company, and you have the right side cluster that's blue, that's Microsoft. So you can start to see all of the interconnections and who's connected to who and where they worked at. And so what a lot of things that you use today have graph databases or graph analytics that are going on under the hood. So let's think in graph. If we have a person has a couple different properties. So in this case, it's John Herke. We also have a location. I live in Minneapolis in Minnesota. Again, you can see the properties underneath. And there's a relationship between those. So a person, John Herke, is located in a city. And then usually when you have geolocations, you have different sort of graph patterns that you could apply. So city, state, and country is a geotree. Geotrees are really neat because you can, let's say you have a whole population, you have billions of people, right? And let's say you had a bunch of records that have 1 billion people. Well, instead of having duplicates of this person lives here and that lives here in the city or state and country, you'd only have one country. So you'd have one element, one atomic unit of country, which would be, in my case, the United States. So I'd start at the United States, and there's only so many countries. So when you're going through your database, you don't actually have to go through all the data. You're just starting at country, and then you filter down to states, and you can go to cities. So having that deduplication, so you're removing the duplications, really compresses your memory or compresses your data in your database as well. And then we want to continue this on. So this is, again, thinking if I was to build LinkedIn and I was trying to build LinkedIn for the first time, this is how I'd start to think about modeling it. John Herke works for an organization. I work for TigerGraph, and my organization is located in this city. And then we can continue to add to this. So we have a person creates a post, and then a person can maybe like a post. You also have tags. If you've used LinkedIn or any social network, you've seen tags before, and a tag is related to a post as well. And then we also have maybe that post mentions a company, and a person follows a person, and a person is connected to a person. So that's sort of how you can think about modeling your applications or your use cases, is you look at the different elements that are in your data and that you want to persist, and you look at the relationships between those data elements. One thing you've probably seen as well, maybe not everyone understood what first degree, second degree, third degree means. But if we go back, you could see that connected, a person is connected to a person. So and again, this is the schema that's on the right-hand side. So a person connected to a person is the schema. And then what that looks like when you're breaking it out in graph is you have your first degree. So John is connected to Sam, who's connected to Fred, who's connected to Jill. And then the second degree would be, that Sam is connected to Dan, but John is connected to Dan in a second degree. So you're going from a first degree to a second degree, and then also the third degree. So that's what that means when you're looking at the first degree, second degree, and third degree, is that you're looking at the relationships between the people in your own LinkedIn graph. On the right-hand side, you can see the feed. So maybe if I was to design or build a social network and I wanted to design LinkedIn, I would look at one of maybe some of these algorithms, these graph data science algorithms, to determine what content people might want to see as well. So those are a list of some of the algorithms, and we'll talk about those in just a little bit. So at this point, I'm hoping everybody was able to sign in and register. What we're going to do now is go through and create a cluster in TigerGraph Cloud. Again, if you're just chiming in for the first time, go to tgcloud.io and just go through the sign up process. All this presentation material will be available at the very end, and then you can have it. And then, of course, you can come into our community and ask questions anytime as well. So we're going to go to TigerGraph Cloud and sign in. I'm already signed into my account here. So, but if it's your first time, just go into your account. And then what you're going to do is go to clusters. Now on your screen, it might show a big orange button in the middle if you haven't created a cluster before. And so the next thing you're going to want to do is click that button, or in my case, I'm going to click Create Cluster over here. So TigerGraph allows you to have any cloud provider that you want. If you want to use Azure, Google Cloud, AWS, you can choose any of those locations. So the first thing you probably want to do is give it a username or a name that you want to identify this box as. So I'm just going to do Geekle, and then I'll do TG, and then I'm going to do 2. I don't know. And then I'll give it a description. So I'm just going to say a provisioned cluster for workshop Again, you can choose any of these. Feel free to choose if you prefer AWS or Azure. You can toggle it off Google Cloud. And then the next thing you want to do is what region is the closest to you. So in my case, I am in the United States. So I'm going to choose this, but feel free to choose a region that's closer to you. And then for the instance type, you get this free. So this whole workshop's free. All the tools that we're going to be using are free. And you'll have this solution for free. However, if you do want to increase your memory or your CPU, you could do that as well. You can just select one of these, but you'll have to put a credit card information for that. But for this workshop, we're just going to use free. And those will be grayed out. If you're using free, you don't get to change the disk size or the partition factor or replication. So the one thing that's going to be really important is for you to click on this this enable machine learning workbench. So this is going to enable the ability to have all the machine learning features that are built in that integrate with Tiger Graph or graph databases. So you're going to want to click on that. If you're coming in here maybe at a later date and you just want to explore different pre-built solutions, right down here are a bunch of starter kits. So you don't even have to build your solution from scratch if you're just trying to play around. One of the great things to do is go down to a topic that you're interested in. If you're looking at doing graph data science and healthcare, or graph data science for entity resolution or financial services or fraud, you can choose one of these starter kits and then get going without having to build everything. You could play around, and then you could try to build yours from scratch as well. So again, click the Enable Machine Learning Workbench, because that's one of the most important things that we're going to use today. And then the last thing you can do here is just give it a subdomain. So don't choose the same one as everybody else. So try to make something unique. Maybe put your name in it. So I'm going to say John. John, I'll just do my last name too. So just make it unique, because this is going to be your unique subdomain that you're going to use throughout the lab here as well. So once you're done, I think everything's set up. You can click create a cluster. So go and grab a cup of coffee. In our case, we're going to go back to the workshop presentation. So that will take a few minutes to spin up, and that's sort of the reason we're doing it in between here. Is it's going to take a few moments to spin up. So why are graphs important? On the left-hand side, this is a representation of data. You can think of these data elements as rows and columns, but a lot of times you're missing out on the composition of that data as well. So on the right-hand side, you can see the composition matters. If you had a bunch of flowers that were composed like this let's say in a flower shop, well, then the composition of where those flowers are located is just as important. It tells a holistic picture versus conforming our data into traditional rows and columns. So looking at things in a holistic picture allows you to gain more insights on your data, and allows you to derive new features that maybe you weren't able to pull together at a large scale. So one of the things that Tiger Graph's really good at is enterprise scale. If you're in the data science world, you might use NetworkX if you're familiar with Python. If you're going to work at an enterprise scale, like my company I was working at before, which is a lot of data. If you have all the patient data and every single record, and you have nurses' notes and providers and every medication, every single phone call, pulling that data together and stitching it together to compose a person and to see every single feature about that person. So on the right-hand side, if you're looking at the flower, in my case, it was a person and composing that person. And so with all of the different databases or backend systems, we would stitch all that data together and be able to have that composition in 50 milliseconds. So in reference, 50 milliseconds is a Google search is 200 milliseconds. So 50 milliseconds is pretty much near real time as you can get to compose all that information across all your different data systems back together. And of course, having that data accessible at any point of time makes analytics very easy. So you can then derive different analytical analytical insights that you're looking to dive into. So you're trying to answer some question. In my case, if you do go Google my name for patents, I was really particularly interested in understanding the composition of people and people that are similar to other people, so we could have a best drug treatment path for that individual. So if somebody was diagnosed with a certain disease or cancer, what is the composition of that person? What are most similar compositions of that person versus other people? So then we can identify the drug treatment paths that were given to them. So then we could then identify what would be the best drug treatment path based off all these different attributes about a person that will have the most successful result. So again, looking at composition, this is again breaking it down from a phone. This is for a use case. If you've ever been on your phone and it says scam, this is what the company was doing, was identifying scam calls. And so on the left-hand side, we're looking at a good phone. What is a good phone? It has a stable group of connections. So most likely phone number 1 and phone number 10, maybe they're in the same family. You're calling the same group of people. You're calling your friends. You're calling your grandmother. You're calling your father. Again, on the left-hand side, those interconnections between different phones. So maybe your father's calling your brother. So you're looking at the connections between not only the caller, but the connections from the people that they're calling. On the left-hand side, you can also see the number of calls. So maybe you're looking at how many calls have you made to your grandfather or grandmother. And then you're identifying all these different features. So we're looking at, I think we generated over 200 different features that identifies what a good and bad phone is. Again, on the right-hand side, you have sort of the opposite of that, right? You don't have that stable group. There's many rejected phone calls. You have no callbacks, and there's short durations. So you're looking at how the data is, what's the patterns of those data from the starting element. Again, you can look at the structure of your data to infer different things. So there might be data that exists just based off the shape of your data itself. On the right-hand side, this is a provider network. So we're looking at the pattern of the data. So we have Helen and Douglas on the very top and very bottom. And there's no data for who referred who in the healthcare system. So we don't know Helen referred Douglas, but if we look at the shape of the data and look at the calls and when the calls were made, or the claims, when the claims were made, sorry, and look at the people and then look at the next claim, you can infer who referred who in that network. Another thing on the left-hand side, we're looking at community detection. We're also looking at the structure of the data as well. So we're looking at the structure of the data to determine those community hubs of providers. So you could probably see like a referral hub provider network as well. So graph databases are being used everywhere. And a lot of the things that we do are using graph data science techniques. TigerGraph has an abundance of graph data science algorithms. These are algorithms that you can use right out of the box. They're pre-built. Of course, you can fully customize them. TigerGraph is using a language called GSQL. So if you have a programming background like Python and know a little SQL, it's fairly easy to understand and write in this language itself. Again, you can customize all of these. And then on the right-hand side, there's a little image of showing the different relationships and what the output of these are. And we have a lot of different educational workshops that will go into these algorithms if you're very interested in learning more or how they could be applied in your use case. Graph databases are being used across a lot of different industries, and we'll cover a couple of them. They're being used in both different types of workloads, from a transactional workload or an analytics or predictive analytics. So you can see some of our customers, interesting ones like Jaguar Land Rover. So they're looking at their holistic data across their supply chain. We'll dive into that a little bit deeper. And some are using it for operational. So looking at routes, if you've maybe explored graph databases before, one of the most common ones, and they're being used a lot, are for routes for your packages or your air travel. And then you also have knowledge graphs are really big. So you can see the last sort of analytical workload types is connecting knowledge graphs. If you're interested in knowledge graphs, we have a couple of really great examples. One's taking a bunch of patents and building that into a knowledge graph. Back when they released the COVID-19 papers, we took the 65,000 published papers and ran it through machine learning to do entity extraction and interlink all of that into a knowledge graph. So there's quite a few different relatable starter kits and solutions out there. Feel free to reach out to me at the very end to learn more about those if you want to get hands-on on some open data as well. So recommendation engines, I'm not quite sure if anyone's seen a picture like this before, but we're running like a cosine similarity algorithm. And so a lot of the things you can do, in this case, we're recommending movies. In my case, when I was working in the healthcare space, I wasn't trying to recommend movies, but I did really want to recommend the drug treatment paths, or maybe what are the best drugs for you as an individual. And what we're looking at is that structure of the data. So here, and for movies, you have a couple different people. We have Alex, Jing, Kevin, Kat, and we can see what movies they're looking at. And we can look at, so if Kevin watched this movie and movie A, movie B, and Noel watched movie A, well, if Noel and Kevin are pretty similar in their taste of genres and types of movies, then maybe Noel would want to watch movie B as well. So we're looking at the structure of the data and finding similar people and what they similarly like as well. Another recommendation that's probably everyone's used before is Amazon. One of the other ones I won't cover, but you could look it up on YouTube, is Pinterest uses graph databases as well. So all of the pins and boards that you see are collections and their recommendations based off their graph database algorithms. The most famous one that you probably didn't know is Google. Google uses graph algorithms. So if you've ever been in that situation where it's super uncanny that they're able to understand and know things before you know things, what you like, what you want to see, those are being used. They're using graph databases under the hood. So their famous algorithm that they developed was a thing called PageRank. And so it's looking at the connections between the pages themselves to then recommend what page you would be most interested in seeing when you search that. Now, of course, they've probably moved on to a whole new algorithm in the data science space, but that was one of the original ones, and you've probably heard the term PageRank before. One of the most interesting ones that I find is the energy grid management system graph use cases. So they network the whole graph or their whole network grid on the graph itself, and are doing the rebalancing of energy grid systems or analytics of their energy grid systems at real time. So they have all the data streaming into graph, and then they're running algorithms and they're running analytics on the edges to determine the capacity. This is also being used not only in energy grid management systems, but networking operations, and then also water flow. So they're looking at flow sensors. I don't know if anyone's used it for oil, but it might be also a similar use case that's along with energy grid management systems. I did talk a little bit about supply chain analysis. And so this is looking at the holistic picture of your whole supply chain. So this is from Jaguar Land Rover. They have suppliers have parts have features, there might be multiple features that are used within multiple different cars. So on the right side, you have panoramic sunroof, and that panoramic sunroof might be used by multiple cars, but it comes from a lot of different parts, and those parts come from a lot of different suppliers. So it's very complex, and running those analytics, I think, took about 3 weeks. And they got it down to sort of an hour of sort of analyzing their whole supply chain, just having their data structured in a graph. Another popular one, especially in the fraud space, is entity resolution. So you have a lot of relationships between different elements, from an account to a device, from a device to a phone, a user using a phone, an account have an email, a user have an email. And so you can start to link all of these different data points together and then look at, let's say this account is associated with a account that was a known fraud or very close to a known fraud. So you can adjust the risk score and then trace that phone number that is close to somebody that had experienced fraud or is the fraudster themselves. This is another one that's hugely popular. A lot of, if you're in the crypto space or if you're in the bank space, there's all these large banks that are using Tiger Graph right now or Graph Analytics. I'm sure every single bank is using Graph Analytics, but it's transaction tracing. So you're looking at the transaction network and you're tracing those transactions. So in the crypto space, they might be looking at Ethereum transactions, they might look at Bitcoin transactions, they might look at FTT transactions, and look at how people are trying to launder money, and then eventually those end up back at a certain account. So they're tracing the transactions across all these different systems to then identify those anti-money laundering schemes that they're trying to have this sort of complex. They're trying to make it so it's so hard for you to join all the data together that you can understand and see where the money is actually going. On the right hand side, that is one of the pre-built algorithms. It's called circle detection. So again, it's all built out. You can customize it, but you can just copy and paste, or there are some features in the graph data science lab that we're going to show that actually imports the algorithm, so you don't even have to copy and paste. So at this point, I think let's go back. Yeah, so let's go to the tools and walkthrough. So we're getting near the end, and I save some time. So if people want to ask questions or want to go, into the Graph Studio or G-SQL Shell or Tiger Graph Insights or any of the other tools, we can have maybe some extra time to do that. But at this point, we're going to go back to our machine learning workbench. So at this point, you'll have your box provisioned. And then what you're going to do is you're going to want to go to tools. I have two different ones. This is one I just provisioned. But you're going to want to go to tools. So again, you're on tgcloud.io. And then you're going to go to clusters. So once you go to clusters, you can go to your geekle.tigergraph.com. You can go to tools directly here. Some of the other tabs we're going to be using. And so there's a couple different ways. You can go from tools here. There's a couple different ways to get to tools, but you just want to go to tools and then go to the machine learning workbench. So once it spins up, if you're in data science, this environment probably seems really familiar. There's not, it's a pretty well adopted Jupyter notebooks. What this Jupyter notebook deployment has is a bunch of the graph interconnection, graph database features built in with our Python connector, so you can import a bunch of graph data science tools to interface with your graph database. So on the left-hand side, you'll see there's a bunch of labs. We'll go through one of these labs today. I don't know if we'll have time. We might have time. We could look at some of these other labs. Example for fraud detection. I won't run through it, but I'll just give you a preview of it. So fraud detection, we talked a little bit about transaction tracing. This is using Ethereum data. They're using PyTorch and XGBoost as well. And that goes through. So after we go through our lab today, what you could do is go through any of these other labs and run through them. So you can click the play cells and you can go directly through them. This sort of all-encompassing scripting, so it doesn't have a lot of input you need to do other than if you want to change some of the parameters for your machine learning tuning, but it's going to do all the data sets, the imports, everything sort of scripted out for you. Under the hood, what it actually looks like. So there's a bunch of different ways that you could develop your graph database solution. You can do full no code if you so choose. You can design, build, drop your data into the graph database. But for those of us that are doing enterprise development, you don't usually use a GUI tool to design and build your database solution. So once you get sort of more advanced, you'll be writing sort of scripts, you could say, to then create your graph. So this is sort of creating that vertex. And so we have a vertex here. We have properties on that vertex. We have a vertex here called movie, and we have properties on the vertex, and we have those edges. So everything's sort of designed and built using code. But for the lab, you don't really have to worry about that. What you'll see here is it's just going to look at the data set and ingest that, and it's going to do everything for you. So, but under the hood, I just wanted to let you know that it's actually code that's being ran. And of course, you can, when you're building your own, you can reference this one, write your own scripts, and then run through your own data as well. This is just to serve as a template for you to understand how you could use graph data science with some data. So again, this goes through PageRank is one of those algorithms that we just talked about. It does degree features, amount features, labels, test, pretty much all the different things you would do if you're into the machine learning space. And I think they also talk about graph neural nets as well. So that would be a talk for a different day. And we have many of our graph data science engineers that give talks quite frequently. So if you want to go into graph neural nets, they'll probably have an upcoming talk at some point. We just did one about 2 weeks ago, maybe a week ago, that's on YouTube. So if you want to look at graph neural nets, you can go through that as well. So let's get started with this. We're going to go back to the main, and then you want to go to your config file. So we're going to go get the configurations for our box. I've already put mine in here, but I'll walk you through how to grab this information. So you're going to go to TigerGraph Cloud Portal, and then you'll be still, if you're still on that same tab that we went into tools and you followed along the same way, you can just go to details right here and grab this right here and just click to copy. If you're back at one of these other tabs, just go to clusters and then go to Geekle. In my case, yours might be completely named differently. And then we'll go and you just click the copy button. So you want to grab the domain URL. So this is that unique domain that you gave your box. And you're just going to want to paste it right here. So just paste it right here for your host. The one thing you want to make sure is keep your, if you're using, in our case, we're using HTTPS. So just make sure that persists as well. And then the next thing we're going to want to do is go to access management. Click the access management, and then we're going to go to database access. So database access allows you to give certain permissions to certain users. So not in our case, we're going to give a super user, but you might want to have really fine-grained controls when you're doing a lot of your database management. So you might want to give a user only certain access, or you can customize your access as well. So you can customize all the access that you want to get. Maybe you only want them to read something, or maybe you want to read a certain attribute or a vertex. You can do the vertex level attribute controls as well. But in our case, we're just going to create a database users that has sort of all full permissions. So just click on add database user. You can give it a name. It comes pre-built with like user one in your case. So you can keep user one, or you can do whatever user you want to put. And then also it gives you an auto-generated password. I'll be deleting all my stuff after this presentation, so I'm not worried about sharing it, but you don't have to do that. You can just click this copy button here, and then just add the user. So add a user, in your case, probably user one or whatever name you gave it. And then you're going to go back here. Just make sure you update this config file. In my case, I just created user 4. But this user does not have permissions. So we created a user, but we did not give this user permissions. So one thing I'm going to do is just make sure you save your config after you put your host, username, and password. And then we're going to go back to the cloud portal. So we want to give this user some permissions. there's a couple graphs I've already created, and the one that we're going to go through today is going to create Cora. Yours will probably just say global, and then you want to give the user super user privileges. Of course, again, you can change all of the user permissions. I'm just going to use super user for now, and then you want to click on your user here that you just created, and then make sure that you save. So this will give the permissions to that particular user that in our case is a super user on the Geekle Tiger graph. And what we're going to do then is click save. So once you click save, you'll be good to go. I do want to show you a little bit before we go into the notebook, maybe just a little bit about the Graph Studio. So, oops, let's go back, go to our box here. So Graph Studio is probably the tool you use the most if you're getting started. So think of the machine learning or the Jupyter Notebook environment as sort of your data science analytical environment that you'll be working out of. If you're building your graph solution and you're not scripting it, you'd probably most likely be in here. So you can see here, just as we showed through the slide decks, we have a schema. This schema has a person, and this person has a name, and there also has another attribute called born, and this person follows a person. And then there's a bunch of actions or verbs, or relationships between another data element, in this case, movies. So again, this is the schema. And that movie has titles, released, and then tagline as some of the attributes. So if you were, I'm gonna leave this. If you were doing sort of the no code version and you didn't want to write the scripts to load the data, what you would be doing is clicking add data file, and you could load, if you have S3 or if you have a CSV file, or if you're going to load from Google or Azure, you could do that as well. So then you just choose like a CSV file, and then it's literally drag and drop. So there's no code. You just use this tool to then map, saying, okay, the title of the movie goes to the title of the vertex here. And so you can just drag and drop. After that, you'd want to load your data. And this database already has a small set of data. So you can see here all the data elements that were loaded. If you want to explore the graph, one of the things you can do is like look at the data. So I'm just going to double click on some things. Again, you're not going to be able to follow along on this because we haven't loaded anything. I just want to give you sort of a preview of what it would look like here before we get started. So this is some of the data here for this movie database, and we can see the relationships between actors and the movies that they created as well. So this just sort of, if you were to explore your data and actually crawl through your data, this is sort of what it would look like. Again, you don't have to write code. You could build these things called graph patterns, so you can actually analyze your data without writing code. And then once you install your query, because it'll compile and create your query for you, every time that you install your query, it's going to compose a REST endpoint, so you can interface with Tiger Graph very easy. The last thing I was going to show you is maybe like a query. Again, if you come from an SQL background, this is probably pretty familiar. You have a select from, where, limit, print. So the language itself is SQL-like, and it allows you to sort of have a lower learning curve to picking up the language. One thing that's unique is the from. So from, if you're going from a person across the edge to movies, this will look a little bit different than just a from person. So you're actually defining the pattern or where you're going to traverse in your from statement. With that, let's go back to the lab. And what we're going to do is go to basics on the far left-hand side. And I think, yeah, let's go to feature engineering. So we'll go to feature engineering, and we're not going to click cell by cell. What we'll just do is click the, start at the top here and we'll run through it. So we'll click run, select the cell and below. So it's going to run through everything. So here we can look at a little bit about what's going on. So again, PyTigerGraph is our connector. So PyTigerGraph does have a lot of graph data science capabilities. You can see here there's also data sets that you can use. So if you're going to just do graph data science and look at some pre-built data sets that you want to use for analyzing, you don't want to go through the star kits and you just want to do that this way, you can do that as well. So we're going to get all the different configs that we set up earlier, and then we're going to ingest that data. So in our case, we have a data set called Quora, and then we're going to ingest that data. What TigerGraph is going to do is generate a token based off your access privileges. Again, you can dynamically generate that, or if you want to sort of hard code or put a token associated with this particular user in this particular graph, you can do that as well. They're using some Cytoscape, so there's some visualization capabilities built within PyTigerGraph that allows you to, if you're not using Graph Studio and this is your interface and this is all you want to look at, you can do some of that visualization and see what your database looks like as well with some of the visualization capabilities that are built into PyTigerGraph. There's ls command is just getting basically your schema and all the information about your database. So it's one of the commands that you can run to sort of see what is in your graph, what are the different jobs that are in your graph as well. There's a lot of pre-built-in functions that are REST endpoints which have been conveniently wrapped into PyTigerGraph functions. So you can just do something like get vertex count and star. In this case, we're getting 2,708 papers, or then we can do a specific vertex type called vertex count of papers. So these are just showing a couple different functions that you can use. There's quite a few different functions. If you go to our docs.tigergraph.com, you can see every single function that PyTigerGraph has to offer that you can use for graph data science as well. So feature engineering, PyTigerGraph has a lot of different algorithms. Some of them are pre-built into the featurizer or the GDS featurizer, and they have list algorithms. So these are some of the algorithms. There's 10 algorithms within centrality, classification, community, and embeddings. And you can list those and then import those as well. So here you can see they started to list all different algorithms, and then from centrality, let's list all the different centrality algorithms. So PageRank is one of those. If you wanted to use PageRank as a feature, you could use PageRank as a feature in your machine learning models as well. So then it's as simple as doing the install algorithm. So you can install a specific algorithm. In this case, they are installing the PageRank algorithm. And then they're passing those parameters. So there's a bunch of different parameters that this particular algorithm takes. It's taking a vertex type, an edge type. So it's a schema. This is a schema-free algorithm, which means that you don't actually have to edit the code itself. You're passing the things that you want to look at within your graph. So in this case, we have a vertex called paper, and we have an edge called site. So we're passing that dynamically into the parameters of the GSQL. And then we're going through and providing some of these other elements. Again, if you go to the docs, it gives you examples of what all these mean. But at this time, we're just not going to go through it. You can also do user-defined algorithms. So if you want to write your own logic or query, and you want to install that, you can define whatever you want to write and analyze. Or if there's an algorithm in the graph data science space that's not there and you want to write your own, you can for sure write your own and install that as well. PyData Graph also has a lot of the machine learning functions that you'd want, like split, commonly split your data, so you can run some of the data through and then run the other part of the data through to see how accurate your model is. So it has some of that split capabilities, and then you can also get, it's got data frame capabilities as well. So if you want to convert your graph data into your data frame, so you can use your traditional tools, you can do that as well. So they had a vertex splitter, edge splitter, and that's pretty much it. So we're not going to go through, I mean, there's a lot of different features and functionalities. What the goal of this is just to give you a spark, to give you a, hey, I'm interested in learning more about graph data science. It seems like an interesting field. There's a huge lack of graph data science engineers in the space. So we're hoping that there will be a lot of people interested in graph data science and can use this as a foundation or a template to get started in graph data science. So you can come in, now you've done an end-to-end demonstration with graph data science. Of course, there's a lot more to learn, but feel free to ask any of those questions. If you do want to learn more, I know we didn't go into a lot of the how to build your graph, how to design your graph, how to optimize it, how to write GSQL queries. So there's a lot of stuff we didn't cover just because of the duration of time that we have. So this is sort of really a short duration, a short crash course into graph data science. I would highly encourage you to go to our Meetup Pro /TigerGraph. So we have TigerGraph events across the world. The next one coming up is on December 8th. That will talk a little bit about TigerGraph 101 and intro to graph as well. There is going to be a lot of educational resources. I'll link this whole slideshow, so you'll have all these links. So I'll link this whole slideshow in the chat. We have our YouTube educational videos. We have a developer portal. We have a university program that you can take and get certified. And of course, we have a vibrant community. So I run the community. We have weekly events with the community where we just hang out and have a graph A session where we have virtual coffee and chat. There you can ask any questions. You can showcase what you're building. And we highly encourage everybody to show up. It's on Discord. And then docs are very important as well. So if you want to learn more about graph and machine learning and do a deep dive, I'd go into the documentation. And that is it. So I hope everybody enjoyed sort of this crash course into graph data science. And I'm open for any questions. So I'm going to stop sharing.
So Asmita, you're muted. I'm sorry.
Yeah, sorry. So thank you, John. It was a really amazing workshop. So I know viewers would have a lot of questions for you, but we'll be having the questions during the Q&A panel after our next two speakers are done. So thank you once again for taking out the time.
Yeah,
see you in the Q&A panel.
All right, thank you.
Thank you, John. Please join for a QA session because we have some questions for you from our audience. So hope to see you soon.
Awesome. Excited for it. I'll see you in a little bit.
Thank you. See you.
So, yeah.
So how was expectation? How was the session, Asmita? Do you enjoy it?
It was great. Yes, it was really nice. Like, it was pretty insightful. I got to learn from the end to end how to work on the Tiger Cloud thing. So it's like at times when we start something new, it gets a bit difficult to analyze where to do what. Where do we have to upload the Jupyter notebook? Where do we have to connect the nodes? So it was pretty insightful, and at least I was able to understand how to move forward if I ever have to.
Okay, great. I hope that everyone will leave us feedback. How was it for everyone? And let's continue. So we have next speaker here. Mohan, are you available to join us now? Okay, great. So Asmita, you could continue.
Sure. Okay. So presenting our next speaker, Mohan. CV. I'll add you. Hi, Mohan. How are you doing?
I'm doing very well, Asmita. How are you?
I'm good. So, by the time you share your presentation, I'll just tell the viewers a bit about yourself. So, Mohan has come today with to talk on the topic of how to reinvent your business for the future with big data. Mohan is a senior solutions architect at Amazon Web Services based out of Northern Virginia and comes with almost 2 decades of technology experience with a background in large-scale enterprise migrations and modernization, and holds a specialty in data analytics. He loves to help organizations come up with new ways to meet their goals from developing strategies, restructuring teams, improving ways of working to product development and hands-on engineering. So nice to have you here, Mohan.
Thanks for having me.
The floor is yours.
All right, excellent. And can you hear me okay, right? My slides
Yes.
are up, everything's all good?
Yes, it's
Excellent.
all fine.
Excellent, thank you so much. And good afternoon, good evening, good morning, everyone, depending on where you are joining. As Asmita said, I'm a senior solutions architect at AWS. And I've had an extensive background in data over the course of my career. I've held multiple roles ranging from software development, data engineering, data architecture, so on and so forth, and anything to do with migrations and modernizing customers' data landscapes, especially on cloud on AWS, helping them build data lakes, right, to draw insightful value out of the data that they have stored on the cloud, and or even for that matter, extending furthermore, to add additional intelligence, right, by performing predictive, prescriptive analytics. That's basically the sort of focus areas that I get to work with on a day-to-day basis. All right. So with that said, I know we've had several conversations since this morning. So I've witnessed a wonderful set of discussions on various different data aspects today. But this session is primarily going to be focused around modernizing the customer's current landscapes on AWS, right? What are some of the modern data strategies that you can employ when you're working with customers, and how do we at AWS help reinvent customers and their businesses for the future, right? So it's going to be more centered around some of the best practices that we at AWS bring to the table in terms of helping customers really reach and attain the data objectives, right, on the cloud and AWS. Okay. And if you're really new to AWS, or if you've already had prior experience working on AWS, regardless of where you're coming from, I think you will greatly benefit from this session. And we'll kind of walk you through some of the common fundamental discussions that we get to have with customers, especially around the data strategies and such. Okay. So with that said, let's get going here. And give me 1 second. There we go. All right. So here's a quick rundown of the agenda. So we'll start off discussing the modern data strategies. I've got a few intro slides to begin with. We'll take a look at some of the market statistics, what the data itself, and then building a data lake on AWS. If you've already had an experience setting up a data lake on AWS, or if you're just starting afresh, I think this conversation around that will kind of help further strengthen that particular understanding of yours. And then we'll take a look at some of the modern features in data mesh and data marketplace. I'll kind of walk you through what that set of features are and how do they really factor into the overall data strategy, right, that you can help build for your customers. Okay. And then for data professionals out there listening to me on this call, where do you really start, right, in this particular journey? I know we were all coming from different disciplines when it comes to working with data, but of course there has to be a starting point, right? So what are some of the considerations that you really need to have or factor in to really get your journey started, and how should you really focus about working with data, right? What are some of the steps that you really need to be focused on? And then call to action, I'll kind of walk you through some of the resources that we have on offer. So if you really want to embark on this journey, strengthen your understanding on AWS suite of services and analytics that we have on offer, the resources that I'll share at the very end of the session will greatly help you. Okay. So with that said, let's get started here. I've got a couple slides here to show you some statistics to begin with. And again, to put these numbers in perspective, I know data, we've heard from the other speakers since this morning that data forms a very core epicenter of all things that the customers do today, right? All customers and organizations really want to be data driven. And as you can tell by these numbers in the slide, the organizations are growing at roughly at about 30% on an average annually, right? And 70% of organizations are still unable to realize value from data. So it kind of goes to show you the market opportunity that we have when it comes to working with data and helping customers drive towards attaining their data goals, right? And 28% of customers, organizations out there have a data strategy in place, right? And the rest others are still trying to find their way out. So kind of goes to show you that we have fair amount of work to be done as data architects and professionals ourselves. I think it is incumbent on us to really help our customers and organizations be data driven and successful. Okay. With that being said, as an architect myself at AWS, I get to work with customers very closely in the field. And if there is one thing that I have learned, which is common between the customers and organizations today that are wanting to be data driven, is the so-called new normal or the new mode of operation, right? So as you can see from this particular slide, the numbers that show here. Roughly 80% of the customers and organizations today, they really believe that the digital business is really making their organizations be better prepared to change, because companies today are really becoming increasingly global. And if you look at the product lines, they're really shaping the product lines to be increasingly digital, right? So with that being said, when I get to talk to some of the leaders and executives on the customer side, they really acknowledge the fact that they want to increase the pace of digitalization to be completely data driven, right? To stay competitive in this global market. Okay. And with that, we all know that technologies like cloud, big data, analytics, and social media technologies have really changed the way the customers really operate with the data today. And the digital disruptions are even forcing the change even faster. Yeah. So what this all really means is the new normal is sort of pushing the application leaders or the data stakeholders within the organization to splice this new digital DNA into their organizational culture, into their processes that they have today, into the technologies that they really are using today to sort of transform themselves into top performing organizations. Yeah. And then with that comes the need for innovation. So when you really talk about the organization going completely digital and being data driven, I think it all comes down to the speed and agility in which they really operate, or with which they really want to operate with, right? So with that being said, the innovation flywheel is basically where we really want to help drive our customers towards. So if you really think of it, the faster our customers are really able to analyze and gather customer feedback, right, the faster they will be able to respond back to the customers in quick time, right? And the more we are able to help them save cost, so that much more ideas they will be able to innovate, right? And speaking of ideas, should they be able to get those ideas to the market at a faster rate, I think chances of them being successful in the marketplace is high, right? So we really want to ensure that we're positioning them and setting them up for success in this data-driven journey. Okay, and on the right, you will see some of the common customer implications for the IT teams today. Anything to do with breaking down the monolith architectures into smaller chunks, right, into microservices-based design. If you're coming from a software development, you know smaller microservices means lower risks and faster release cycles, right? Sort of gives the development teams the autonomy to operate at will and accelerate the deployment process at a faster rate, right? And the systems that we're building today for the customers, and the customers really expect those systems to be completely data driven, which are consistently kept informed by the customer feedback, right, on a near real time basis. And of course, automating things is going to be key. So anything to do with building DevOps, CI/CD pipelines as you start transitioning your journey with your customer to the data-driven world is going to be key. And then talent in an organization plays a very pivotal role. It's important for the development team, the data engineers, the data professionals to really level themselves up on modern technologies, the latest and greatest that the analytics and the data science platform has to offer, so that they are able to really cascade those knowledge into helping customers be data-driven. Okay. So with that being, with all of that being said, I think putting the data to work really brings in key benefits. One, to really help customers make better informed decisions and discover opportunities. Two, improve their overall operational efficiencies in the long run. And then three, like I said earlier in the previous slide, it presents them an opportunity to be able to respond faster to their customer feedbacks. And then lastly, it sort of helps them uncover and unpack opportunities, right, beyond the traditional lift and shift migration. Yeah. So with that being said, how does AWS really help in this journey for the customer to be fully data driven? Right now, if you really talk about the data journey itself, it all really starts about sourcing the data from various different disparate data sources, right? So you start ingesting the data and then store the data into some form of storage. It could be a central storage, or it could be multiple storage platforms that you may have. And then the next step in the process will be about analyzing the data, right? Transforming the data in some way, shape, or form to add a bit more additional intelligence. And then you would really need a way to visualize the data in some form of dashboards and visuals that you really want to present it to the executors, right? And lastly, if you want to take that a step further to really bring in the predictive and prescriptive analytics, and that's where the AI ML part of the data analysis comes into the equation. Okay, so with that being said, in addition to all of the regular data pipelines, we firmly believe that adding the governance control on top of it will really help the customers determine or rather establish the right security frameworks and governance architectures on top of the data as the data is being consumed by various different work streams within the organization, right? So with that being said, how do we help design the modern data strategy on AWS? There are 5 key components to it, as you can see on the slide here. I'll start from the bottom right, which is the purpose-built databases. The very first thing for you as a data professional is to really determine what data store that you're going to be using, right, to store the data. Depending on the requirements that you have at hand, it's important to really identify the right purpose-built data stores. Yeah. And then the second one is data lakes. Try and unify the data from disparate data sources into a common centralized data lake on AWS. And then the third one is analytics. So we have a suite of analytics services that really function on top of the data that is being centrally gathered in the data lake, right? And then the fourth one is machine learning. Again, from an AI ML standpoint, so we have a suite of services catering to the AI ML portfolio that can help you perform predictive and prescriptive analytics. And then on top of all of these 4, we deploy the security and governance models in terms of designing the fine-grained access mechanisms for various different lines of businesses or business units that are wanting to work with the data that's being processed, right, within the AWS cloud. And then just taking that 5 components further in putting together a feedback loop, you sort of can say that the data that gets generated as it is being consumed by people will only generate more data, right, resulting in a feedback loop. So it's important that you have a mechanism of some sort to really process this enormous volume of data, incorporating all of these components in place. Okay, so with that being said, what are the different use cases that kind of opens up, right, when you're really talking about building a data strategy on AWS? So like I said in the previous slide, setting up a data lake is going to be absolutely crucial. So that really forms the very core center of all things that you do with data on AWS. So right at the center, you see a data lake being set up, and I kind of walk you through what that process really means in the coming slides. But then surrounding the data lake, you see various different possibilities that you can pursue, right, with the data that's in the data lake. So you have big data processing. So if you want to really process a lot of enormous volumes of data from the data lake for your big leveraging a big data frameworks like Apache, Hadoop, and Spark. So that's one use case that you can target into. And then you have the relational databases, right? These are your operational data stores or online transactional processing systems. Then you have your non-relational databases. If you want to really get into key value stores to really fasten your processing, I think that's another use case that you can pursue. And then of course you have machine learning for predictive prescriptive analytics, data warehousing needs. If you really want to have an historical body of information stored in a central warehouse for various different reporting needs. That's another use case that really stems out of your data lake scenario. And then lastly, the log analytics, right? So if you want to just capture all of your streaming logs from various different sources centrally, and then perform analytics on top of your logs, that's another use case. So all of these are various different possibilities that kind of opens up once you have the data centrally stored in the data lake on AWS, right? Now, the next slide here kind of walks you through some of the AWS specific services that can really help you achieve certain goals, right, in terms of how you operate with the data. I'm not going to really go into the detail of these services. We've got public documentations, a fair amount of resources, help guides online that can kind of walk you through in detail. But at a high level, Athena, think of Athena as a service more for you to query the data that you have stored in the data lake, right? So it gives a non-technical user, a business analyst of some sort, to really go write queries. If all that they really know is to write queries, I think they will really find Athena really useful to draw quick insights out of the data files that's being centrally stored in the data lake, right? And Redshift, for those that are hearing this for the first time, Redshift is our native data warehousing service. It's a fully managed data warehousing service that helps you store historical volume of information, right, from your sources. And then EMR it's Amazon EMR. It's called the Elastic Map Reduce. So EMR is the platform where you help perform big data processing, right, using some of the open source Apache, Hadoop, and Spark frameworks. And then Open Search Service is where the service really helps you perform log analytics. And then Kinesis, Amazon Kinesis, and MSK manage streaming for Kafka. So if you're really into the real-time streaming or near real-time streaming, if you want to perform analytics on top of the data that is being streamed in real time, I think those are the services that can really help you achieve your goals there, right? So just a quick rundown of some of the common analytics services. Again, this is not a complete list of services. Just want to kind of introduce you to a few so that you have this on the back of your mind when you starting to put together a data architecture on AWS. Right now, if we sort of tie back all of these services to that central image that kind of walked you through a couple slides earlier. So at the core center, you heard me saying the data lake sits there, right? So that forms the core center of all that we do with the data. Now, the data lake on AWS can be built using what is called an Amazon S3 service, right? Simple storage service. So S3 is what we use to help put together a data lake. And then from S3, you sort of have all of these individual use cases that you can work out using the respective services, right? We touched on each of these services in the previous slide. And building a data lake in AWS, again, if you've already experienced setting up a data lake on any different cloud platform, it's going to be no different on AWS. It's going to remain the same, largely speaking, but then the sequence of steps and the process that you follow might slightly vary, right, from platform to platform. But on AWS, we have a very structured methodological way of going about setting up a data lake, right? But broadly speaking, the sort of steps that are involved is, one, you go about setting up a storage to begin with. So you identify a central storage where you want to just capture all of the incoming data from various different sources. And then two, you have to find a mechanism to move the data or ingest the data, right? Now, there are multiple different ways. Are you going to be following a real-time streaming ingestion methodology? Are you going to be following a batch-based ingestion methodology? Right? So there are multiple different options there. 3, you go about cleansing, preparing, and cataloging the data. Right? So if you do not find or figure out a way to capture the metadata of the files or data that's incoming into your data lake, I don't think that's going to solve any value, right, as you start storing the data into data lakes. It's important for you to perform that necessary cleansing and preparation before the data is being transformed and processed downstream. And then 4th is it's really important to set up security and compliance frameworks on top of the data, anything to do with authorization or authentication models that you want to build, securing the data using appropriate encryption methodology, so on and so forth. And lastly, making the data available for analytics, right? So using some form of visualizations and dashboards, things of that nature. Okay. So this is roughly speaking. I just want to kind of walk you through the lakehouse architecture on AWS. If you really look at it bottom up, right, on the first image on the left, so you have the data sources layer. So you have a plethora of data sources to deal with, right? Anything ranging from databases, your internal, external customer files that you get on a daily basis, and then you have the social media sources as well, right? Streaming data, sensors, so on and so forth. And then you have the ingestion layer, where you have multiple ingestion methods or methodologies that I kind of mentioned previous slide. You have the batch-based ingestion layer, and then you have the streaming ingestion methodology. Now, the type of data that you will deal with can also vary anywhere from structured data to semi-structured or unstructured data, right? And then the storage layer is where you centrally store the data in some form of a data lake or a data warehouse, depending on what your requirements are, right? And then cataloging kind of ties into your storage layer. So as you start storing the data, it's important that you catalog the metadata of the data that you're storing in the lake or warehouse, right? And then the processing layer is where you perform necessary ETL activities, right? Transformation and loading activities to your respective downstream. And then the last one is consumption. So how are you really putting the data to use? By some form of dashboards and visualizations. So down below on the other image there is just an equivalent mapping of AWS services to each of those respective components on the first image. Kind of gives you a mental model of which service to go with for what use case, right? Or what processing across various different layers in this particular image here. Okay. Now, multiple things that you can do with the data lake. I was told that there's a mixed audience on the call listening to me. So if you're really fairly new to AWS when it comes to setting up a data lake, we kind of looked into the various different services that can really form the creation of a data lake, right? And I kind of told you Amazon Athena is a service where any non-technical user with a background of writing queries can easily use the service in Amazon Athena to write queries to draw meaningful insights of the data that is stored in S3 data lake, right? So if you've got enormous volumes of files, right, in some way, shape, or form, be it structured or unstructured, you can just store those files in a central data lake and then use the service to write queries of the data files that are sitting in S3. Right, as simple as that. Right, you don't necessarily have to do any sort of ETL, or the business users, for that matter, don't necessarily have to rely on the IT teams or the data engineering teams to really get them the information that they want. So they're really looking for is some real fast, quick insights of the data files that's sitting in the data lake. This is the service that can help them, right? And then EMR, this is where the data engineering folks, the data related teams within the organization, if they have a need to process enormous volumes of data, they can bring the data from the data lake down into an EMR cluster to perform big data processing, right? So using some of the frameworks like Apache, Hadoop, and Spark. Right. So if you're a data engineer who's well versed in writing Python or PySpark or even Scala for that matter, I think Amazon EMR will really help you in setting up that ETL framework using those languages, as you can process enormous volumes of data, right, from the data lake that you have set up on AWS. Okay. And then visualizations, when it comes to visualizations, Amazon QuickSight is our native dashboarding service, visualization service. But not to say that if you're familiar with other dashboarding tools or visualization tools, just to name a few, Tableau or Business Objects or MicroStrategy, doesn't really matter. I'm just giving you the AWS flavor of what we have from a visualization standpoint. But then regardless of whatever visualization tool that you're comfortable with, it can integrate with the data lake that you have set up on AWS, right? And can seamlessly tie in, and you will still be able to create and write dashboards out of the data that you have stored in the data lake. This is just visual from the Amazon QuickSight, which is a native visualization tool that is used to really come up with dashboards and visualizations. Okay. And then creating a central data catalog. So you heard me saying that as you make that journey of ingesting the data into the data lake, one of the primary steps that you do is to catalog the data, right? The metadata of the files or the data that's coming into your data lake. Now, how do you go about creating a catalog? So we've got what is called AWS Glue, right? Now, AWS Glue as a service really does a lot of things, and one of the capabilities that it brings to the table is the cataloging aspect, right? So if you're familiar with some of the traditional conventional ETL tools, right? Which really does the ETL operations, extract, transform, and load operations. Glue does also help you perform those ETL operations, as you can see here on the image here. So we have an ETL functionality that helps you perform extract, transformation, and loading of the data. But then in addition to that, the other capability is cataloging the files, right? This is where you go about capturing the metadata of your data files centrally within Glue for all the rest of your user communities to use it from a central place, right? And then for any data science experts or specialists or data science engineers who are wanting to work off of the data and the data lake from an AI ML standpoint, build models, train models, then Amazon SageMaker will be a good fit. Okay, so this is the far end of the spectrum where you have the data in the data lake. So you have transformed the data, fed your downstream applications with all the necessity that you really need, and then you're exposing certain segment of data for ML purposes, right? Using Amazon SageMaker for your data scientists to work off of. Okay. And then some additional set of services, Redshift. I spoke about Redshift a little earlier. It's a warehousing service. That's your ask to centrally bring the data down to a warehousing. So Redshift can really help you there. And Amazon Aurora. We talked about Postgresql, MySQL in one of the previous sessions. I don't recall which session it was. So if you're really looking to set up an operational data store on AWS, then Amazon Aurora kind of gives you the different options of setting up relational databases, right? Either on MySQL or on PostgreSQL. Okay, depending on what your core requirements are. And DynamoDB, Elasticsearch, and SageMaker are some of the additional downstream services that you can really insert or ingest your data into. Okay, so that's a quick rundown of some of the AWS services that can really tie in to the broader data strategy that you're trying to build or help your customers build on AWS. Now, what I really wanted to introduce you to is a new feature called new terminology called data mesh. Right? If you haven't really heard about this previously, think of data mesh as something like this. Right? We talked about data lake. Where you have a team that's ingesting the data centrally into a data lake platform. But what if you have multiple teams with multiple data lakes, right? You really have to find a mechanism of really connecting all of those data lakes centrally, from where the consuming teams can then pull in the necessary data from various different data lakes, right? So that's where data mesh as an architectural approach can really come in handy. Okay, so what it really does is, if you in real world, is if you've got multiple producing teams, right? Multiple producers creating different data lakes, right? For each of the respective business units. So what you can then do is you can have a central place where the metadata for each of those respective data lakes are cataloged, right, in a central account, and then your consuming teams can then have access to those catalog to really pull in the data that they've been granted access to, right, rather than really exporting all of the data from the primary producers to the consumer side of things. You can just capture the central the metadata and the central catalog and provide an easy mechanism for the consuming applications to really pull in the necessary data from the data lake, right? So that's basically what it is at a very high level. It really helps speed in the data discoverability aspect of dealing with data, instead of having you to really ingest and push the actual data to the consuming applications, right? So it really entails 3 different AWS accounts to begin with. So on the left, the green box is basically a particular AWS account where you set up your original data lake, right? And then you have the central account. It's going to be a central governance account, right, so to speak, where you will have a central data catalog that is going to have the information of all the metadata based in cataloging information of all the data lakes that the producing teams generate, right? And then the third box is basically the consumer AWS account, which is going to be provided access to the central catalog, which is stored in the central account, right? So by means of putting this all together, the data mesh architecture together, regardless of how many ever data lakes that you have that the producing teams are generating, with this central data mesh architecture in place, you will have a governance model that will allow your consuming teams be able to seamlessly access the data without the need for moving the data physically to the respective consuming applications. Yeah. So that is good. Now, now that you have your data generated by the producing team, right? How we talked about moving the data within the account, right? As the producing teams are generating the data, and across the accounts works the same way as well for a given customer, regardless of how many producers and consumers you deal with. But what if there is a need? If the data that you generate, right, within your organization is something that you want to publish to the external parties, right? Or if you really have a data set or a data file that you really want to subscribe from external vendors into your organization, right? So you think of it in a real-time scenario, right? If you're a financial services company, for example, so you probably may be getting a lot of external partner files that you really ingest into your transactional systems on a day-to-day basis. So if there is a mechanism for you to easily subscribe to those data, and then you bring the data into your data lake, and something that can accelerate your data transformation process, I think that will be greatly helpful. And that is exactly what AWS Data Exchange really does. So it can really help you play 2 roles. So if you are the provider of the data that you're generating within your organization and something that you really want to publish it to the external world, right, for the broader use, so you can use the AWS Data Exchange to publish your data set in the marketplace, from where the external parties can then subscribe your data to, right? And then the other role is where you perform the role of the subscriber, where if you really are looking for a data set that you want to subscribe to from an external vendor, so the data exchange is a place where you can go in, quickly find the data that you really want, subscribe to it, and the data automatically gets pushed into the data lake that you have set up within your organization on AWS, right? Pretty seamless transactional service in terms of not only sharing your data within the organization, but then giving you the ability to share your data across organizations as well. Okay, multiple different ways of how you go about dealing with AWS Data Exchange. One way is to allow the producers to ingest the files from external platforms into your S3 data lake that you have set up. And then the second option is, if you've already got a warehousing structure set up using Amazon Redshift, the data producers can send the data in the form of tables into your Redshift warehousing structure, right, via data exchange. That's another option as well. And then, of course, if you're a programmer, if you want to write a programmatic way, or using a programmatic way of calling the data providers APIs, I think that's another option, which is the third option as well. So you can use SDKs to really help put together a programmatic way of really extracting the data from data producers into your data lakes. Okay. So with that being said, for all of this data related exchanges to happen, Redshift forms a very core central service, right? From there, it kind of opens up multiple different use cases for you. So from Redshift, we've talked about Redshift being the warehousing service. It kind of helps you cater to the business intelligence customers, right? So if you really have the need to come up with dashboards and visualizations, so Redshift has that use case for you. And then operational database, it kind of ties into your operational data stores. If you've got MySQL or PostgreSql, it seamlessly ties into that. And then you've got S3 data lake, right? So Redshift integrates with the data lake that you have set up on S3 seamlessly. And then you've got what is called data exchange, which is something what we just discussed, right? By means of data exchange, you will have the external data from different organizations seamlessly transferred or ingested into Redshift. Okay. And then the other feature, which is a new feature that we launched last year, was called the Redshift ML. Now, without you really having to perform machine learning, right, on top of the data that's already in a warehouse, without you really having to build and train models, Redshift ML basically does that for you, right? And that is basically what I will be demoing as part of the session tomorrow. So if you have already signed up for the 11:23 session, which is tomorrow, I think you'll kind of see me walk you through the various different steps of how to go about setting up a data sharing in Redshift to share the data within the organization, either from a given account or across accounts within a particular customer organization. Or if you're really, the second part of the demo would be about data sharing, accessing the data from external platform, right? And pushing it into your warehouse without having to really perform the ETL yourself, right? And then the third step is where we're going to be looking at using Redshift ML to see how ML capabilities can really be performed without you really having to do ML, right, on your behalf. So kind of helps accelerates your ETL and ML process. Okay. So that is that. I know we're coming up on time. So what I wanted to do is wrap up with a few different piece of advice that I wanted to share with this particular group. So if you're really a data professional, with all that I've just mentioned, you will probably have some question, right? Where do you really want to start, right? So 3 tips that I will give you is: 1, it's important for you to understand your data, the nature of data that you're dealing with, and align your data around the audience that you're working with, right? You may come across different personas within the organizations. It's really important to map your data to the respective personas, and then identify the right tools for the right job. We saw a whole bunch of services over the last few slides. So it's important to choose the purpose-built data stores and the AWS services that can really help you achieve your goals, right? With that being said, this is just a quick mental model in terms of what is that you need to consider, right? Number 1, you really need to identify the data structure. What's the structure of the data looks like, whether it is structured, semi-structured, or unstructured data that you're dealing with. And then what's the data volume, right? And the latency that you're really expecting to handle, right? If your marketing team is wanting to have access to the data in real time, then your requirements will vary, right, as opposed to having a batch-based requirement, right? So you things of that nature is something that you really have to factor in. And then the request rate at the top in terms of the throughput and the IOPS that you really want to deal with, and then the cost factor as well. Now, when you really talk about cost, of course, the performance and resiliency will have to be factored in. So it's going to play a major role in you determining the right technology or the architecture that you want to design, right? And if you really map some of the services that we just discussed on this particular slide, right? So you will then see if you're dealing with a NoSQL requirement, right? That sort of requires you to expedite the processing of search queries, for instance, right? So that's a hot data that you're dealing with, right? So you will have to use a service called Amazon DynamoDB to really help achieve your goals. But otherwise, if you really your requirement is more around archiving the data in the data lake, where the users can just buy some time to extract their data, then you go about using Glacier, which is where you archive the data, knowing that yes, the customer are not really wanting to query the data in quick time. Okay, so it really depends on what your requirement is in terms of choosing what the right service is. Okay, and then identifying your right data specific personas is also going to be key. So I have just listed down some of the few data related personas that you'll come up in real time, right? And then putting a data pipeline based on the AWS services that you pick, right, for each of the respective streams is going to be key, right? Data ingestion, like I said, we've got multiple ways of how you ingest data into the data lake in S3, and data processing using Athena. We didn't touch about data brew, maybe on a different day, but I strongly encourage you to search for that particular service. That's the service that helps you cleanse and prepare the data. And then if you're dealing with batch jobs, if you have the need to perform ETL, then you can use AWS Glue. And then for analytics and ML, you then go about performing your predictive prescriptive analytics using Redshift as a warehousing service, and then on top of it, you apply ML, right, using SageMaker. And finally, if you want to visualize the data, you use QuickSight. So you have to keep in mind what your core requirements are, and then stitch your data pipeline accordingly based on the services that can really help you achieve your goals. Okay. So I'm going to leave you all with 3 key takeaways. I know we sort of briefly went through some of the high-level services that we have on offer, especially when it comes to setting up data strategy, modern data strategy on AWS. So data is going to be a core component for customers going forward. Gone are those days where data was looked at more as a differentiating factor, right? Now it's not a differentiating factor anymore. It's more a survival thing, right? So customers will have to maintain the data-driven status to really stay competitive. Okay, and then secondly, think about the virtuous circle of data that I walked you through in one of the earlier slides. So it's important to use all of those components around data analytics, setting up data lakes, using machine learning, so on and so forth, to really put together that holistic experience for your customers. And then thirdly, try and incorporate the data mesh architecture, right? So as you start working with the customers, as you start dealing with multiple data lakes, it's important to really put together a central governance model using data mesh to really allow the consuming parties seamless access to data from various different data lakes. Okay. And I'll leave with the summary here. Again, leverage the services that we have on offer on AWS, regardless of what your data-specific use case is. Understand who the user base really is that you're working with. Identify the right tooling. Okay, it's super important. So we will, as we just saw, the multiple different use cases, multiple different tools that can be applicable. So it's important for you to identify the right tool and leverage managed services as much as possible, right? We've got a whole bunch of managed services. Speaking about managed services, think of it more like all that you really have to do is to just give quality code, right, to create that customer experiences, and forget about the rest of the infrastructure management, right? That's something that AWS takes care of. So all of that undifferentiated heavy lifting is what we take care of, and we expect you to really focus on generating that core business value for your customers. Okay. And I'm going to leave you with a few resources here. So if you're fairly new, either to AWS or to working with data on the cloud, I think AWS Skill Builder has got variety of courses for you to ramp up your knowledge on not only on AWS, specifically on data related aspects, right? Be it data analytics or AI or ML. And certifications, definitely recommend those professionals out there who want to really validate their knowledge and exhibit their understanding on cloud. I think that will be a very key, good way of really getting your journey started there as well. With that, I'm going to leave my LinkedIn reference in case if anyone is really interested in connecting with me. Happy to take any questions offline as well. With that, I really want to thank you, and really hopefully this was good for you. Thank you so much.
Thank you so much, Mohan, for coming with us today. We're really looking forward to the demo tomorrow. So once again, we'll see you in the Q&A panel.
Yep.
See you in a bit.
Thank you. See you in a bit.
Thank you.
Yeah.
So I'll be introducing us to the last speaker of the junior track today. So Kundan Karma. Hi, Kundan. How are you doing? I think you're mute. Give me 1 second.
Hey.
Yeah. Hi.
Hey,
Hi.
Ashmita.
We can hear you right now. Hi. So by the time you share your presentation, I'll give our audience a bit of your intro. Will that be fine? Yeah.
Yeah.
So Kundan has come today with a talk on the topic of big data analytics and machine learning with SynapseML. Kundan holds a master's degree in machine learning and artificial intelligence and is pursuing PhD in data science. He is presently working with Microsoft as an engineering manager and has more than 16 years of development experience. He specializes in data science, machine learning, natural language processing, Azure Cloud Platform, Azure Machine Learning, Azure Synapse, microservices, Azure Kubernetes services, and other technologies. We're really happy to have you, Kundan, with us. Thank you so much for taking out the time and sharing your knowledge. So I believe you can, the floor is yours. You can share your presentation if you want.
Yeah. Thanks, Ashmita, for a great introduction. And hi, everyone. Thanks for joining, taking out the time. I hope you are enjoying this conference. Yeah, so let's get started. The topic for the session is big data and analytics with machine learning. And I will be introducing the new thing called SynapseML and how it will help you. So let me share my screen and the presentation. So let's talk about the SynapseML, how it can help and what kind of value addition it is giving in the big data analytics with machine learning. So now, if you think of the big data, what kind of massive processing it do, the volume processing it do, and we are looking for solutions where even the data scientists or machine learning engineers will get the similar power and kind of a platform where they can write and experiment and do the inference of the machine learning models at a scale. So
I'm sorry, Kundan. I'm sorry to interrupt you, but could you please open your slides because it's not very good now, and it's
okay.
okay.
I'm sharing. Should I stop sharing? Okay, let me share again. Okay. Okay. Yeah. Let me know once you can see my screen. Yeah. Is it fine?
Yes. Yes. Now it's
Okay.
good.
Okay.
Thank you.
Okay. Hey. Thanks. Let's move ahead. Okay. So let's move on. Now, first, let's talk about what exactly the big data is. What is big data analytics? And then we'll jump into what kind of offerings we are getting as the part of SynapseML. So big data is a massive amount of data sets that cannot be stored, processed, or analyzed using traditional tools. So you can think of the regular traditional data where we store on the file or databases, which is in a structured form. The big data is some kind of a term which is used where the data is very huge, its amount is very large, and the data is not in a one format, but it's have a heterogeneous format. It can be structure, unstructured, semi-structured, or something. And if we talk about the big data analytics, we can think big data analytics is like the methods, tools, and the application which actually helps to you to collect the data and process the data, kind of scrub the data, do data cleaning and all this operation at a scale. And also you can derive insight from such a huge data, so it can help you to make better decision makings, right? And that data you can use it for your intelligence operation and analytics. And this data is in a different kind of in varieties, right? It can be structured, similar like your database tables. It can be unstructured, like a free text, or the audio files, or the images, right? Or it can be semi-structured if you think about the web pages or XML files. So this data can come from many places. This data can come from the web, email, mobile, social media, smart devices like IoTs. So yeah, so some are streamed, some are batched. So you require a tool which can help you to collect such a massive amount of data, process them, and get insights from the data. So that is the big data analytics. Okay, let's move on. And why big data analytics is important, right? The first important thing is, in such a huge amount of data, we need to get an insight into data. What exactly the data is talking about, what patterns it is talking about, right? What kind of things happened in the history, or what is the kind of an insight which can help us to make our decisions better. It can this data, after getting an insight, we can optimize our operations. Maybe the things which what we are doing, we can improvise that things after getting these insights. And another is predicting future outcomes, in the sense, now we analyze the data, we get an insights, right? We get the patterns, right? Now with this all the learnings, how can we forecast the future of our business, right? Or what are the operations you are doing, right? So all this could be possible using big data analytics. And it helps any business, any company, any organization to make a better decisions based on this data. So there where the big data analytics helps. Okay, so the regular workflow of big data analytics is it's one of the traditional way which I depicted on this picture. And depends upon the tools to tools and technologies, it varies, but in general this is one of the generic one which you can think of. So in this one, the first stage is like a collect, right? In this one, based on any kind of data, it may be structured, unstructured, semi-structured, or it is stream data or batch data or real-time data, right? You first you should have tools and technologies to collect that data, right? And collect and store the data. So that is most important. So you need some kind of an storage where you can store such a varied forms of data. So collection is first stage in analytics. And the second is, now you got a data, right? All the data is not the good data, right? So you have to filter the right amount of data which can be useful based on your domain and the problem which you're gonna solve. So you need to do some sorting, filtering or something you need to apply. And you need to process that data so it is in a little useful form. Then after that, you can pass this data to the next layer, like a scrubbing the data, where you can identify the duplicacy, redundancy. You can now some missing values, outlier treatment, right? And all these things you can do at this layer, right? After that, now once your data is in the right format, so there where you can start doing analysis. So here you can use all the analysis tools, or here you can use the machine learning as well, data science work here you can do, or you can use the data mining. So all this analytics or analysis on the data can be possible here because right at this layer the data is in a right format to be used by all these tools. So this is one of the kind of a typical workflow which has been followed by any analytics tool. Now it depends upon which analytics tools you are using. There are many such tools in place, like HD Inside, Hadoop, or Spark, Apache Spark, many such things. So here we'll be more talking about one tool or one kind of an the platform or technology, that is the Apache Spark. Apache Spark is actually big data analytics engine, right? And it is open source. First thing, it is open source, and it's a unified engine for processing a large scale data, right? And now it actually has the capability to do the parallel processing, and it is do its operation in memory, and it utilizes the distributing computing framework. So that's a Apache Spark, and it has a capability to and flexibility, so that the programmer can choose the language of their choice, in which language they want to write the programs. So they can use Python, R, Java, Scala, or SQL. They can choose. So this is in general explanation of what exactly the Spark is. This is one of the foundation to introduce you to the SynapseML. So let's move on, and now let's see on a high level what exactly the Apache Spark architecture looks like. So it is very high level. I'm not going in a very detailed one, but if you want to learn more about it, you can go through the documentation. But I just on a high level, I'm explaining this one. So the first thing is the driver one, right? So driver is the one where exactly the users interact. So any user who will be using Apache Spark platform, we can use this Apache Spark platform from anywhere. We can use the Databricks, we can use the Azure Synapse, right? So it depends upon, it doesn't matter which kind of platform you are using, but these components will always be there, same. So now driver is the one where the users would interact, and it has kind of an the communication, regular communications with the cluster manager, which actually helps to allocate all the resources. And now here it is kind of, it always run on a master node. Driver always run on a master node, and then we have a multiple other nodes where the executor runs. So what happens, any kind of a job which is given to the driver, it actually breaks down that job into multiple tasks, and then each task is allocated to the different executors to execute them. And whole coordination being done by the session management driver program, you can say. There's a more complexities around it and more components inside it, but yeah, in general, driver is the one who coordinate everything, and the cluster manager manages all the resources and all the communications between the driver and the executors. So this is a kind of a high level introduction to the Apache Spark. Let's move on to what exactly now the SynapseML is, right? Why this is a new term called SynapseML. So before that, the SynapseML is a new name, but before that it is called Microsoft Machine Learning for Apache Spark. So this was the old name. So people who are familiar with this one, that was the old name, but new name is SynapseML. And SynapseML came with more kind of an support and the more value addition in the libraries on the kind of an its previous version. So now let's understand why there is a buzz, what exactly the SynapseML is. So SynapseML is the library that actually makes the life easier for the data engineers or the machine learning engineers or the data scientists, because of this its simplicity. In the sense that previously the engineers need to write big amount of code, or need to for every different kind of an operation, they need to use a different kind of patterns and different kind of methodology. So suppose take an example of communication with web service. It's a different kind of code. Communication with database, it's a different kind of code. Executing the machine learning program, it's a different kind of code. So it actually unified everything. Now we have a unified approach for all these operations. So it makes the massive machine learning pipelines much more simpler. Right. Another thing is because it is targeted for the big data, and it is targeted for the Apache Spark. It is the machine learning capability it brings. It is scalable, right? So it can run on the local machine, it can run on the cluster, it can run the Elastic cloud as well. So it has that scalable capability. Another good part, it's open source, so it can run on. It doesn't mean like it's a SynapseML. The name is there, Synapse. So you have to go and use only the Microsoft Synapse service and you need to buy it. Not like that. SynapseML is the free and open source, so you can use it from any platform of your choice. You can use the Databricks, you can use Azure Synapse, you can use your any other like HD Inside or any other platform which supports the Spark, Apache Spark. Okay, so these are the some of the highlight points of SynapseML which I brought it here, and so it helps you to go through what kind of capabilities it brings. So SynapseML previously, as I told, it's called MML Spark, Microsoft Machine Learning for Apache Spark. It's an open source library that simplifies the creation of massive scalable machine learning pipelines. So here is the one, it's a capability it brings, like the previously the pipelines of machine learning, which is very massively and bunch of code. So it unified that approach, and it simplifies the things. Now another good part is it actually brings some APIs which actually not only for machine learning, but also it helps you to use out of the box frameworks. And take an example of a cognitive services. So you don't need to bring any you don't need to build any kind of machine learning program from scratch. There are some out of the box and ready to use services are available. Cognitive services is one of them. So suppose you want to do the sentiment analysis, or you want to do the language translation from one language to another. So you don't need to go ahead and do the things from a scratch. You can go ahead and use these services, right? And these services which you will use not on from just one node or from one service, it is on a scale. Like, so that kind of capability the SynapseML brings. So SynapseML will allow you to communicate and make use of the cognitive services or any services, but at a scale. Now, SynapseML is built on the Apache Spark, right? So that is Apache Spark is the main kind of an foundation on which the SynapseML is built, right? And it shares the same APIs as a Apache Spark ML. So Spark ML is the machine learning libraries for Apache Spark. So on top of this, the SynapseML has been built. So all these APIs of machine learning which Spark ML has, everything can be accessed from SynapseML. Along with that, it gives some value addition, right? So now, as we talked about, it's on a scale. You can train the model and run the models on a single node, multi-node, or elastic resizable clusters of computers. Now, it not only the one language, it can support multiple languages as well. And this is one of the great thing, like it abstract all the variety of things, right? So many things which we are doing, it actually abstract all of them. So for as a developer, it gives you the simplicity to write the programs and maintain your programs. Okay, so now this is one of the kind of an high level overview, same thing which I described, but in a graphical way. Like SynapseML, what exactly SynapseML is actually nothing but Spark ML, whatever this is the foundation, plus other capabilities. So these are all the other capabilities which is been value added to the Spark ML, and then it's the new name is given called SynapseML, and it is also an open source. So kind of a graded boosting like a light GBM, which is the Microsoft kind of a open source algorithm in a trees category. So that has been added here. The cognitive services, and now so if you think like a new project of the Spark is called networking on a Spark, and which actually very much connect to it right now, because now you can do web services communication from the Spark clusters. So the cognitive services which connects from the SynapseML, it shall actually take care of all the abstractions as well as all the complexities like a throughput, right, or a throttle control. All these things embedded already into that, so developers don't need to worry about it. Apart from that, it bringing the some frameworks related to reinforcement learning, right? Responsible AI, like explainability and other ethics related libraries it brings, so we can easily make use of it. Some for cybersecurity, CyberML is one of the library which it brings, and some explainability also we can make use of it. So all these capabilities along with the Spark ML is been offered through SynapseML. Okay, now yeah, these are the languages, and now with the new version it can support the .NET as well. So so the people who belongs to the .NET background, sometimes they think of for learning the data science or machine learning they need to change their language, but there are new kind of platforms which is coming. SynapseML is one of them, where they can write their programs in a .NET language. So this is one of the new capability, but along with that the Python, R, Java and Scala are the part of the SynapseML. Okay, these are the key feature on a highlighted feature. Unified APIs, so single way or unified way for all the creation, training and scoring models. So developing the model, training the model, and also inferencing the models. The similar unified APIs are available. Now next thing is because they're using a pre-built intelligent model, so you sometimes you don't need to write the model from scratch, or if you would like to use the existing models, there are many models, out of the box models are the part of this SynapseML ecosystem, so we can go ahead and use it. Cognitive service is one of them. Now another thing is it has a broad ecosystem compatibility with ONNX. ONNX stands for open source neural network exchange. So here all the models which is there, which into this category of ONNX, we can go ahead and use them seamlessly here. So there is some the kind of a library which helps you to convert your model from TensorFlow, scikit-learn, Core ML, LightGBM, and other places to the ONNX for accelerated and distributed inferences using SynapseML. So now the traditional kind of a neural network model which is there, you can convert them and you can use it on a scale in a distributed computing framework. And this is another good thing is especially the responsible AI, which is getting popular more and more in nowadays, to give the fair judgment, to give the fair prediction. So it is one of the ethical responsibility as a machine learning engineer or a data scientist. So it brings some capabilities into the framework, so we can go ahead and use this all the capabilities from here. There is one thing which is a part of responsible AI, which I brought especially, so we can make use of it. So sometimes the machine learning model or deep learning model is a black box to us, and we never know what kind of things it is doing, right? Maybe it took some features from you, and we never know among these thousands of features, right, which is a more important features. The model is more kind of biased towards, or model is more taking into consideration, or some kind of an internal explainability of the model, right? So that things can uncover using the model explainability, right? So these are the kind of capabilities which SynapseML brings here. So it utilizes the open source some library, Lime and the Shape. These are the two it uses. On top of that, it gives the kind of flexibility on to use them on a scale, in the sense you can now use them on a Spark Apache Spark cluster, and you can do all the model interpretations on the large amount of data, or the model which you're building. So these are the whole capabilities it brings. I just highlighted into table here as well, and you can find the same into documentation. Okay. Now I will jump into the demo part, right? I will show you what exactly kind of capabilities brings. So yeah. Give me a minute. Sorry, just give me a minute. Let me share my screen.
You have turned off your screen sharing for twice. So just start sharing, and then everything's working totally well.
I'm just trying. Like, I don't know. Like, I'm clicking to share screen. It's
just ignore the message that you got at the bottom, and yeah, it should be fine.
Yeah, give me a minute. Can you see my screen? Yeah.
Yeah, just switch to your demo. It will work.
Yeah, is it fine?
Yeah, just switch to your demo. You can go on.
Yeah. Can you see?
Yes.
Okay, perfect. Okay, so this is the documentation of SynapseML, which you can go ahead, and it actually provides all steps, what kind of an installation, how to use it, in which platform it enables you to install, how to install it on Databricks, HD Inside, or Synapse, or how to use it. It actually gives you step by step, like how you can create your examples and whole tutorials around which kind of an area you want to do, like for cognitive services, how to connect, for isolation forest, how to use for anomaly detection, and that is how to use the libraries for responsible AI, and everything is available here, and it is a very good kind of a documentation and a step-by-step approach. Along with that, there's a GitHub, which is a SynapseML, and you can find here the whole project. Along with that, if you can go here, the notebooks, you can find here the ready to use notebooks for every not every, but most of the kind of regular the machine learning problems, you can find it here. And not only one example, but it has multiple examples as well. If you talk about the responsible AI, it has multiple different ways and examples. If you talk about the classifications, it has the different kind of an data sets and different kind of methods specified here. So yeah, this is a good documentation start. Now let me come to so if you go to the GitHub of SynapseML, and there is one option is you can use SynapseML with some Apache Spark platforms, right? You can use the Azure Synapse, you can use the Databricks or something. But suppose you are a developer and you want to try out without paying anything, right? You want to, because it's open source, you are looking for something without I should buy or install the whole Synapse cluster. How can I directly go ahead and start using the Synapse? SynapseML. So here is the binder. If you click to this one, it will launch this Jupyter notebook, right? This is the one. And wait a minute. Sorry, I need to restart this cluster. But there is called binder. You click to this binder, and you can take like it is gonna start one SynapseML whole Apache Spark cluster for you, and SynapseML is already been installed there. You can easy and go ahead and use it very quickly into this platform. So this is free and especially designed for the developers to go ahead and use it. So you can see like it's getting started, and we can use it easily. So still it is getting started. Let me take you guys to another one kind of an framework or a service called Synapse Analytics, which is available on Microsoft Azure, right? So you can find it here, and this is one place where Synapse. This is called Synapse Analytics. It is also big data analytics platform. It actually unifies everything. So here, instead of using different kind of an platforms for everything, like especially related to the storage of data, you are using a data lake or something, right? For processing or compute of the data, you use Apache Spark or something. So it is one of the unified platform where we can get all the options. So for data, it actually gives the flexibility to connect to the any kind of a database. You can connect to the Azure Data Lake, right? Or through the link services, you can connect to any other kind of your data store, right? And along with that, it gives you the flexibility to develop all of your work using the notebook way. These are the you can either use the SQL, or you can use the PySpark or the Python to create the notebooks. And along with that, it actually gives the flexibility to connect to other kind of services and the tools using the link services. So if you can go ahead and use the link services, it gives the many options. Which kind of services would you like to connect, right? There's some open source, some are related to especially related to Azure. So that way it is one of the unified kind of an platform. So here SynapseML, we can go ahead and create a notebook, and we can start using the SynapseML directly from here. So yeah, before that, let me see if yeah, it is still getting started. It takes some time, some minutes, because it's spinning the whole cluster for you. But yeah, in meanwhile, I will walk you through the SynapseML on Azure Synapse. So here, one thing is because it's a part of Azure, right? So some free kind of credit is available. If you sign up, you will get some free credit to use it. So yeah, some dollar amount. So that will help you to do your experiments. So let me take you first example is the one where suppose we want to use SynapseML on Apache Spark cluster, and we need to predict the flight delays. Okay, so there are some. Okay, I already created it, so I will walk you through this one. Yeah, okay. So now here you see first thing we need to start a Spark session, because SynapseML is built on the Spark ML or or Apache Spark, you first start your Spark session, and then you load down your all the necessary library. Along with that, you need to import the SynapseML library. SynapseML is nothing but like the machine learning library. So we need to import it similar way. So here, because we are using Azure Synapse, we don't need to install it. It comes with it. But if you are using any other platform, there is a simple ways we can go ahead and install it, which is provided in the documentation, the installation part. Okay, now once we install it, now here we'll be using open database or open data set of flight delays. This is a Parquet format, and I just printed like the schema. This is a schema of the data set, right? All these features, and you can see it's 490,000 records are available into this the data set, right? And some kind of in top few records I printed. So we can see here these are the records, and this is the arrival delay. So this is the column which we need to predict it. So now if you can move ahead, and here we are using the kind of an libraries to split the data into train and test format, which we split it here. 75% is training and 25% is for testing. And then once we move on, we can see here, like here we are doing little feature engineering in terms of there are some categorical columns which we need to transform into the numerical columns. So that is a kind of machine learning work, pre-processing, which we do. And here we are doing the same using the Spark ML libraries. We are doing a transformation categorical to the numerical, and with a temp as a prefix. And now here is the one which we are using the SynapseML library. You can see the SynapseML train. So we are using a trained regressor, and here we are passing the logistic regression model with the hyperparameters. With this hyperparameter we can change or whatever is our choice. And then we need to supply here what exactly the label column is. And when we call the fit method, we need to when we pass our train data set, it will start doing a training on our data. Okay, so once this training is done, right, now the next is we need to store the model, right? So storing the model, there is it's because of simplicity, it comes with some out of the box API. So it can detect the model is running on what. Is the model is running on Synapse? Is the training is going on Synapse? Is the training is going on Databricks or some running on some other Synapse internal or something? It can identify, then based on that it will save the model, right, with a MML extension. Now once this the model is saved, right, and now with a load method we can take the model. So you can disconnect it, like you save the model, and in another inference pipeline you are loading the model, right? Every time you need to forecast or predict, you can load the model, and once your model is loaded, the transform, the method name is transform, but exactly it is kind of prediction, right? So you are actually calling the transform method and passing your test data, and it is actually predicting your on your test data. Now using the train model. Now just top few records I'm printing on, and this is the prediction column which actually predicted. So this is your the label column, the ground truth, array delay, and this is your prediction. So this is the two kind of an which we can compare, right? So now to compare the how our model perform, we need to see some metrics. So here you don't need to print each and every metrics. You can call a compute model statistics, and then it will go ahead and based on the type of the problem, right? For classification, it's a different metrics. For regression, it is a different metrics. And for time series, it's a different metric. So based on that, it will print you the metrics which is specific to your model, how it model perform, and you can see it here. Okay, Now, if you need to improvise, you can go ahead and retrain the model for different hyperparameter or some algorithm change or whatever you want to do. Now, there are another good unified APIs available. The compute per instance statistics. This is also very useful in terms of suppose for every row, each and every row, we would like to understand how much the loss is, right? Using the L1 and L2 loss function. That's also you can create it. You don't need to write any custom program for that, or you don't need to write any custom function for that. So what you can do, you can, using this single API, we can pass on what exactly our ground truth is. We can just pass on our score data, and it will compute all the statistics for every record, for every instance. And then here we are printing what exactly the ground truth was, what was the prediction, and what was the L1 loss and L2 loss. So you can see it here. It's clearly it helps us to see for every record. So
Hi, Kundan, I'm so sorry to interrupt you. We're a bit over time, so
okay.
it will be great if you could wrap up in another minute so we can start the Q&A session.
Oh, sure. Yeah, perfect.
Thank you.
So yeah, thanks for that. And yeah, now similar like other problems, like this is the classifications. You can find it in the GitHub, but before and after the Azure Synapse, like so this is the problem which is solved without SynapseML, and here is the complexities and the kind of an the very lengthy way which was performed. And after Synapse, it is just in the 3 steps using the SynapseML, the same solution was achieved. So it is the power of some unified APIs. It makes the life easier for developers. Yeah, I think with that, thanks everyone.
Thank you so much, Kundan, for giving us this amazing presentation. It told us a lot about SynapseML. So I guess we have our other speakers backstage, so I'd like to invite them on the stage to have a Q&A panel. So welcome back, Mohan. Welcome back, John. So we do have a couple of questions for you. So I guess I'll start with John first. So the question is, are graph databases faster than relational databases?
I would say depends on your use case. Again, we talked about transactional. So if you're not doing complex data or traversing your data in traditional relational database, you're doing a lot of joins. Yes, it will be significantly faster.
So is there a certain like category you would work on if you want to specify that, okay, we can use graph databases or we should go for relational databases? Is there a certain category, and how should we determine such categories?
Yeah, so there's certain categories. When you have to do deep analytics or you have complex data. So I think from my healthcare experience, it was we had patient data, we had diagnosis codes, we had notes, we had time series data, we had prescriptions, we have all of these different data sources. And so the data systems in the healthcare space are highly complex, and we have highly complex data that all that data together composes into analytical insights. That's when you should traditionally probably use graph databases. But if it's like logs, you're just doing logs or transactions and there's not a lot of joins, then I would say relational database is just fine.
Okay. All right. So our next question is for Kundan, but I guess we can ask Mohan as well. So what is the difference between Databricks and Synapse? And Mohan, you could answer the same question for Redshift. So Kundan, would you like to go ahead?
Yeah, I can go next. So yeah, both are the kind of an big data analytics platform. So Microsoft Synapse is a first party product of Microsoft. Databricks is from a different company, but it is available into Azure, as we call it Azure Databricks, and maybe it is similar way it is available in AWS with some name, right? I can and it actually very similar kind of a product, but especially with Synapse, ML, with Azure Synapse, it gives you flexibility to connect out of the bricks, out of the box with other Azure capabilities, which is in-house for Microsoft, because it's a first-party product. So that kind of limitation we can see in the Databricks. Yeah.
Okay. All right. Mohan, would you like to answer the question related to Redshift?
Yeah, no, totally agree with Kundan's comment there, right? I think as it relates to Redshift itself, Redshift is more a data warehousing offering, right? A native offering from AWS, right? As opposed to Databricks and Synapse being other vendor platforms that sort of ties into Redshift from a data warehousing realm, right? And Databricks, I can't really speak to those two products as such, but I know for the fact that Databricks does come up with their own lake architecture frameworks to sort of tie into the broader AWS ecosystem, right? So it really depends on the core requirements as to what the customer has. They can very well do with just Redshift alone, perfectly fine, or they really have a strong enough use case to use Databricks and apps and Redshift in some way, shape, or form. I think it all really goes back to the core architectural needs and design requirements.
Okay, that makes sense. So our next question is for John. Among the learning resources you mentioned, can we design our own graph database?
Yeah, so a lot of those resources, they have a lot of introductions to building your first graph. I can send a lot of those resources out, or I can send them to you. I don't know if you send a bunch of resources out. Yeah, I would start at YouTube. YouTube, go to TigerGraph, do like TigerGraph 101, or go to our university.tigergraph.com, and you can find how to get started from zero. So that's where
Okay.
Yep.
All right. So this is one question for all of you. Like, we had this pandemic behind us. So how do you think the field data science took the pandemic as? Like, there were very many developments in the field. So how do you think the developments were done, and how developed do you think the data science, AI, and ML field would be in the next few years? I think we can start with Mohan.
Yeah, it's a very loaded question, right? I can share a lot of my insights. We all really went through very uncertain times for sure with COVID, and from a technology standpoint, it really took us a complete 360-degree change in terms of how we looked at the way technology operated, right? Pre-COVID and post-COVID. From an AWS lens, I can say for certain some of the areas that we really had to evolve ourselves were more around end user computing needs, where a lot of those traditional computing environments were on-prem. We had to really help customers get them on board on cloud. And that, when you really speak about end user computing, that also comes with the data storage, right? That they traditionally had stored in on-premises environments. So we had to really bring them over to the cloud platform on AWS, help them set up a data lake of some sort. And then from there on, depending on the customer's appetite, the use cases around AI ML sort of opened up. So customers that never had an exposure to cloud, never had an exposure to AI ML, they really used this COVID duration, the last 2-3 years phase as a way to really get going on cloud and AWS, right? So it's been a significant win-win for all parties concerned in a good way. Yeah.
That's correct. The pandemic has given us a lot of time to try and do a lot of stuff.
I'd also add on to that. I think the pandemic accelerated the field of data science, meaning that because of the complexities that happened with full nations shutting down, supply chain issues, all your analytics that were perfect before are no longer perfect. You have to reanalyze that data, how to get something from the supplier to the end manufacturer and the user, how to from the healthcare space, what are the side effects of COVID? What before COVID was even known to be COVID, we didn't have a lot of analytics, but we could track all the symptoms, all the different population data, and we could determine who had COVID before there was even a COVID label. So there's a lot of things and complexities and changes that happened and accelerated. I would say the data science field is in a higher demand than in any other time. So
yeah,
That's true.
completely agree.
Kundan, would you like to add something?
Yeah, I agree with Mohan and John, but I would like to add this is the time when we was not prepared, and the evolution which I saw from my personal my personal perspective, uh, especially related to the remote work. At some part we was prepared or we keep doing it, but especially related to schools, I saw that they face major challenges, especially in academics. If you think about the colleges, universities, and the school kids, even the especially the elementary kids, so they ramp up themselves so quickly into the new field. Especially you think about the any kind of an online meetings for education, right? And when you see this is one of the opportunity given to the data science field to improvise themselves, right? Especially how to better engage the kids, right? In class it's very easy or not easy but sometimes it is easy for a teacher to engage the kid, but when the same kids or same students are online on a different windows, how you can engage them, right? Easily. So there where the analytics, data science, AI comes into picture, which actually entertain them, engage them easily. So that's one of the education field which was semi explored or less explored. Now this is the time which given the boost to the researchers, to programmers, to the policymakers, so to not think about the remote working for the employees, but you can think of such situation where the university students or the elementary middle students, and the good example, if I say the examination, right? I saw that the kids are giving exam in front of a screen, so you definitely need such a system like prometric kind of thing, or supervise them, right? I went through one exam, and where when I was turned little bit or something, it identified me and say, okay, please be focused. So such kind of an innovation, more and more you can see in near future, and that actually boosted the brains of the researchers. Yeah.
Okay. Yeah, that's actually true. With online learning, their data science and MLAI have made it a bit fun. So we have one last question for Mohan. So what are the critical success factors for big data analytics?
Yeah, so success factors, you can really look at it from various different lenses, right? I think first and foremost, when you really talk about success factors from a business lens, it's really about performing the initial assessment, right? Start from the business objectives and work backwards from there in terms of identifying the readiness levels, what the maturity levels look like, and identify the type of data. As I kind of walked the audience through during my presentation, there are multiple different data structures that one can deal with, right? And determine the core primary use cases that the customer is solving for, and map those use cases to the right fit for purpose data elements or data services technologies, right? Doesn't matter it's AWS, whatever platform that you're working with, it's important to tie those technological elements back to the core use cases, right? And what is it the customer is wanting to do with the data? You bring the data centrally stored in a data lake, but what after that, right? What are the use cases for them? So I think those are some determining questions that you really have to ask your customers to really put them in the success path, right? And for you as an analytic expert, it's important for you to ramp up your knowledge on all various disciplines around data, be it analytics or AI, ML. And between Kundan, myself, and John, I think we have shared enormous volumes of assets, right, for this group to really ponder upon. So it's important to have a consistent, progressive learning around some of the latest and greatest in the data field. I think that will help you set you up for success in this journey.
Okay, that's true. That's an amazing advice as well. Like we have to learn every time down the line. So why not? So yeah, we have a question for John. Why is graph database not popular?
I don't know if it's not popular. I mean, it's been used and it's in production. It's used if you use like LinkedIn, Facebook, Google, Twitter, Pinterest. It's being used. I would say in the last few years, there's been more commercialization of having a product that anybody could use. So a lot of these big corporations had their own proprietary graph technologies, and just more recently, I would say the enterprise or decentralized capabilities of graph are now available for the general population. So, but it is a nascent field. The creators of SQL, the organization that defined that language, they're defining a new graph language called GQL. So that standard will be coming out. So it's gaining a lot of traction. So.
Okay.
There's just a lot of people using it. But it's not being taught traditionally in schools. And so my hopes is that you'll be interested. What is graph databases? You explore it, and there's tons and tons of opportunities. Huge high demand, and the industry is looking for more data scientists. So if you're looking for to set yourself apart, I would definitely look into graph data science.
Okay. All right. That's a great advice if you want to go be a little apart from people. So I guess we're done with questions. So thank you so much, Kundan, John, and Mohan, for coming to the summit today for our junior track. And with this was the last Q&A for the junior track, and we're done for the day. It was an incredible event, and thank you once again for taking out the time. So apart from you, I would also like to thank all our Geekle members and all the team for conducting this event. And the last 24 hours, every viewer who has watched us and streamed us, you all drive us always to look out for new developments of technologies, to digitalize the world and bring you all the new stuff that is happening to us. So yeah, thank you so much everyone for attending the junior track. Hope you attend the senior track as well and have a lot of fun, learn a lot. Thank you.
I want to join to thank you words, Smita. Thank you a lot, our speakers. It was great to work with you today, and I hope that we will meet on future events. And I just want to remember that Mohan will present a second session tomorrow, so please join and listen. I think it will be very interesting. Thank you, Smita, for your moderating today. It's a great job, and yeah, it's really a finished first day of our event, and I'm very happy to say it, and we are preparing for next 2 days. So please let me know if you will have any questions or comments to us or our speakers, and I hope to see everyone tomorrow, and have a nice day, evening, or night probably. See you guys. Bye-bye.
Thanks for having us.
Thank you, everyone. Bye.